Hi everyone.
Welcome to amazing channel of Brilliant Katha.
When you are rubbing one body with another body, electrons are transferred from one object to what? Another object. So this type of electricity is been given a name.
Halogen connected carbon sp3, then it's connected to benzene. See all of you, halogen connected. What is this carbon hybridization? Full single bond sp3. See then a benzene ring.
Denominator poles shouldn't be included in the denominator poles. That means the denominator, these -1 and -5 should never be included in the solution.
Homocircle caudal fin. It's giving two equal lobes. But in case of cartilage fishes, look at here, one big lobe is there, one small lobe is there. You cannot cut into two equal half this fin.
Brilliant Katha.
Hi students.
Hi.
Hello dear students,
So I think
join fast.
Join fast.
We can start our session. Those who have already joined, please give a thumbs up, dear students.
so. Yeah, Arnav.
Good
Arnav
afternoon.
is-
Yeah. They're coming.
I think almost our students are ready.
Ready. They're ready.
Yes. Hurry up
Yes,
students,
Nima,
join
Nima,
fast. We
Nima,
can start our
Atul.
session.
Hanna is there.
Nima.
Yes.
Atul is there.
Nima.
Yeah, Nima is there. Yeah.
Imra and Ola there.
Yeah, Imran. Yes.
Yeah.
Okay.
Yeah. So let's start, sir. I hope.
Yes. Dear students, welcome back to another live streaming of chemistry. Today we are going to do the marathon live. All the chapters we are going to discuss with important question. 100 questions we selected. So be active. We need your active participation throughout the session. Be energetic, okay, and be ready and tell everyone to join fast. We are going to start now.
Yes, good afternoon everyone. So we are going to start our Maha Marathon about our chemistry examination. So day after tomorrow you are going to face your first main exam, right? The chemistry is
Yes,
the
yes,
first
yes.
main
Most subjective.
exam. Subjective exam. So 70 mark, they're all chemistry, I think almost here they are asking simple questions. Only around 7 or 8 marks question they will make a twisted one. Remaining all question we can freely able to answer it. So how to present and which all are
What
the
to do.
important area, all of them. We will showcase you from each chapter which all important area you have to start first. Which all area have to be focused more. So be ready with one book, one pen. Because whenever we saying a reaction and all, whenever we showing a
Reaction
question,
Yeah.
before we doing the calculation, you should be ready with the answer.
Yeah.
That's what we are expecting. And that precious comments you can give in the comment
That
box.
energy, they
Yeah.
have to keep us there always in that energy.
Yeah.
Yeah,
And
maintain
also-
that energy level throughout the session.
We are starting this session by 3 o'clock. We don't know when it
When
is
we
going
will
to
end.
end because 10 chapters are there, 100 question, numerical, conversion, many theory, reasoning, many things are there. So be active all of you. It won't waste your time. So all of you give a good, what we can say,
Their maximum support.
maximum support and your love, your knowledge. Mainly we need your knowledge. What all things you know about the concept and all, what all things you learn in this 1 year. Please give your comment in the chat box. So I think
So we can
We
start.
can
I hope
start.
this is the Maha Marathon. So be ready with us. Be always support us. Okay. So let's start now.
yes,
So we
let's
don't
start
need to
all
waste
of
the
you.
time. Okay, let's start.
Are you all are ready,
All
right?
of you. Are you ready or not? Don't
Are you ready,
sleep,
guys?
Okay. It's a noon time, we know.
So we
Yeah.
can start. I hope.
Yes.
Yes.
Let's
Yes,
start.
sir.
Come on.
Yeah.
Now we are going to
Let's
start the live.
Yeah.
Okay.
Okay, sir. Let's start.
Yes. See, dear students, chapter 1, as you know, we are going to discuss important topics from solution chapter. See, these all topics you have to give more focus. Concentration terms, you know that one question will come based on the concentration terms, molarity based and all, or definition may come, you have to keep in mind that one. Henry's law is important, even we did so many numerical based on that one. Raoult's law, ideal and non-ideal solution based, concept based question will be there. Azeotrophs, colligative properties, you know that one, 4 colligative property you have to keep in mind based on that one. We selected few questions and those questions you have to practice, and the same type question you can expect. Van Hoff factor related numericals are there, and some logical based question, degree of dissociation and association based question, or that logical part also you have to keep in mind. These are the important topic you have to keep in mind. So we are going to the question. Hope you all are ready. Keep a pen, paper and be ready. So we are going to start. All the important point you noted down, you can do along with the solving and all. Whenever numerical come, we need your active participation. Don't be sit lazy over there. We need your answer and all in comment box. So we are going to start. So shall we start now?
Yeah, yes, sir.
Yes. See, question 1. Read the question carefully. 100 milligram of a protein is dissolved in enough water to make 10 milliliter of a solution. If the solution has an osmotic pressure of 13.3 millimeter mercury is the pressure unit given at 25 degrees Celsius, what is the molar mass of the protein? You know that one, molar mass of protein obviously will be a very high value, you know that one, that they are asking to calculate. So here we need to use the equation, the osmotic pressure equation. I am going to write the equation directly. Pi is equal to, okay, we can write directly WB into RT divided by MB into V. I will write directly. So volume, mass of solute into RT divided by MB into V. But you keep in mind one thing, R value has given in the bracket, but that in that R value, pressure is in ATM unit, but osmotic pressure here it is given. So I'll write on right side. Osmotic pressure pi is equal to 13.3 millimeter mercury. Dear students, millimeter mercury and the ATM pressure, that it should be equalized. You know that one, that can be easily equalized. So this one if they are giving, just divided, because we have a equaling ATM and it's given directly. So 1 ATM is equal to 760 millimeter mercury, even that is there in the question. So we can write the osmotic pressure pi is equal to 13.3 divided by 760, we need to divide. Okay, clear. So that 13.3 divided by 760, the answer will be 0.0175. Okay, ATM will come. This question we did so many times, even the values we can memorize. Not for you guys, I am telling. So you should solve and you should write the exact value, 0.0175 ATM. Once you get the osmotic pressure, I will substitute over here 0.0175 equals to WB they gave, but keep in mind again, WB mass is given in milligram, so is equal to 100 milligram, 100 into 10 power minus 3 gram, because everywhere we are taking gram. Okay, that also you have to keep in mind. So is equal to, we can write 100 into 10 power minus 3 can be written as 10 power minus 1. So I will take 10 power minus 1 into 0.0821. Temperature, you know that one guys, temperature T is equal to 25 degrees Celsius is equal to 298. Okay, so we have to add 273. So here we will be writing 298. Okay, so 298 divided by molar mass they are asking to calculate. So I will write MB over here into volume. Again you keep in mind that all conversion you have to keep in mind. Volume is 10 ml. So volume is equal to 10 ml is equal to 10 into 10 power minus 3 liter. Okay, so it will be 10 power minus 1 again is equal to 10 power minus 2 liter will come. Okay, 0.01. So we can write over here 10 power minus 2. So we will cut the value, or we can write now. See here MB is equal to, MB equal to 10 power, molar mass is equal to, we can write 10 power minus 1 into, this one we can write 0.0821 into 298 divided by this one 0.0175 into minus 2 will come. Now you can cut the value over here. Yes, so 10 power minus 2 and 10 power minus 1, 10 power minus 1 will be coming. Yes, 0.821 into 298 divided by, this will be 0.0175. Obviously, I think it will be a very high value. So that value also, that's what I told. 13963.4. Okay, it's gram per mole, that you keep in mind. Unit you should write clearly, should not make the mistake, they will cut your mark if unit is not there. Hope you got, how many of you got the right answer? You people are doing right. Hello dear students.
Yeah, 71
Don't simply say.
71 students are there, sir.
Ah,
Like,
good,
great to
good,
see.
good. Oh.
71 students are there. Nice,
Yeah,
nice.
we are so happy. This many students are attending. Okay, don't simply sit. We need your active participation. So write the question, values and all you can
they're
do.
ready. Satvik got the answer.
Yes,
Okay.
Satvik.
Yeah. Pooja also got the answer. Yeah, great,
Good,
great,
good,
great.
good. Great. Yeah.
Anna got the answer.
Anna.
Babu
Yeah,
also
yeah.
got the answer.
Yes.
Answer. Gujjuman also got the answer. Nice, Gujjuman.
Yes, Sanjay, do
yes.
the calculation. All you have to do, okay? It should be benefited ultimately. That is actually we plan such a session.
Asking, sir, do we always divide by 760? No, here they are telling 760. If it is
Yeah.
in ATM, you have to divide.
If they are giving the value directly in ATM, no need. 760 means the R value keep
They
in
are
mind.
in
Here,
milliliter.
yeah, ATM is given and even the volume is in liter. That's why milliliter we converted to liter. Hope you got, okay? Sharish,
Can
yes.
you explain how the temperature is 298?
Yeah, that is already we wrote 25 degrees Celsius is equal to 298 means 25 plus 273. So 25 plus 273 is equal to
Every
298.
time in SI unit
Oh.
you have to take in Kelvin.
Yes.
That's it.
All the time temperature should be in Kelvin. Okay, that you know directly. That's why I wrote 25 degrees Celsius is equal to 298. Yes.
Yeah, nearby answer is coming. That's no problem.
Yeah. It's
5%
yeah,
no problem.
more than 5% error only they will cut your mark. That it's fine anyway. That is
Everyone
yeah.
are telling, okay, sir? Okay,
Yes.
I hope they are
Shall we
happy.
go to-
Okay, we can go to the next question. Sir.
Yes. We will go to the next question. See, question number 2. Again, it's a numerical one. Solution chapter you can expect 2-3 numericals. So another one, a solution of glycerol. Formula has given in water was prepared by dissolving some glycerol in. So the amount of glycerol we need to find out. 500 gram of water. Solvent mass has given. This solution has a boiling point of 100.42 degrees Celsius. What mass of glycerol was dissolved? That's what I told. WB, mass of solute we are going to calculate. So mass of solute we need to calculate means first we need to take delta TB. So we have the equation delta TB equal to TB minus TB naught. Dear students, you keep in mind here
TB.
100.42 degrees Celsius is given. Whenever they are giving the temperature in degrees Celsius, the boiling point of pure water, we know that one TB naught is equal to 100, okay, degree Celsius. So here we will be taking 100 minus this one, TB is 100.42 minus 100 degrees Celsius, so is equal to 0.42, but this one is in Kelvin. Don't get confused because even though you are converting also, that we did so many times.
Change is same only. Degree Celsius or Kelvin?
Yes,
Same.
yeah.
But we have to take Kelvin now.
Exactly. So if you are changing also, that value will be same only. So that's why we are taking directly to Kelvin. After that, we will write the equation. Delta TB is equal to, okay,
WB.
directly KB we will write KB into WB into 1000 divided by MB into WA in gram. So that we will substitute the value we have 0.42 is equal to KB is equal to 0.512 into WB we need to calculate. So WB into 1000 divided by MBC, that is, yeah, you can memorize even, okay, glycerol. See, glycerol formula also given. Otherwise, I told in class you can C3H8O3. Few molecules. This will be 92. So many molecules you can remember, sir. For glucose and all, you can remember is equal to 180. You can you can memorize the value and you can save the time. Actually, okay. Glucose, even sucrose, you can memorize the value. Sucrose will be 342. Okay, that whole value will be coming. Okay, so that you can keep in urea. You can remember the value. 60. Urea is equal to 60. Okay, all are gram per mole. Anyway,
they
here
they can save the time.
Yeah, save the time. No need to find out. That all only 4 or 5 will come. That you can remember. So 92 into WA is given, dear students. It is 500. Here we can cut the value easily. So 1500 when it comes, it will be 2. So I'll take the WB. So WB is equal to 0.42 into 92. Divided by, this will come 0.512 into 2. So you can cut the value, yeah, you can cut the value over here. Even this value also you can remember 0.21 into 92 divided by 37.73. It will be gram. Even this value we did this one so many times that you can remember. Hope you people are doing over there. Yes.
They are asking the sir, why did they take the value in Kelvin for the first question but in degree Celsius for the second question?
Yeah, here it's a given boiling point of the solution is there in degree Celsius. See, I'm not telling that this should be in degree Celsius. You can convert into Kelvin as well, but the value will be same. That is
change.
Yeah.
1 degree increase in temperature means 1 Kelvin degrees.
Yes, we will tell you here if you are adding 273, right hand side also we are adding 273 or 273.15. Then left hand side same value means it's subtracting. Subtracting means the difference same value subtracting, 0 will come. That's why we are using the degree Celsius value directly. So we will be getting 0.42 degree Celsius, that is equal to Kelvin. If you are taking the same value, after converting to Kelvin also, value will be same. But when you substitute, we can substitute only Kelvin.
Yeah, got
okay,
it.
over here. Yeah, got.
So
Fine,
they're
fine.
getting the answer, yeah.
Yes,
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 sir,
all are,
yes, sir. All are getting the answer,
yeah.
yeah.
Sanjay, very
Sanjay
good.
is telling, Ardita
Yeah.
is also got the
Now
answer.
we have
Yeah.
85 people, sir. Thank you,
Yes,
thank
yes,
you,
yes,
dear
yes,
students.
yes, yes.
Yeah, be active.
That much support they are
Yeah,
giving.
yes, yes.
Thank you, sir.
Thanks a lot. Yes.
So Venkata Super
Yeah,
team what
Venkata.
colour, okay.
Yes,
So
yes,
that is
correct
the
only.
program then.
Yes, gram only. It's, yeah, 37 point. Very good, dear students. So we will move to the next one.
question.
Yeah. Next one also we have numerical, but before that you keep in mind here we have a question. That question is Raoult's law for a solution containing volatile components. How does Raoult's law become a special case of Henry's law? So Raoult's law, you know that one, everyone, you should expect that Raoult's law, Henry's law definition, it's very important. Azeotrope definition. These all are the definition question you can expect from solution chapter, dear students. Raoult's law for a solution containing volatile components says that, or statement is, you know that one, the partial vapor pressure of each volatile component is directly proportional to the mole fraction of the component. Okay, PA, partial vapor pressure of each volatile component is directly proportional to the mole fraction of the component at a given temperature. You have to write it in complete sentence. That is the definition for Raoult's law. Then the next one they are asking, how does Raoult's law become a special case of Henry's law? Listen, see, according to Raoult's law. See, according to Raoult's law, we can write this one with the solute. I will be writing PB is equal to PB naught into XB. I can write. Okay. According to Henry's law, we can write. According to Henry's law, we can write this is pressure P is equal to KH into XB. Again, we will be writing. XB is the mole fraction of solute. That solubility we are expressing in terms of mole fraction. See here, what is common? Here only the constants are different. Remaining everything is same. Here it is B only solute. So we know that one. What is Henry's law says that the solubility of a gas is directly proportional to its partial pressure. Okay, at a given temperature. Here only the constants are different. So how do you give the answer for this? You have to say that in Henry's law and Raoult's law, only the constants are different. Okay, remaining everything is same. And you can write these two equations. That will be the complete answer. So Henry's law, they are telling that Henry's law, Raoult's law become a special case of Henry's law, because in Raoult's law and Henry's law only the constants are different, remaining is same. Okay, so that is the answer, and you can write these two equations. That will be your 1 mark. Hope you got the definition and this one. Next one again, see B part we have a numerical, dear students. 1 gram of a non-electrolyte solute dissolved in 50 gram of benzene lowered. Yes, lowered the freezing point of benzene by 0.40 Kelvin, means they gave the delta TF. Okay, freezing point they are talking about, right sir?
Yeah,
yes, so delta TF they gave, delta TF is equal to 0.40 Kelvin they gave. Find the molar mass of the solute and KF of benzene is given. See dear students, it's easy. We can write the equation delta TF is equal to KF. You might have a doubt that, sir, why we are not considering the I? Because non-electrolyte I equal to 1. No need to consider I, no need to consider. Delta TF is equal to KF into WB into 1000 divided by MB into WA in gram. Okay, so we will substitute the value. 0.40 is equal to 5.12 is for benzene into WB they gave, it's 1 gram, it's easy. 1000 divided by, you know that one, molar mass they are asking to calculate. So we will write MB over here into, so mass is given, 50 gram. So here cut the value easily, so he will be
1050 we can cancel.
Yeah, here it is this one, here it will be 20. Okay, then MB we can write over here, so I'll write over here. So MB is equal to 5.12 into 20 divided by 0.40 will come. Yeah.
256.
So MB we are getting 256. Okay, molar mass. So 256 gram per mole we are getting. Hope you all got the.
Everyone are getting the answer.
Yes,
Sadhvi is getting, Mohammed Hisham is getting.
Yes,
Venkata is getting.
Imran.
Everyone are doing.
Yeah,
sir.
Hisham. Well done. Yeah, this is what we are expecting. Yes.
The same cooperation we are expecting.
Sure.
Once they are telling the answer, means we are feeling that much happiness, na? Yeah.
Yeah, all are there in active participation. Yes, good, dear students. Yes. Well done. Yeah, the unit.
Great to see.
Yeah,
Okay.
gram per mole unit. Every numerical that you keep in mind when you present your right answer with unit. That is very important. Don't simply lose the half mark. Yes, Abu.
Abu
Yes,
is also,
all are there.
Imran.
Thank
Yes.
you. And so we have a definition question over here. That definition question is define the following terms. You know, it's an easy one. Still, ideal solutions are solutions which obey Raoult's law at all concentration and temperature. So solution which obey Raoult's law at all concentration and temperature can be called as ideal solution. We know that one. Example also you have to keep in mind benzene and toluene, normal heptane and normal heptane. That all type of compound you have to keep in mind. Azeotropes, very important one. See, what are azeotropes? They are binary mixtures, okay, binary mixture solution which boils at constant temperature and they have same composition in both liquid as well as in vapor phase. So it is, yeah, so very important, azeotropes are, you keep in mind, azeotrope definition, okay, they are binary liquid mixtures which boil at constant temperature and have same composition in both liquid as well as in vapor phase, okay. Osmotic pressure. The minimum external pressure applied on solution side to prevent.
That they have to remember, solution side.
Yeah, solution side to prevent osmosis. Keep in mind all the definition means it should be in complete sentence. Should not write something over there. They won't give you mark. It's board exam. Keep in mind there is no lenient correction over there, and your teachers are not there. So that you keep in mind. Okay, paper will be in someone's hand. No idea. So that you have to present in the exact form. With
If possible,
clear,
if they want to draw the diagram also, it will be more appreciated.
All points you have to present nicely, okay. So osmotic pressure is the minimum external pressure applied on the solution side to prevent osmosis. All the points should be there, then only you will get the mark. Hope you understood. We will move to the next one. So question number, again, see, read the question over here, dear students. Again, we got the numericals, okay. Yeah, hope you all are interested to do the numerical questions.
They are putting the fire as well as love and
Yes.
once we are seeing Imran is also showing like this, okay.
Yes,
So that's
Imran.
the power, right? That's
Yeah,
the
all
spirit.
are there. Yeah, good. Ramanujan, we have the same
Ramanujan,
guy,
nice
all
to
the
see
live.
again, every live he is always
Yeah.
active only.
Yeah.
Ramanujan, okay.
Yeah. Faraz came,
Yeah.
yes, all are there. Now listen, define the following terms. Dear students, molarity, molar elevation constant. Molarity is defined as the number of moles of solute present in 1 liter of the solution. Molality, if they are asking, you know that 1 kilogram, okay, of solvent. Here it is number of moles of solute present in 1 liter of the solution. What is molar elevation constant? You know that one molar elevation constant, we have the equation delta TB is equal to KB into M. So this M when 1, then you know that one, that is KB is equal to delta TB. So M is equal to 1 means it is the elevation in boiling point of 1 molar solution. So whenever we are taking 1 molar, okay, molality, 1 molar solution whenever we take, how much elevation, how much boiling point difference, so that's called elevation in boiling point. How much elevation in boiling point comes, that is called molar elevation constant. Okay, unit is also important, so here keep in mind you will be able to write the unit. Hope you understood. I'll go to the numerical one, that is the B part. Listen, B part is a solution containing 15 gram of urea. This is what we told just before: urea, glucose, sucrose, glycerol, ethylene glycol. These all are coming. That value, if you can memorize, it would be better. A solution containing 50 gram of urea, molar mass as given, per liter of solution in water has the same osmotic pressure as a solution of glucose. Okay, see, both are having osmotic pressure same means isotonic. See, keep in mind, dear students, osmotic pressure same means pi 1 is equal to pi 2, then C1 is equal to C2. So here they are asking to calculate the mass present in 1 liter of the glucose solution.
So
both are in 1 liter. So here we will write normally N by V, concentration. So N1 by V1 is equal, V is equal to N2 by V. V will cancel. So we can write like this one, sir. WB divided by MB of the first one is equal to WB MB of the second compound. Second compound in the sense here they gave the compound
Urea
separately.
glucose.
Yeah, so we will write WB
First
of
one, urea.
this one. Urea mass they are
15
giving
divided by
15
60.
divided by
Molar mass
as
we
we
already
told
told
it's
there.
given. Yeah,
Already
it's
told
given
you.
60 is equal to WB. Here I think we need to calculate.
how to calculate.
Yeah, WB divided.
But
Glucose
glucose
already
180.
we discussed. Yeah, 180. So it's a quite
WB
easy.
equal to
WB is equal to 60 into sorry,
WB
180 into 15 divided by 60.
We can cancel
So
60
this
and
one,
180.
so it will be
3 into 15, 45.
45.
45 gram.
45 gram will be.
Yeah, they are getting
Easy
the
one.
answers.
Yeah,
They are
all are
telling
getting.
the
Yeah,
answer.
they
all are
already gave the answer. Very good. Well done. Well done.
Mahmood, everyone are telling that.
Yes, sure. Okay, all are there. Good, dear students. Okay.
So we can go to
Keep up the energy. So we will move to the next one. Sir, we have one more question, I think. A solution prepared by dissolving. Again, numerical came. A solution prepared by dissolving 5 gram of non-volatile solute in 95 gram of water has a vapor pressure of 23.375 millimeter mercury at 25 degrees Celsius. Calculate the molar mass of the solute. Vapor pressure of pure water is given. See, dear students, so we can do this one. I will add one page. Listen. So here they are asking to calculate the molar mass of the solute. So vapor pressure, keep in mind here 23.375 is the millimeter mercury, and the final vapor pressure of the pure water is also given same. So no need to convert. So same pressure only we will be using. Okay, mass WB is given 5 gram and the mass of solvent is given. Calculate the molar mass they are asking. So we can add a page over here. So we will write. So here we will write the equation. This is our equation. Keep in mind Pa naught minus Pa divided by Pa naught is equal to WB Ma. I am writing directly WB Ma divided by MB WA. So this is the XB. So XB you can write directly. So I will substitute the value. Here the value will be like this one. See, it's given over here. Pure value is 23.75. So this is 23.75 minus 23.375, right sir? Yes, divided by 23.75 is equal to WB is 5. Hope it is correct. 18 gram is the molar mass of water. MB they are asking to calculate. Mass of solvent, I think it's 95. These questions and all we did so many times. Yeah, it's correct, 95. See, values even so we can remember, sir, now. That many. So it's equal to 0.375 divided by 23.75 is equal to 5 into 80. That will be 90. We can write directly. So 90 divided by MB into 95. Yeah. So we will take MB separately. So MB is equal to 23.75 into 90 divided by 0.375 into 95 is coming. So the value will be, you can divide the value over here. So 23 point. So here the answer is 95.05 gram per mole. Hope you all got the correct answer.
They are telling 60 gram.
Wait. 0.375, 23.75, 90. Wait. Let us check the value once again, dear students. 0.375.
Yeah, 60 will come. 60 will come.
Wait. 23.75. Yeah, this value will be
60 only will come because
23.75 into 90. 90 and 90 approximately one will be, sir. So 0.3 into this one will be 60 gram per mole. Yes. Good. Yeah, same type of the values. Yeah, correct anyway. It's 60 gram per mole is coming. Correct. All this value. You have to do the very good. This is actually very appreciated, dear students. Yes, very appreciated. Yeah, good. Well done. Yes. Good. Well done.
So we have 95. If they are missing that kind of things, means that their mark will be reduced. That's
yeah. So here the right answer is 60. So we got this one. Now we will go to question number 5. Listen. See, question number 5. Write two differences between a solution showing positive deviation and a solution showing negative deviation from Raoult's law. Quite easy. So what is positive deviation from Raoult's law? Positive deviation from Raoult's law means, you know that one, what all things we can write. You know that one, PB greater than PB naught into XB we can write. Okay, so many equations we can write, and PA greater than PB naught into XA we can write. And you know that one, delta mixing H. Okay, delta mixing H greater than 0, or it will be positive. And delta mixing V, you know that one, delta mixing means when these two, delta mixing V, that also greater than 0 for positive deviation. Okay, so what is for negative deviation? So you know that one, positive deviation, this one you can keep in mind, the total vapor pressure of the solution is greater than that expected by Raoult's law. So Raoult's law, when we apply, we will be getting a value, but actual value is greater than. So any of these points you can write PB greater than this one, PA greater than this one, delta mixing H greater than this one, delta mixing V greater than this one, and we have one more point. What is for positive deviation? AB interaction is weaker than AA and BB interaction. So any points you keep in mind, and negative deviation what we will be writing? So we can write PB less than PB naught into XB, then PA less than PA naught into XA, then again delta mixing, okay, H less than 0, delta mixing volume less than 0, which means negative it will come. And as I told you, negative deviation, which means what? It will be the value will be, the vapor pressure of that such a solution will be less than that expected by Raoult's law. So that means the AB interaction will be stronger, okay, than AA and BB interaction. These many points are enough, I think, sir. So this much, yeah. Now we will go to the numerical one, okay, negative and positive deviation, differences, any difference you keep in mind that you can write. These points if you are writing, you will get the mark, enough, yes.
They're telling the answer, sir. AB
Yes,
interaction greater than A
yes,
interaction,
yes,
BB
yeah,
interaction.
yes,
That
correct,
will be
correct,
also
yeah,
like
that is it, yeah, that points you can write, that is an important, that is the cause of positive and negative deviation. Positive means it will be weaker AB, negative means it will be stronger, that you keep in mind. Yes, always.
Sir, the thing is that they are telling the answers for the next one also. That while we are saying we are that much happy now.
Yes.
Yeah, they are doing.
Now we will go to the
fast.
second one. Calculate the freezing point of a solution when 3 gram of calcium chloride, molar mass is given, was dissolved in 100 gram of water, assuming calcium chloride undergoes complete. Yeah, here we need to give one point for the students. Dear students, keep in mind this is the hint for considering which one? I means Van Hoff factor. Should not forget, then the whole calculation will go wrong.
Whenever they are giving the solute means that time they have to think about the I
Exactly,
value.
yeah. Wherever that statement is there, undergoing complete ionization or complete dissociation and all, that is the hint for
I value.
yeah, I value. That you keep in mind. See here, I think here itself we will write, that would be better. Yeah. So calculate the freezing point of the solution, 3 gram, okay, dissolved in 100 gram of water. This one they are asking to calculate the freezing point of solution. So we need to calculate the delta TF first. So delta TF I am writing directly, KF into, okay, so I also I'll write. So we can write I first. So I into KF into WB into 1000 divided by MB into WA. Okay, so here I will substitute the value. So when you are substituting, hope you can, it is visible for you guys. Yeah. So here I will substitute the value. So is equal to I will be using, dear students, here I we can take it as what?
CaCl2.
Yes, if you have doubt, I will write over here. It's visible, I think. CaCl2 on dissociation gives Ca2 plus 2Cl minus. So 2Cl minus means after dissociation we are getting 3. So 3 divided by 1. Because we have an equation, total number of particles after dissociation divided by total number of particles before dissociation. So 3 by 1 is equal to 3 will be taking. So that delta TF we need to calculate. So is equal to 3 into KF as given in the bracket 1.86 into. Yeah. Then WB we need, they gave, it's equal to 3 into 10 power 3 I will write 1000 divided by MB they gave, it's calcium chloride 111. 111 and into 100 gram. So 100 and this one can be cancelled. So we'll be getting 100 and 1000. So it will be 18.6. So the value will be.
They can get directly delta TF means we'll get 271. Directly they can substitute now that value.
Yes.
The difference they can get.
So this is the delta TF value. So this delta TF value we can find out over here. Okay. So it will be 3 into. Yes. Yeah.
That's enough. Let's wait, sir.
Yeah. I think they are giving the answer. Well done. Well done. Well done. So 271 point final answer I think they are giving. Yeah. I is equal to 3. Yeah. Well done, dear students. Yes. Abu, give the right answer.
It's actually 1.5.
See, sir, we have 13K subscriptions.
Yes, 13K subscribers, sir. This is a celebration mode, I hope. Anyhow,
thank you all. Thank you all.
We can celebrate.
Yes.
Yeah.
Thank you for your support, dear students. Yes, thank you for your support.
Because of their support only, we reach up to this limit.
Yes, exactly.
They have to share this video to your friends also. They are also writing CBSE board examination now.
Yeah.
You have to send them this link also to them also.
Yes.
So here, sir,
delta TF we are getting 1.5.
1.5.
Yeah. So here we'll be getting 1.5. So we can write the value over here. I will write directly.
1.5 will come.
So it's equal to 1.5. So 1.5 is the delta TF students. After getting the delta TF student, we have to substitute into this equation. I'll write over here delta TF is equal to TF naught minus TF. So delta TF already we got 1.5. You know that one delta TF TF naught is equal to 273.15. So here we can write that is 1.5 is equal to 273.15 minus TF. So we can write directly. So that is TF is equal to, when you are subtracting this one, 271.64. 65. Shall we? Yeah, fine. 271.65. Well done. Yeah, good. All has done. Yes, Hannah. Thank you. It's with you guys support only we reached this much
idea.
subscription. Yeah, thank you so
Everyone,
much.
they are actively participating, sir. We know that. We don't know when we are going to finish these topics. We don't know, but they are also doing that. That's the spirit.
Yes, all are there.
No, that's the spirit. That's Abu Ahmad. That's the spirit. Okay, Abu Ahmad.
Yes.
Yes, everyone. Pooja is getting the answers. Great to see that.
Yes.
Satvik already got the answer. Yeah, super.
271
Okay,
point.
sir, I
Yeah.
think we can move to the next one.
Yes. So here we have a few more sub question. Yes. That sub question one is measurement of osmotic pressure. See, sir, this is the very repeated question. I think measurement of osmotic pressure method is preferred for the determination of molar masses of macromolecules such as protein. Yeah. Keep in mind for all polymers. Okay. Yeah, that polymers like this one, any protein like polymers. Why we are depending on osmotic pressure? We have so many colligative properties, we are depending on osmotic pressure because of two reasons that you keep in mind. Whenever you use osmotic pressure, that only will have considerable value. As you know, osmotic pressure and molar mass are inversely proportional. So whenever protein like polymers you consider, their molar mass will be very high. So osmotic pressure will be very negligible. But in case of osmotic pressure, how it comes a considerable? Because osmotic pressure we will multiply into 10 power 5 and will take in Pascal. You know that one, right? So when ATM when you are getting, it will be into 10 power 5 Pascal. That all no need to write. This is your answer. This way I have to present. You have to write the first point. Only osmotic pressure will have considerable value. Second point. Osmotic pressure is measured at room temperature, so denaturation of protein can be prevented. All the other case we are heating, temperature increase, decrease, that may cause the denaturation of protein. In all the other case, osmotic pressure, there is no such variation in temperature, room temperature we are measuring osmotic pressure. So 2 point, first one, only osmotic pressure will have considerable value. Second one, you have to write osmotic pressure is measured at room temperature, so and denaturation can be prevented.
And molarity is very important. Molarity we are using instead of molality and that also easy method to calculate.
Yeah. So this one, these 2 points you have to write.
Yeah,
they are giving. Yeah, I think this is the final lab, no?
Yeah.
So they are in very
studied.
yes, large magnitude of osmotic pressure. Yes, very good, Smriti Ganesh. That is the key point, and the temperature measured at room temperature. Yes, correct. Yes. Yeah. Can the freezing point answer be
written in degrees Celsius?
Freezing point, which means here, no. These all different. Finally, we are taking here, we got Kelvin, dear students. 1.5 is Kelvin, that you keep in mind. Wherever we are taking delta TF, it will be in Kelvin. No doubt. Okay, it will be in Kelvin. So that Kelvin, when you are subtracting, means it should be in Kelvin. So 0 degrees Celsius.
If they are taking degrees Celsius means 1.5 degrees Celsius, that means here it will be minus 1 point.
Then you have to take
confusion.
That will be better. Better you can do with Kelvin. Yeah. Then don't take such confusing factor and all. Yeah. Yes. Now we can go for the next one, the last one. Elevation in boiling point of 1 molar KCl solution is nearly double than that of 1 molar sugar solution. Dear students, that is a very easy one. You can give the answer. You know that one, 1 molar KCl solution when we consider, you know that one, KCl means I factor is equal to, okay? Yeah, KCl means, you know that one, I factor is equal to 2. When it's a strong electrolyte, it completely dissociates to form 2 ion, I equal to 2. And what about for glucose, I mean sugar? Sugar, you know that one, I is equal to 1, it does not dissociate or associate. So it's a non-electrolyte, you know that one, I directly depends on which one? I directly depend on elevation in boiling point, because we have an equation of delta TB is equal to I into KB into M. Okay. So elevation of boiling point of 1 molar. Elevation in boiling point means, you know that one, delta TB directly proportional to I. I double, then the value will be double. So you have to say that elevation in boiling point is directly proportional to I. When I doubles, this value will be double. KCl has I2. These many points you have to write. Hope you got. Yes. Yes. Shall we move to the next question?
Yes.
Question number 6. Yeah, so many sub questions are there. So all these questions you have to go through. Okay. Later on also you can go through the video and you can check the answer. Give reason for the following. Dear students, aquatic species are more comfortable in cold water. Another repeated question, you know that one. This question is based on Henry's law. According to Henry's law, that would be the best answer. According to Henry's law, when temperature increases, solubility of gas in liquid decreases. So you have to say that they are more comfortable in cold water. When temperature is low, more oxygen will be dissolved in water. So that application you write, according to Henry's law, when temperature increases, solubility of gas in liquid decreases. So at low temperature, more oxygen will be dissolved in water, that is will be comfortable. At a higher altitude, people suffer from anoxia resulting in inability to think. That is again Henry's law's application. You know that one. At high altitude, osmotic pressure is, atmospheric pressure is very less. So less oxygen will be dissolved in blood. Therefore, it causes anoxia. So that 2 point, high altitude, atmospheric pressure is very less oxygen will be dissolved in blood. These 2 points should be there. Okay, hope you got. Next one, what type of azeotropic mixture will be formed by a solution of acetone and chloroform? Okay, it's very easy, you know that one. Dear students, acetone and chloroform, when you mix together, it forms a solution having negative deviation. Why it is negative deviation? Because you know that one, acetone you can write like this one, CH3, C double bond O, single bond CH3, acetone, chloroform if you write, you can write CH, and here it is Cl, CH, Cl3, that is chloroform. You know that one, yeah, intermolecular hydrogen bond. So here we can say that AB interaction is stronger. So wherever AB interaction is stronger comes, you know that one, it shows negative deviation from Raoult's law. So what type of azeotropic mixture? So what type of azeotropic mixture they are asking? So what will be the answer? Minimum boiling or maximum boiling they are asking. So this will be negative deviation means maximum boiling azeotropes. Okay, this will be negative deviation. So your answer should be maximum boiling azeotrope. Okay, by a solution acetone. Justify on the basis of strength. That is what you have to say, that between acetone and chloroform, intermolecular hydrogen bond will be formed or AB interaction is stronger. So they show what type of deviation? Negative deviation from Raoult's law. So that azeotropes are called maximum boiling acetopes.
In the just reverse case, positive deviation means they will break the intermolecular hydrogen bond.
Yes, wherever this one positive deviation comes, intermolecular hydrogen bond breaks. So they produce more vapor pressure.
That kind of question also may come.
Yeah, so azeotropes will be opposite. Minimum boiling azeotropes will be coming. Okay, that you have to keep in mind. Yes.
They are telling the answers, sir. Great
Yes.
to see. Yeah.
Yes, yes.
Okay.
So now we will go to the next one. Question number 7. See guys, again it's a numerical question. See, a solution containing 5.85 gram of NaCl per liter solution. It has an osmotic pressure of 4.75 atm. See here it's atm, it's given, no need to convert. At 27 degrees Celsius, that should be converted to Kelvin. Calculate the degree of dissociation, which means I we need to calculate. It's another type. So we can write like this one, pi is equal to I into, we can write the equation directly, sir, WB into RT divided by MB into volume. Okay, so we will substitute the value, you know that one pi value has given, so we will take that one directly. Osmotic pressure is 4.75 is equal to I we need to calculate. I into WB is 5.85 into R value has given 0.0821. Temperature, dear students, it is 27 degrees Celsius is equal to 300 Kelvin. No need to add, I think, you know that one, it is equal to 300, 273 we will be adding. Divided by molar mass,
NaCl 58.5.
so molar mass 58.5, you know that one, right? MB of NaCl, even that you can keep in mind. So 23 plus 35.5 is equal to 58.5 gram. Okay, so into volume is given
per
in
liter they are telling.
per liter I think
NaCl
somewhere
per liter
per liter is given, so it is 1. So you can cut the value easily over here. 5.8, this will be 100.
100 will be 100 and 300.
It will be 10, sir. 5.85, this one 1 by 10 it will be.
10
So
this
I is
300 we
equal
can
to, this one and this one we can cancel.
So I is
So
equal to
I will be equal to 4.75 divided by, this will come 0.0821 into 30.
divided by 30.
Okay, so
Approximately
I value will
1.92
be,
come.
I think people are giving,
1.93.
yes, I think I is equal to, here
1.93.
don't take I is equal to 2. That will be a wrong one. That should not make the mistake. That only you can take whenever they are giving complete dissociation. Here they are asking degree of dissociation, means, dear students, that is a hint that it's not going to dissociate completely. Okay, if it is completely dissociating, they should not ask, because completely means that 100% will dissociate. So they are asking degree of dissociation means it's not dissociating completely. Theoretically we can say 1.93, well done, well done. So 1.93 is coming, the answer.
Then alpha.
Yes, after that I when you are getting, you know that one, we have an equation for dissociation. Alpha is equal to I minus 1 divided by n minus 1. So is equal to I, we have 1.93 minus 1 divided by n. Don't here is the value comes NaCl when dissociate you will get Na plus Cl minus. So here it is the 2. 2 by 1 is equal to 2.
2.
Yeah. So we will be
So
substituting
number
2
of
minus
ions
1.
produced, that's enough.
We have the equation, no? Total number of ions after dissociation divided by total number of ions before dissociation. So 2 by 1 is equal to 2. So 1.93 minus 1 divided by this one is equal to 0.93 divided by 1, or we can write 0.93. They did not ask percentage, so just you have to write 0.93. 0.93, I think, yeah.
Into 93% also,
If you are writing also, but yeah, did not ask the percentage, they are asking calculate the degree, which means if you are writing 0.93. If you are writing 93 also, they won't cut your mark. 90.93 is enough.
Everyone are telling the answers, sir, before they are doing itself. That means they are in the last lap, I hope.
Yes.
They are in the whatever.
Even
we
are happy to see this answer here, dear students. Yes.
This is the thing we are expecting.
Yeah, something it has happened like all our effort. You people has taken in the positive manner, and so happy we are, dear students.
So when we should use R equal to that whenever we are using SI unit, that time only we have to use that one. Here they are telling in ATM, so that's why no need.
That 8.31 will come only in joules. Joule case.
Only.
Joules.
SI unit
Wherever joule we are taking means any answer delta G naught whenever it comes. Okay, that all cases only 8.314 will come in case of joule, because unit is in joule. Here all the case, and moreover they will give the value, same value only you take 0.081.
Satvik,
Yes.
Deepak sir will come. Okay, Deepak sir will come and join. Don't worry. Okay. Yes.
Yeah.
Great. Okay.
Yes, 90. Yeah. So we got the 0.93. That is the value. Yes.
So we can go to the next one.
Yes,
sir.
yes, sure. So question number 8. See, question number 8 is Henry's law. They are asking. See, state Henry's law. Why is air diluted with helium in the tanks used by scuba divers? See, Henry's law already we discussed. Henry's law states that the solubility of a gas in a liquid is directly proportional to the partial pressure of the gas at a given temperature. It should be in complete sentence. Okay, solubility of a gas in a liquid is directly proportional to the partial pressure of the gas at a given temperature. And why their scuba divers are carrying a air diluted with helium? You know that one, at deep to the sea, or when they go to the bottom, you know that one, pressure will be very high. High altitude, pressure is less. At low altitude, pressure will be very high. Then more oxygen will dissolve in blood. It exerts more pressure on the walls of the blood vessel. It causes a severe pain called bend. You know that one, right? So you have to say that to prevent the severe pain, bend, okay, on the walls of the blood vessel, air will be diluted with the helium. And one more point, helium is insoluble in water. Helium is insoluble in blood. Okay, oxygen soluble in blood, oxygen plus helium they will be adding, but only oxygen will dissolve and helium will not dissolve, so it will not exert that much pressure. Otherwise, only oxygen inhale happen, more oxygen will come to the blood, that will exert more pressure on the walls and it causes a severe pain called bend. So 2 points, first one, to prevent the pain called bend, and the second point, helium is insoluble in blood. Hope you got. According to Henry's law, application is this one. Yes, I think all, yes, Atul.
Atmospheric gases will be
Yes, yeah,
dissolved.
to prevent the bend. Not only that point, you have to say the second point, it is insoluble in blood. Which one? Helium is insoluble in blood. Yes, air diluted with helium.
So
Yes.
FR1SK anoxia, we already told that will happen at a low pressure. At a low pressure condition.
High altitude.
At a high altitude.
Anoxia is in high altitude. High altitude means atmospheric pressure is very less. Less oxygen will dissolve in our blood.
Anoxia,
That,
absence of oxygen.
that fainting tendency is called anoxia. This is deep to the sea. At the bottom of sea, atmospheric pressure will be very high. Means altitude when increases, atmospheric pressure decreases. Okay, going down means pressure will be very high.
Pressure will be increased, solubility will be increased.
Yeah, more pressure means more oxygen will dissolve in blood. That is also very harmful. More oxygen will dissolve in blood means that exert very high pressure, that cause the blood vessel has pain.
Submarines and all
Exactly, that one. Okay. Yes, Benz. Yes, we will go to the next question, question number 9. We have 2 more questions from this chapter. Each chapter we selected 10 questions, 100 questions we have. So be active over there, and we need your same energy level throughout the session. Dear students, next question is, this one we have done so many times. Still, when 19.5 gram of fluoroacetic acid, molar mass as given, is dissolved in 500 gram of water, the depression in freezing point is observed to be 1 degree Celsius. See, here should not get confused. This is the very repeated numerical question. calculate the degree of dissociation. Okay, that's why we selected this one. Yes, fluoroacetic acid. So what you need to do over here it is, we need to find out the I first.
Degree,
Okay,
first I
so
got
delta TF I will write directly is equal to 1 degree Celsius equal to 1 Kelvin. It's same only. So we can write the equation. So delta TF is equal to I into KF into WB into 1000 divided by MB into WA in gram. So we will write the value. So 1 is equal to I we need to find out. So KF they gave, so 1.86 into W we have 19.5 into 1000 10 power 3 I will write, divided by molar mass has given, that is 78. 78 into mass of solvent. Mass of solvent is given, that is 500.
500.
So 500 and 1000 we can cut the value. So it will be 2 over here. So I will write I is equal to 78 divided by 1.86 into 19.5 into 2. Okay, so here also we can cut the value. This one will be 39. So it's equal to 39 divided by 1.86 into 19.5. I think
So
people are giving the answers.
1.07 will come. 1.07
Yes.
will come.
Very good, very good. 1.07 is the I value.
1.075.
07 is enough. I think after decimal 2 places are there means it's very
That's
good.
enough,
Yes,
that's
yeah,
Everyone
1.07.
are telling the answer. 1.075. Yeah,
Yeah.
great to see that.
Yes, very good,
great,
very
great,
good.
great.
So once we get the I value, dear students, it is
Alpha.
dissociation. Dissociation means we have the same equation I minus 1 divided by
n minus
n
1.
minus 1. So we will substitute the value 1.07
Minus
1 divided by
n we
this
have to
here.
find
Yeah.
out from this.
Here I will write the equation, that is FCH2COH. Dear students, when it dissociate, you will get FCH2COO minus plus H plus. Every carboxylic acid will dissociate like this one. Here it is 2. Okay, 2 and initially 1. So 2 by 1 is equal to 2. So n equal to 2. So I will substitute over here. 2 divided minus 1 is equal to 1. So answer is, you know that one? Yeah, so 1 point. So 0.07 is the answer. They did not ask the percentage.
So
Only they are asking
0.07. Yeah.
0.07.
Everyone are getting.
Yes.
Sanjay Menon, great to see that. Okay.
Yes, Pooja, all are there. Yes.
Mohammad Isha,
Atul
Hanna.
is alpha we
Yeah,
got
Ansar,
0.07.
Nice to see
Yeah.
you.
So we did so many
Ashmita,
sessions for
everyone are getting,
numerical. So yeah, Ashmita, yes, yeah. So all are there. So should not lose the mark from the numerical side. Okay. So we will go to the next one, dear students.
Yeah,
This is the last question from
question.
this chapter, solution chapter. Listen. The vapor pressure. See, another type of question, vapor pressure based. The vapor pressure of pure liquid X and pure liquid Y at 26 degrees Celsius are 120 millimeter mercury and 160 millimeter mercury respectively. If equal moles, here should not get confused, dear students, they are telling equal moles of X and Y are mixed to form an ideal solution. Another hint, ideal solution. What is the equation? So, ideal solution, you know that one, ideal solution we can write total pressure, okay, PT is equal to PA plus PB. So what is PA? Is PA we can expand it as PA naught into XA plus PB naught is equal to PB equal to PB naught into XB. Clear? PA naught has given, dear students, PA naught is equal to 120 into XA not given. But XA they gave a hint, listen, both XA is what? Mole fraction of solvent. But number of moles are not given, but they gave one hint, moles are equal. If you are taking mole of A as X, then the mole of B is also what? X. So X plus X is what? 2X.
2x.
X by 2X is equal to what? 1 by 2. So what is same for XB? XB is equal to same is equal to 1 by 2.
1 by 2.
Because fraction 1 is 0.5 means obviously the other
second
should be
one also 1 by 2.
0.5. No need to write even. So here I will multiply 1 by 2 plus PB naught has given I think 160 into 1 by 2. So here we can write 60 plus 80. So here it is 140, correct
140
sir?
will come.
Millimeter mercury. So right answer. I think all,
Yeah,
yes,
everyone are getting
total,
140,
yes,
140.
140.
Yeah, correct only, everyone are telling.
Yes.
We solved in the question previous class.
Yes, Satvik.
Yeah.
That is what I told. Most of the answer we know already. That many times we these numerical. Yes, Ashmita, correct.
Yeah,
Yes.
even though they are doing along with us means that's the happiness, sir. Nothing more to tell.
Yes.
Great,
So
great
I
to
think the solution chapter now you have confidence.
see.
What all answer?
10 question DKs are already did. I hope you guys are happy with that. Yes or no? Tell me. Show the
Yes.
power in the comment
Yeah.
box. Yes, please.
Sir, you should be confident the chapter, that is the main point.
Yeah.
Yeah, how many? Yeah, I think.
9-hour sessions. You already did like that. They're telling. Yes, great to see. Great
Yeah,
to see.
yes, Anna, we did a 9-hour
Yes, sir,
session
yes,
before.
Sir, yes, sir. Great. Okay. You have
Yeah.
to show that affection with love as well as fire. Okay.
Yeah,
yes, it's coming.
Yes, 60
Okay.
questions we finished on that day. So I think numerical this time, no one is going to make any mistake.
Yes.
Salman, yes. Thanks
Okay.
a lot. Yes,
So
all are
I
there.
think
yeah.
we can go to the next.
Yeah,
one.
we did in 9-hour
9-hour
session.
session. Yeah.
Yes. Yeah, let's see. It should be there in the paper day after tomorrow.
They have
That
to
is
be.
what we are expecting.
Yeah.
Yes.
Yes, sir. Okay, sir.
Yes.
Shall we go to the next one?
Yes, we will go to the next chapter.
That's
Again,
correct.
electrochemistry. We will continue. Okay, Deepak sir will be joining. Okay, you students can wait, listen. So, see, electrochemistry, what all points? Yes, Hanna, thank you a lot. Thanks a lot. Thanks a lot. Yes. Yeah. Now we will go to electrochemistry chapter. See, electrochemistry, what all points you have to, what all area you have to give more focus. Electrochemical cell and electrolytic cell. Okay, Nernst equation based thing gives energy. That equation numerical, conductance, conductivity, molar conductivity and limiting molar conductivity. Okay, then Kohlrausch's law based numerical definition, applications of Kohlrausch's law important. Faraday's first law, second law, numerical. Product of electrolysis, okay, cathode and anode, what will be deposited, okay, inert electrode and active electrode, both. Batteries, primary and secondary batteries, important. Every question paper, 2-mark question you can expect based on battery. Corrosion, it's the last part, you know that one. Corrosion is an electrochemical cell. Okay, I'm not wasting time, we will go to the question. Yes, dear students, yes. Yes, Jamshed, all are there. Yeah, now we will move to the question number 1. Hello, dear students, listen here. Question number 1 is state Kohlrausch's law. Yes, I know that one. It's the very expected one. Definition, Kohlrausch's law states that the limiting molar conductivity of a weak electrolyte is the sum of the individual contributions of all cations and anions present in the electrolyte. Okay, for all cations and anions, that lambda m naught value, when you take the sum, you will be getting the value. So that statement you have to write. Limiting molar conductivity of a weak electrolyte is the sum of the individual contributions of all cations and anions present in the electrolyte. Here one more part is there for the question. The molar ionic conductance of Ba2 plus and OH minus I are given. They are asking to calculate the BaOH twice. So it's easy, students. BaOH twice you can expand, dissociate. Then you will be getting Ba2 plus 2OH minus. So just we have to write the equation, students. Lambda m naught of BaOH twice, okay, is equal to lambda m naught of Ba2 plus lambda m naught of 2 into, we can write 2 into, yes, that number is coefficient is there, that will come over here. Okay, so we'll write Ba2 plus, they gave directly. Ba2 plus is 127 plus 199, right, sir? Yeah, so here it will be 2 into 199. So this is the answer. I think they gave the answer already. Yes,
525.
Correct answer. So correct answer is 525 Siemens centimeter square mole raised to minus 1. Should not miss the unit. It's very, very important. Okay. Yes, Ashmita,
Yes,
very
yes,
good way.
Venkada,
525
Venkada,
Siemens
yes,
centimeter
advanced,
square
yeah.
mole raised. Yeah. Whenever you write the answer, keep in mind along with one unit is there. Okay. It's like a combo thing that you have to keep in mind. Not only answer.
Sir, the happy thing is that still now there are 80 members are always present in the
Yes,
live.
good,
That
good.
is a very, very happiness thing now.
Sure,
Yeah.
sure. Yeah.
Keep the spirit, okay, guys?
Yes, so we will go move to the next question,
Next
sir.
one, next one,
Yes,
next one,
question
yeah.
number
Fine.
12. See, question number 12, almost all area we put the question. Keep in mind, next is calculate the maximum work. Dear students, what is the maximum work they are asking? Maximum work is delta G naught. So they are asking to calculate the delta G naught. We have the equation delta G naught equal to minus NF E naught cell, correct? So E naught cell is not given, that we will find out separately. E naught cell, we have an equation. E naught cell equal to E naught of cathode minus E naught of anode. So higher value always will be cathode, that is no doubt. This is the higher value. 0.80 minus of minus, here it is given. So 0.25. So we will be writing 0.80 plus 0.25. It will be 1.05, correct, sir?
Yes,
1.05 volt.
1.05 will come.
So even these type of practicing means you can remember the value even, okay, but should not make mistake with overconfidence and all. That is important thing.
1.05.
Once you get this one, you can substitute the value and see what is the n over here. N means always you can, this one and this one you can multiply if you have doubt. Same only. Yeah. In any equation you can multiply this coefficient and the chart. That will be the n value.
So
any doubt
2.
means, okay, if a different equation comes. So we can substitute the
2
value,
into
minus 2 into F is given 96,500 into 1.05. So I'll write over here minus 2 into 965 into 105. So it will be minus 202, yeah, even the, yeah, 650,
will come.
correct? This much joule. If you want, you can write it in kilojoule, minus 0.2650 kilojoule. So better you should write it in kilojoule. That's SI unit, okay, of delta G naught.
That's the answer.
Yeah, that is that.
Everyone are getting, sir.
I think all, yeah.
Yes,
One more
great.
part we have, sir, for this question. So we will continue. I think this is a easy. We are not wasting the time. Yes, yes, Abu, correct. Yeah.
Great.
So log Kc we will be going. So we have the equation, dear students, that is E naught cell is equal to 0.0591 divided by n log Kc. So I'll write the equation, dear students. We will write directly the equation log Kc equal to E naught cell into n divided by 0.0591. So we can substitute the value.
1.05.
Yes, here it is 1.05 into 2 divided by 0.0591. This one
So
when
that
you
is
divide, this is
35.6.
also we did 100 times, I
35.6.
think 35.5.
Fine, okay.
Log Kc has no unit, 35.5. This one, yeah, this one also we did the same question. Yes, Ashmita.
Everyone are getting now?
Yes.
Sir, is the answer is positive or negative? Answer is positive.
Yeah, here it is. This delta G is not negative always. Delta G naught is
Delta G is
always
negative.
negative. Delta G naught is always negative.
Because that's when only it is decreasing now.
Yeah,
So
yeah.
energy should decrease.
Energy should emit. Okay, spontaneous.
Then only that
cell
the
will
cell will work.
Yeah, that's the logical thing. You know that one. Cell is a spontaneous cell. Spontaneous reaction means
We are talking
energy
about
should emit.
galvanic cell only. So that time we are using the energy. That's
Yes.
why energy will liberate.
Yeah,
Delta G will
energy
be negative.
liberating means delta G is
Because
equal
of
to
electrolytic cell means we have to use the
opposite.
energy.
Yeah. So there we are supplying energy. Here energy should come out. Yes, dear students. Yes.
Radiate casually selling, sir, can you tell formula for degree of association? That is
Radiate cash. Yeah, sure. We can write. So I think that is the previous chapter. Okay.
Yeah, that's
So
that you can write
here
that
I'll write.
alpha
Okay.
equal to
No problem. Degree of association. It's very easy. I'll tell an easy method to remember. Numerator you keep in mind. Degree of association alpha is equal to I minus 1 divided by 1 by n minus 1.
That's it.
How you can remember easily means only the thing is that n instead of n
Previous
you
case,
take
n
1
minus
by
1, here 1 by n minus
1 by n.
That's
That is the easy one you can remember. Okay, I minus 1 divided by 1 by n minus 1. That you keep in mind. Yeah.
Anti-log questions will come means that time they will give you the answer.
Yeah, Sanjay, anti-log they won't ask. That is why they are giving the, because anti-log they are giving the value means that is the right directly the answer.
Directly the answer.
So that type of question, even the CBSE question paper, previous sample papers and all, they are giving the log case only. If they are asking means they should give the anti-log part. So
That part
no
they
issue,
will
that
give,
value
no
you have to write directly. That's it. Okay,
sir.
shall we move to the next
Yeah,
one?
next question,
Yeah,
sir.
this is from the previous chapter. Okay, so here I will write it separately. Fine. So we will move to the next one.
next
Yeah,
one.
question number 13. So question is the electrical resistance of a column of 0.05 molar kaoid solution of length 50 centimeter and area of cross section 0.625 centimeter square is 5 into 10 power 3 ohm. Calculate its resistivity, conductivity and molar conductivity. See, almost all
Direct formulas
direct
only.
one come, but keep in mind this type of question they asked in previous cases. So here first we will write what they are asking, sir. So resistivity I will write directly rho is equal to R into A divided by L. Okay,
Directly we can
so we
calculate
can
the
directly substitute resistance as given 5 into
10 raised to 3.
10 power 3 into
Area
A has
cross-section
given
0.625.
length is equal to area of cross section 0.625 divided by 50.
Length is 50.
Yeah, so here I can think
can
we can
cancel.
cut the
50
value
and
over
5
here.
we can
50 and 50 we can cut.
10
100 will
square
come.
will be coming.
It will be
62.5.
62.5. Hope you all got resistivity. Yes, so
Yes.
here we will write
Then,
the unit ohm. Okay, here it will be centimeter.
Ohm
Don't
centimeter.
get, yeah, because a centimeter square and this one. Ohm
Yeah,
centimeter
ohm
is a unit. Yeah. After that they are asking, sir, what?
They are
Calculate
asking
the
conductivity.
yeah, that I think we can
Directly
directly,
1 by
yeah.
rho.
Conductivity is equal
Kappa,
to
1 by rho.
reciprocal of resistivity, 1 by rho. 1 by rho means is equal to 1 divided by 62.5. So 1 by 60,
0.016.
yeah. So 0.01, 0.016 will come. Unit is equal to, you know that one, conductivity
Just opposite.
Siemens centimeter raised to minus 1. Because
Just
ohm
opposite,
inverse, yeah.
ohm inverse.
Ohm inverse is
Siemens
Siemens centimeter raised to, yes.
Yes, great to see that.
Yes, yeah. All you got. I think one more is there.
Lambda
Molar
m.
conductivity.
Lambda
Molar
m.
conductivity lambda m is equal to K
Kappa
into
into
1000 divided by C. So is equal to K already we
Kappa,
got is
there you
equal to 0.016 into 10 power 3 divided by
C,
concentration, I will write 5
0.05.
into 10 power minus 2, I will write, correct?
Now we can take it
So
to top.
here, yeah, here we can write the value. So 0.61, it
Can
will
go to
be,
top.
yeah,
320
here it will be
320 will come,
16,
sir.
yeah. 16,
we can take it 16.
divided by 5 into 10 power 2,
So 320.
correct? Yeah, it's equal to 320.
320 will
Yeah,
come.
320 Siemens centimeter square, mole raised to minus 1.
raised to
Hope you
minus
got
1.
the answer. 320, I think, yeah, all are giving. Yes,
All are
Abu,
getting the
correct,
answer,
correct.
Sanjay.
0.016.
Yes.
Conductivity is reciprocal of resistivity.
Yes,
After that,
yes,
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 Salman
yes.
Shihab. 620, check your answer, please.
Great.
Yeah, Salman, check your answer. Venkat.
So
Venkata,
everyone
correct.
are only telling the answers. Along with that, you don't forget to write the unit also. That's
Yeah.
important.
That is what
That's
I'm telling.
important, yeah.
Wherever right answer you are getting, should not simply lose that half mark. Every right answer with unit.
So I think our students won't give the chance to lose it, sir. They are showing that much confidence in the answer. Comment box, I think.
Yeah.
Yes or no? Yes or no, guys?
Yes.
Show that heart and love and fire and all in the comment box. Yes, please.
Yeah, be confident and calm in the exam hall and write everything, okay? Yeah. So don't be panic and all. Yes.
Now they started, I hope. Okay.
Yes, Siemens
Yes, sir,
centimeter
yes,
square
sir,
mole
yes,
raised
sir,
to minus.
yes,
Yes, all are
yes,
getting.
Mohammed Isham, great to see that. Okay, Pooja, Ash, okay, great to see that. Yes. Power.
Okay,
is coming.
shall we go to
Yes,
the next
yes,
one?
we can go to the next one, sir. Yes,
Question number 14. Dear students, another type of question. Listen here. How much charge in terms of Faraday is required to reduce the 1 mole of? This question also we did. It's very easy. Listen here. I think the question is correct, right? 13 we did, then 12. Yeah, correct. So question 14.
I think 13.
Yeah. So that is what we are checking. Any question we missed in the sense? So
11,
question number.
11.
Yeah.
11, 12, we did already.
13.
12,
Yeah,
I
here.
think, yeah.
Here conductivity. Here we missed.
Writing the
Yeah.
points, yeah, that's one more.
Okay.
B
See,
is
listen. Yeah. See here, one question is there. Yes. Dear students, listen. There is a part B that we did not consider. So predict the product of electrolysis of an aqueous solution of CuCl2 with a platinum electrode. This is what we discussed in the point we gave. See, platinum electrode means you know that one. It's an inert electrode.
That's an inert electrode.
Okay, inert electrode wherever you're using with the value or otherwise also you can do. We can tell a logic, sir. First, you know that one CuCl2 when dissociate you will be getting Cu2 plus
2Cl minus.
Okay, 2Cl minus you will be getting, and you know that one aqueous solution means water we have.
H plus
Water
and OH
dissociate
minus.
H plus and OH minus. So you have two cations, dear students. Two cations are Cu2 plus and H plus. Among this one they gave the value. Which one has higher reduction potential, that will go to cathode. So I'll write over here, you know that one, we can write at cathode, okay, which will move. I gave an order as well. Cu2 plus and H plus means Cu2 plus will go, which will higher value. So we can write Cu2 plus 2 electron gives Cu. It's over. At cathode, this is the one. At anode, you keep in mind, at anode there is an order that you can remember always. Halogen will go fast than OH minus. Always you keep in mind. That only, two only will ask in board exam. Okay, competitive we can write after this NO2 minus will come, SO4 2 minus will come. But in board exam, these two you keep in mind. X minus also, Cl minus will go first. After that only Br minus will come.
Yes.
Okay, so here what we have? Here we have Cl minus and OH minus. Hope you got the logic. Cl minus and OH minus wherever comes, Cl minus will go to anode. So I'll write the equation directly. 2Cl minus gives Cl2 plus 2 electron. So which gas will be liberated? Chlorine gas will be liberated. So chlorine gas will be liberated at anode and copper will be deposited at cathode. Yes. So hope you got this one. Yes. So hope you got. So this is the one. So cathode and anode, that question B part was there. Okay. Hope you got. Yes.
They got it, sir. Okay.
Yeah, they are giving
the answers. Smriti Ganesh is writing the answers itself.
Yeah, well done. Yeah, well done, Smriti. And yeah. Till then.
Till then the live will
Shanta
go on.
Kumar.
Shanta Kumar. Nice to see that. Okay, great.
Yes. Yeah. So you people should be there all the time, okay, till the end. That is our energy. Let us see when we can wind up the session, okay. Be there. We need your active participation.
Yeah. We are going. Yes.
How much charge in terms of Faraday? See guys, this is the easy one. Even the same equation we are using in D and F chapter. MnO4 minus become Mn2 plus in acidic medium. You know that one. I'm writing the oxidation state directly.
Plus
here
7.
it will be plus 7 and here already
Plus
given 2.
2.
So you know that one difference in electron is 5. So 5 electron is equal to 5 Faraday. Right, no sir, directly
Yeah,
we
5
got,
farad,
yeah.
5 farad.
So 5 farad, they are asking in terms of farad. I think answer came. Yeah, answer
already
came.
answers are coming.
Well done, well
Yeah,
done.
yeah,
So
good,
5 farad.
Everyone are telling that.
It's an easy
Great,
one.
great, great.
Still, that one type of question you can expect. So
That's
keep
easy.
in mind. Yes, we will go to next one. Yeah, this one is another expected numerical. Listen.
Numerical.
When a steady current of 2 ampere was passed through electrolyte, and keep in mind this question we selected because both the Faraday's law are connected to this one, first law and second law.
Both laws are connected.
So when a steady current of 2 ampere was passed through two electrolytic cells A and B containing electrolytes zinc sulfate and copper sulfate connected in series, 2 gram of copper were deposited at the cathode cell B. How long did the current? So here we can use the equations are M equal to atomic mass into IT. I am writing directly QI divided by NF. So mass as given for 2 gram, that is equal to atomic mass of copper they are talking about. It is equal to 63.5 into I am 2 ampere current. Time we need to calculate over here, right? 2 ampere current there. Time we need to calculate for the first. N is equal to, because copper you know that one. Yeah, copper always we wrote just before gives 2. So here it will be 2. So 2 into 96,500. Here we will take out T.
2 we can get cancelled.
Yeah, these two will be cancelling. Okay, time
So then
is
time
equal
will
to
get 96,500.
2 into 96,500 divided by 63.5. Okay. So here the time will be, yeah, here we will get the time. I think, yeah, people are sending the answer. Yes. Yes, yeah. Tell the value, yeah.
3,000.
Yeah. Salman, yes, yeah,
Yeah,
people are
3,000.
giving, yeah, correct, yeah. Yes, so here we are getting the time.
Time.
Yeah.
3039.
Yeah, so 3039. Yeah, seconds.
Nearby.
Yeah, this much seconds will be getting, yeah, it's close the value. 3039 is fine. Yes, correct. Yeah, 3039 seconds. So once we get the time, students, then the second part is there, they are asking how much zinc will be deposited. Here we can use the second law, that will be easy. What is the Faraday's second law? Faraday's second law, we know that one, mass of copper deposited divided by
equivalent mass of copper.
Yeah, mass of zinc deposited is equal to equivalent mass of
copper.
Equivalent mass of copper divided by,
equivalent
we can
mass
write
of zinc.
equivalent mass of zinc. So we will substitute over here. Mass of copper deposited already they gave 2. Mass of zinc deposited we need to calculate. So I'll write it as X over here is equal to equivalent mass of copper means 63.5 divided by 2 divided by 65.3 divided by 2. Correct,
The
right?
2 get cancelled, sir.
Yeah. So here the value we can cancel the value. Then X will be is equal to 2 into 65.3 divided by 63.5. Is the close value, then you will be getting approximately. What is the value you are getting? Yes. W1 divided by E1 is equal to, yes, Sanjay. So 2 into 63.5. Yeah. Answer will be, yes. Solve the value and tell. Jasim. Yes, Jasim, we will send the PDF or you can watch the live later on also, no problem. Salman, yes, I think it is 2.05. 2.05 gram will be getting. Yeah, it's very close.
They are getting, yes, they are getting. 2.05 is getting.
Yes, well done.
2.05, 2.04,
Yeah.
no problem.
2.04 or 2.05, no issue. Yes. Hope you all got the value. Yes, Venkat. Yes. Yeah, all are there. Yes. So we will go to the next question, dear students. Okay, we can do the maximum question. Listen, question number 16. This one is fine, right? Yeah, all you got the answer. 2 point, yeah, Hanna, right. Yes. We will move to the next one, question number 16. Listen, 16th one is represent the cell in which the following reaction takes place. So represent the cell representation means that one here cell representation, if you want you can write like this one.
Aluminum
How do you
become
represent?
aluminum 3+.
Yeah, Al become Al3 plus. So we can write Al slash Al3 plus. Then there will be double slash for salt bridge. Then you will be getting Ni2 plus become Ni. So this is the cell representation. Yeah, that concentration value you can write the bracket. Al3 plus value has given 0.01 molar. And here it is 0.1 molar. Yes. Okay, that is. So this is the representation. Calculate the EMF. EMF means that one you can use the Nernst equation, you can find out. So E cell is equal to E0 cell minus 0.0591 divided by N log anion, or you can write the product anion concentration raised to X divided by cation concentration raised to Y you can write. So we will substitute the value over here. You know that one E0 cell they gave 1.41 is equal to 0.0591 divided by.
1.41 minus.
Here we have to put the minus. Yes, 1.41 minus 0.0591. I told you this is the better method to multiply. You know that one 3 and 2 plus you multiply. Then it will be 6.
That's 6.
So 6 into log. Okay, anion you know that one always on right hand side,
Al
but
3
you have to write Al3 plus concentration raised to
Whole
2.
square.
Divided by here it will be coming as
concentration.
Ni2 plus concentration raised to 3. Correct? The coefficient is 3. So we will substitute the value is equal to 1.41 and dear students this one you can.
Anode divided by cathode.
Yeah. Correct only, right?
Okay.
Yeah, that one. So 1.41 minus this value you can remember 0.009. That I told you, that also you can remember easily that value because when divided by 2 comes 0.02985 sir. Yeah. So this will be 0.009. Yeah, 98 something will come.
98,
I think
99,
0.0098. That value you can remember. Okay, into log I'll substitute the value and this one is 0.1 means I'll write 10 power
10 to
minus
the
2
power minus 2
whole power 2 divided by
10
0.1 I'll write 10 power minus 1 whole power 3. Okay, so here itself I'll cut the value, you know
10
that
to the
one
power minus
minus
1
4
will
and
come.
minus
10
3
to the power minus
minus
1
1.
will be
So I can write 1.41 minus 0.0098 into
minus 1.
log
10 to the
10 power minus 1. So I'll
minus
write
1.
minus 1.
That
Because,
minus 1 become plus.
so it's equal to 1.41 plus 0.0098. Okay, I'll
So
write the answer over here
1.41985
1.41985 volt.
That will be the answer.
I think this is the answer.
Yeah, 419.
Yeah,
419,
1.419.
yes,
Yeah,
yes,
correct. Yeah.
Yes.
All are
We
getting the
can't
answer.
yes,
Yeah, well
complete.
done. Yes, dear students, good. Yeah, all are sending answer. That value you can remember wherever 6 comes 0.0098, wherever 2 comes 0.0591 divided by 2 is 0.02985. Okay.
Okay, great.
That well done. Ashmita, good. Salman, well done.
is telling the answer. Mohabbat is telling the answer. I think we
Yes,
we have to
Rida,
move
all
forward.
are there. Good.
We have to move now around
Yes.
around 2 hours we completed. Great.
Yes, question. I think there is no sub question for well, there is a sub question, sir. How does molar conductivity vary with the increase in dilution? See, this is the very repeated from
always
How
they
can
are
you
asking.
obtain limiting molar conductivity for weak electrolyte? See, whenever they ask this
another
question,
slides.
I think that would be better. So whenever they are asking this type of question, better you can explain with the graph. That is the right, no, sir. So you can
That will be
draw the
better.
graph. Here we will be taking lambda m and here we are taking root C concentration. Then you know that one for strong electrolyte. Okay, you have to write that strong electrolyte. The graph will be like this one. And this graph, when you extrapolate, you will be getting a y-intercept. That y-intercept is called lambda m naught. That they asked for weak electrolyte. And here you know that one for weak electrolyte, lambda m and root C, when you draw, the graph will be like this one. There is no y-intercept because
They
large.
cannot meet that point.
Yes. So why there is no lambda m naught over here? You have to say that for weak electrolyte there is no y-intercept. So here the question you read carefully. How does molar conductivity vary?
With increase in dilution.
Yes, you have to say that for strong electrolyte only a slight increase is there since they dissociated completely. Only mobility of ion increases.
But
for
here,
weak
two things are
electrolyte, there is a sharp increase in molar conductivity because number of ion increases as well as mobility of ions increases. So number of ion increases.
Degree of dissociation increases and mobility
Yeah.
increases.
So mobility of ion as well as number of ion increases or degree of dissociation increases. That's why. And why there is no y-intercept means lambda m naught for weak electrolyte. There is no y-intercept for weak electrolyte. Hope you got the thing.
That's it.
Okay. Yeah. So that is the thing. Lambda m naught. See, how can you obtain molar conductivity of weak electrolyte? That is by Kohlrausch's law. Yeah. So that is you have to say that here we are applying Kohlrausch's law. Okay, Kohlrausch's law for which one? To find the lambda m naught. So lambda m naught of AB is equal to lambda m naught of A plus plus lambda m naught of B minus no
So
related
if
state.
they are writing with an example means the answer will be more good. If they have time means.
Yeah, you can present the answer in perfect manner. So Kohlrausch's law we will be applying for weak
Don't miss a
electrolyte.
chance to lose a single mark. Okay.
Exactly.
Likewise,
So what all points you can add, but should not write like a story.
A story.
Yeah, that should not be.
It's a science exam. You have to draw
For
the figures. and how this will
CBSE,
be.
they want the point exact. So in the beginning and all should not write so much story, and at the end you are writing the point. That will be very different.
Read,
So they won't read that one. Yes. Yeah. Next question, I think people are reading. Yeah. Write the name. Yeah. See, write the name of the cell which is generally used in hearing aids. I told you one cell part question, one 2 mark question you can expect. Yes, the cell which is used in hearing aids is which one? Button cell, or otherwise what is the other name? Button cell called, otherwise called mercury cell. I think they have a good idea right now.
Yeah, anode and
So,
cathode we have tried.
yes, so
At
they are anode. So you know that one, at anode, the
Zinc
reaction
plus-
you can write zinc gives
zinc plus 2, directly we can write. sir.
Zn2 plus 2 electron. You know that
electron.
one, if you want, remember, or you can
Okay,
write
no
Zn2 plus 2 OH minus.
Gives
You will be getting zinc oxide plus
H2O.
water. So this one, if you can remember logically,
Yeah, that's it.
should not get confused. That's why we are writing this one. Otherwise, you can go directly. Then you will be getting Zn plus 2 OH minus gives
Zinc oxide
Zno
plus
plus H2O plus 2 electron.
electron
Right,
will
sir?
come, yeah.
Yes. So
That's the
if
anode.
you are able to remember this one directly, it's fine. Otherwise, logically this one, because Zn2 plus cannot exist independently. That will take OH minus ion from the aqueous solution. Then will give zinc oxide and water. I added the equation. This is the anode only. Then you know that the cathode. Cathode, the reverse you remember, that would be better. Reverse in the sense you know that one. Dear students, mercury oxide. This is the way you remember. Mercury oxide plus 2 electron. Okay, plus water will come. Then you will be getting
mercury plus
zinc.
2,
Mercury plus
2 OH minus.
mercury plus 2 OH minus will come. Just opposite of the anode. That way you can remember, will not make any, you cannot, that
then we can
mistake will
cancel.
not be there. Yes, that will be easy. Then you know that one, no ions are involving. When you add actually, they did not ask overall. So if you want to write the overall, you know that one OH minus will cancel, 2 electron, water will cancel, you can write the overall. But in this question, they did not ask. How high is the chance the battery?
Reactions will be
Yeah,
outside.
see, because that part is difficult. Students, if you are expecting a good mark, okay?
Not a good mark means you have to
Definitely.
learn.
See,
No other option.
I'll tell you one thing. Percentage wise, if you are asking sir chance, we can say more than 50%, right, sir? Battery side,
yeah,
more than 50%. Okay, that definitely percentage wise, if they are asking.
Yes, yes, yes.
5% varying answer.
varying answer numerical, still we have get the full mark.
Yeah, that definitely.
Nearby means you will get full mark, no problem. No
It should not be more than 5% error
Then
and
they
all.
won't get it.
Not happen. Yes, our student. Good. Yes.
So I think whenever they are learning about the cells, they have to more focus about lead acid battery and this battery and as well as
more
H2O2
chances,
fuel cell.
more chances for lead storage,
storage battery.
fuel and even mercury also.
Mercury cell.
But give more important for fuel and lead storage.
Fuel cell
and lead storage.
They are
That
environment
is,
friendly, na? So that's why the chance is there.
yeah, fuel cell advantage and all they asked. I think we can go to the
can go
next
to the
one.
next one, sir.
Yeah.
Next one.
Question number 18. So question number 18, listen here. Calculate the degree of dissociation of acetic acid if its molar conductivity is given. So see, we have an equation, sir.
Alpha
is equal to lambda m divided by lambda m naught. So lambda m, I think they gave. So we can find. Lambda m is given.
39.05.
Yeah,
Here
39.05 is given. Lambda m
And
naught
infinity
we
we
can
have to
calculate.
find out.
Lambda m naught of which one? Acetic acid. So
Acetic
we will
acid.
write the equation.
We have to
Lambda
add
m
it.
naught of CH3COH
Contraction
is
law we
equal
have to
to,
use
yes,
it.
lambda m naught of CH3CO minus plus
lambda
m naught of H plus. So we can add the value lambda m naught of CH3CO minus is given 349.6 plus
40.9.
that is H plus.
Yeah,
We can
40,
write,
both are adding now, no problem.
yeah. So this one 40.9 plus
Plus
349.6. I think
So
it will
three.
be 4.
No, 390.5 will come.
Yes, 390.5.
Five will come.
Yeah, that is the Siemens centimeter square mole raised to minus 1. Yeah. Value.
They're getting
After that, we have to divide this one is equal to
390.5.
390.5. Approximately
So 0.1
0.1 will come because 1 by
Simple.
10
Point
will
one,
come.
if they want to convert it into a percentage,
Yeah, I
then
think
percentage.
so. Here they did not ask the percentage. So
No,
if
no,
you're
no.
writing 0.1, it's right. Yes. Yeah, correct. 0.1. So you can write the 0.1. Alpha is equal to 0.1. Enough. So guys, we are moving on to the next one. Okay, better I think this all include. We can do the maximum
Sanjay
question.
Shamkumar, lead storage battery also they can ask. Okay, they can ask. That's also important one.
Yes. Lead storage
That's the
battery.
important one.
Yeah, lead
Important
storage
one.
and fuel, the most repeated.
Every time they are asking about H2O2 fuel cell.
At
and
least,
lead storage battery.
one application level question also we can expect. If they are not asking the cell reaction. But we cannot say that one cell is important anyway. You cannot
The
skip that
H2O2
part.
fuel cell and all environmental friendly, na? So that's why the chance is there. Okay, don't forget it. You have to go
Yeah.
through it at least.
Question
Okay,
from
sir.
that cell part you can expect. Yes. Question
You can
number
go to the next
19,
one,
sir. We
19,
have
sir.
2 more questions. Yes. Question number 19. Resistance of a conductivity cell filled with a 0.1 molar KCl. It's a reader exercise question, very important, they asked in so many previous papers. For KCl solution, 100 ohm is given. If the resistance of the same cell when filled with the 0.02 molar KCl solution, 520 is the resistance, calculate the conductivity. See here, dear students, they gave two cases over here. Why they are giving two cases over here? In the first case, you have to find out G star. Okay, so G star you need to calculate, that G star you need to apply to the second one. So what is the equation for G star? So G star you cannot take directly. We have the equation K equal to G into G star. Okay, that means G star is equal to K into R, because G can be substituted as what?
1 by R.
Yeah, if you want, you can. I'll write K equal to 1 by R into G star. So I'll write G star is equal to K into R, correct? So K into R. So I can substitute the value K has given over here. I think the value is 1.29. 1.29 into 10 power minus 2. Resistance has given 100. So 100 I will take as 10 power 2. Minus 2 and 2, this will be 1.29. Okay. G star is centimeter inverse. Always you keep in mind unit.
L by A only.
L by A. So once you get the G star, I'll go to the next part. Next part they are asking calculate the conductivity. Conductivity, you know that one K is equal to. So conductivity we need to calculate. That is K is equal to G into G star. Okay, G into G star. G star already we got. I will write this one as 1 by R into G star. So R is given 1 by 520. Correct na sir?
1 by 520.
Yeah, that this question and all 100 times we did I think. So 1 by 520 into G star is this value 1.29. Okay. So I can write 1.29 divided by 520. So 1.29 divided by 520. I think people are sending the answer.
0.0024.
Yes. 0.0024. Okay. K is Siemens centimeter.
0.0024 Siemens centimeter. Yeah.
Siemens centimeter inverse. Yes, people are sending the answer. Very good. Yes. Yes. Wait.
Yes, they are telling the answer, I hope.
Yeah. So once we get that one, the conductivity of 0.1 molar KCl. Okay.
Yes.
After that, molar conductivity they are asking to calculate.
About molar conductivity also they are asking.
Yes, molar conductivity lambda m is equal to K into 1000 divided by C. So I can substitute the value 0.024 into 10 power 3 divided by that. I will take it as 2 into 10 power minus 2. Okay. So so we can write that is fine. No? Yeah. So is equal to, this one will be 2.4 in the numerator. 2.4 divided by 2 into 10 power 2 will come. Correct, no sir?
Yeah, correct.
So it will be 120 I think. 1.2 will be, it will be 120, correct?
124 will come because it is here.
Correct answer.
120, 124.
120 or 124 is fine I think.
Nearby.
Siemens centimeter square mole raised to minus 1.
That's it.
Siemens centimeter square mole raised to minus 1. Correct. Yeah, correct answer
here
is.
The thing is that, sir, if you are taking 2,
here,
0.0024,
if you want, you can take 8 over here, then 8 over here, then it will be 124. No problem.
2.48 will come, so 124.
It's okay.
That's it. No problem.
That 120 and 124, they won't cut your mark. It won't be that difference and all, but better nearby. Because after the decimal 2 places, if you are considering, it is fine.
It's okay.
Yes.
So they are asking, sir, DNF, Satvik DNF block, you just wait, okay, we are coming to the DNF block elements.
It's odd.
For manganate, potassium, everything we are coming, okay.
Order only we are going. Yes.
Order only going. Okay.
Chapter order wise we will be doing all the chapter. Okay. All the 10 chapter we will be doing. Yes. Wait.
So,
yes.
Sir,
yes.
Okay.
Question number 20. The last question from electrochemistry. I think 2 chapters almost going to over. Yeah.
81 members still there, sir. 81. I was checking how many members are there. 81 members still there. Okay.
Thank you, dear students. Thank you so much. So we will solve the last question from the chapter electrochemistry. State Faraday's first law of electrolysis. Okay. Very important. You know that one. Faraday's first law, second law, important one definition. First law states that the mass of substance deposited or liberated at respective electrode is directly proportional to the quantity of electricity passed through the electrolyte. So the amount of substance deposited or liberated at respective electrodes is directly proportional to the quantity of electricity passed through the electrolyte. If you are writing, M proportional to Q or M equal to ZQ. If you are writing, that will be EC or M equal to ZIT. Same only. This one you can write. Formula. Second law means you know that one. It's same current when passed through different electrolyte. Amount of substance deposited is equal to their equivalent weight. That 2 definition you have to keep in mind. And they are asking one more question. How much amount of Faraday is required for the reduction of 1 mole? It's a quite easy one. Cu2 plus 2 electron gives Cu. Correct? Yes. So here it will be you know that one 2 Faraday. 2 electron means 2 Faraday. And
And
instead of
next
this one, if they are
3,500
asking,
like.
instead of this one, if they are asking, sir, for coulomb, you know that one 2 into 96,500 coulomb. That they did not ask. This is our right answer. If they are asking for coulomb, just multiply the quantity of electricity. If they are asking, just multiply with 96,500. That much coulomb. Yes, all you got. I think yes.
Yeah, they are getting the
Here,
answer.
yeah, here no need to multiply. Just write the answer. That is enough. 2 Faraday is more than enough.
So
Yes.
19,
Yeah. Here
19,
they are asking in terms of Faraday.
Faraday means
Is
no need to
required. In
multiply,
terms
that's
of
enough.
Faraday means, yeah, just you write 2 Faraday. Yeah, enough.
So they are asking again, sir, what is the advantage of button cell over lead storage cell? Both are different. Both are
Yeah.
different uses, different applications.
Yeah, button cell has long life, sir.
Long
It will
life
be
is there.
long life. Button cell is long lasting. You can
And
sell
also their
steady
potential
current.
will be steady.
Yeah. Steady
Up to the
current.
end,
Yeah.
the steady current
So
will be
in
there.
some cases we need to use the steady current. That case we will be using button cell and all.
In calculators
Yeah,
and
yeah. That type
ear
of
aids and
devices.
all,
Yeah.
like that only.
In the lead storage cell and all, the voltage will be varying.
Varying.
Because of ion. Here no ion, steady voltage, and it is more durable.
And lead storage
That are
battery
the
even we are using in our inverters and all. That
Yeah,
lead storage
yeah.
battery in bike,
Automobiles,
car,
vehicles,
and all we
yeah,
are using.
that.
That is lead storage battery only.
yes.
There, whenever voltage is decreasing, that time we usually used to add H2SO4 dilute. That and all they know, I hope.
That
yeah, you learned now. No
That
problem.
is why it will be recharging while running the vehicle.
Yeah.
Here no need such recharging and all. Yes, and what all are the expected cells? Yeah, the Anish already we gave.
So many
Fuel
times.
cell and the
Lead storage battery. If you
That
have
is-
time means you have to learn button cell also.
Yeah. So
Okay, sir.
that is the more chance. So should not avoid all the other one because sir said only
So
these
we
two
are
will come.
telling
No.
the most expected. That's
Yeah,
all. Okay.
most repeatedly they will give more focus on that one. Okay, they can ask any nickel cadmium cell also they can ask.
They can ask. They can ask.
But more chance if you are asking.
While
will-
we are looking the history, that's the thing. They are
Exactly.
repeatedly
Yeah.
they are
The
asking
pattern
about
and
that.
all if you are telling, we would say that fuel cell and lead storage.
Lead storage. Sir.
Yes.
Okay, now.
Yeah. Sir, yeah, kinetics.
Then
You
I
can
will
start, sir, now. Yes. Kinetics, yes. Kinetics
Okay.
you can start. So, see, you can tell remember the point over here. What all points we have to remember for this one, kinetics.
So, dears, I hope all of you are here. You are listening properly. So, here in this chapter, we have to remember about the ideas. First idea is rate law that you already learned, and order and molecularity, and average and instantaneous rate. Then unit of rate constant, okay, average and instantaneous rate, how to rate, okay, that idea you have to remember. And zero order and first order reactions and numerical, their equations, okay, in the case of zero order reaction, T is equal to R0 minus R divided by K. In the case of first order reaction, T equal to 2.03 by K log R0 by R. That and all idea, and half-life period also. In the case of first order, T half is equal to 0.693 by K, and zero order, R0 by 2K, T half is equal to R0 by 2K. That and all idea you have to remember, okay, no need, you have to remember it, okay. So then half-life calculation is there. Then Arrhenius equation and its graph, okay, Arrhenius equation K equal to A raised to minus EA by RT, as well as log K2 by K1 equal to EA by 2.03 R into 1 by T1 minus 1 by T2. That formula and all you have to remember. Then activation energy calculation. From that, how to calculate if they are giving T1, T2 and K1, K2, how to calculate EA. That idea you have to remember. Then effect of temperature and catalyst. Okay, how it will affect that idea. So whenever you are using positive catalyst, activation energy will decrease. That idea you have to remember. Then collision theory. According to collision theory, every product formation is because of the collision between the molecules and ions. That idea you have to remember. That's all the chemical kinetics. Mainly we have to focus about that rate and integrated rate equation order. Okay, first order, second order, that idea you have to remember. So anyhow, let's go to the very important question from these chapters. Okay, let's see. Sir, let's start now.
Yes.
Yeah. So this is the first question. Guys. Write the slope value obtained in the plot of LNR versus time for first order reaction. Okay, first order reaction. We know in the case of first order reaction, while we are deriving, we remember, okay, if you remember means we can directly write the equation LNR equal to minus KT plus LNR0. While we are deriving that formula, you remember, or else if you are not remembering this one means you can start from the equation. Which equation? You have the equation T equal to 2.303 by K log R0 by R. Okay, log R0 by R. This equation you are remembering. From this one, you can write the equation T equal to 2.03 by K log R0 by R. From that itself you can find out. Okay, so here you can take the K to left hand side, that will be KT, then 2.303 into log R0 by R. Okay, log R0 by R. You know the idea. 2.303 log x, you can write what? ln x. Okay, ln x means logarithm in the base e, exponential value. Okay, so here I can write this one equal to ln R0 by R. Okay, ln R0 by R. So we know the idea. Deepu sir, welcome to the stage.
Yes, sir.
So your Satvik, your Deepu sir is here. Okay, along with me. Okay, so students are asking, where is Deepu sir? Where is Deepu sir? Okay.
We all are here. That's why I'm giving the comment in the. I think personally you are getting some comment also. That's what I am giving from there.
Okay.
Here onwards we can start.
Yeah. Okay.
Right.
Can I start now, sir?
Yes, sir.
Okay. So here we know the equations are ln A by B equal to what? ln A minus ln B. That formula.
Yes.
From that we can write here, dears, ln R0 by R equal to ln R0 minus what? ln R. Okay. ln R0 minus ln R.
Yes.
So that idea only, here it is KT is there. Now just I am rearranging. How I am rearranging? ln R I am taking to left, that only I got ln R. Okay, and KT I am taking to right hand side, that is minus KT. Then ln R0 I got. Okay, so that's the equation that only I got. I already taught you how to get it. Okay, I hope the idea clear. Then I am writing that one here. I will show you here. I will write it one more time. ln R equal to minus KT plus ln R0. This is of the form of. This is a form of y equal to mx plus c. You just compare. This is y means y-axis. In y-axis ln R is there. Okay, in y-axis what is there? ln R is there. In y-axis ln R is there. In y-axis ln R is there. And instead of x, t is there. And instead of m is the slope. Okay, m is the slope. So m is the slope. So they are asking about slope. So slope equal to, yes, it is blinking, sir. Okay, so slope equal to what? Slope m equal to minus k. That's the answer. Simply you will get slope equal to minus k. So if you remember the derivation means from anywhere you can write according to your wish, they can make the formula.
Yes, the same thing you can expect as an MCQ. Okay,
MCQ.
the slope, what is the y-axis, x-axis, mainly
Like
the
that,
slope.
like that.
Please.
You have to remember, if it is in the terms of, if they are asking about what, log R versus that curve also, if they are asking means minus k by 2.303, like that come. If log R versus t means minus k by 2.303 will come. Okay, so like that. Anyhow, you got the answer. Sir, derivation in the chapter are important for exam ready. For zero order they can ask sometime, or else T half equal to first order, as well as that T half relations now. T half is equal to 2 times T 75% is equal to 2 times T half. That and all idea they usually used to
I
ask.
think most of the students have a confusion like whether they ask the derivation for the first order and second order. They all just go through that one. We can't able to say that they won't ask, because the last many year they didn't mention that question in that one.
So that does not mean that they won't ask. They will ask. Sometime they will ask. Okay.
Sometime.
So you have to remember at least zero order and first order they have to remember.
Yes,
Nothing.
At least from the K value we have to know how to calculate the T half.
Yes.
And the graph also very important.
Yes,
Both
yes.
from zero order and first order. We'll show you some graph questions.
Yeah.
Also we have to
That's there.
discuss here.
Okay. If they are asking from the graph means you can draw from here itself. They can draw the graph also. No need to draw the graph here. They are simply asking about K only. So I mean slope only. If they are asking about graph means instead of y, here we can write ln R. Here in x-axis we can write what? Here x-axis what we can write? Time. And here this is the y-intercept. Y-intercept is here. And it is a slope is negative means it will become like this. Slope m equal to what? Minus k. It will become like this. Okay. So ready?
Okay, fine.
If it's so, then we can move to the next question. Okay. We can move to the next question, guys. I hope the idea is very clear. We can go to the next one. This is the next question, guys. A first order reaction. Listen to me very carefully. Okay. A first order reaction 45% complete in 80 minutes. Okay, so that means they given the T 40% complete in 80 minutes. Then they are asking about the calculate the value of rate constant. We have to calculate the rate constant value. Okay, and also we have to calculate the T 90%. How in what time will the reaction will be 90% completed means we have to calculate T 90% also we have to calculate it. Yes. Listen to me very carefully. We know the integrated rate equation. What's the integrated rate equation? T is equal to, for first order, what's the integrated rate equation? T equal to 2.303 by K log R0 by R. R0 by R. This is the equation. Okay, this is the equation. Here they are talking about 40%. What do you mean by 40%? If I am taking 100 gram, 40 gram is reacted. Remaining only 60 gram. That's the idea. Nothing more. If they are asking about T20 means 20 gram reacted. Remaining 80 gram only remaining.
Yeah, so
okay.
While they're reading the question, they should be very careful.
How much?
R not mean initially.
Initial, and R means final.
Existing.
That's the idea.
So sometimes they will say 20% is decomposed.
Decomposed,
sometimes
yeah.
they will say 20% is remains.
Remains.
That
That
question we should be very
you have to remember that idea. Here they are telling 40% completed. Meaning, if I am taking 100, 40% is reacted. Only remaining is 60. So instead of this T, I can write T 40%. T 40% is equal to 2.303 by K log R0 I am taking 100. R0 I am taking 100 divided by R. Final how much? If 40% reacted means final how much, sir? 60 will come. So I can cancel this one I can cancel. So log 10 by 6 is there. So I can take this, instead of this T 40% I can substitute what? T 40% I can substitute 80. 80 minutes they already given, sir. So 80 equal to what? 80 equal to 2.303 by K. This one log 10 by 6 is there. Log A by B means log 10 minus log 6 will come. Yes. Log 6 will come. So now I can substitute the values. Here K I can take to the left. Sir, you can see K equal to 2.303 into 2.303. This K I am taking to left hand side. 2.303 log 10 minus log 6 means log 10 is 1. 1 minus log 6 value they already given in the question. They given the question 0.7782. Okay, 0.7782. Okay, 0.7782. So while I am substituting that value 1 minus 0.7782, so 0.33 will come. Then here while I am doing this one, K equal to 2.03 into, well, I'll subtract this one 1 minus, okay, 1 minus 0.7782. Okay, 82 I am subtracting, sir. So 10 minus 2, 8 is coming, sir. 1 is there. Then again, I'm sorry, here I will take one more 0. Here 2 will come. Okay, 2 will come. So here 8 will come. 10 minus 2, 9 minus 1 will be there. Again 9 minus 7, 2 will be there. 2 will be there. Okay, 0.2218 will be there. 0.2218 divided by how much is there? 80 will come. Okay, so you will get the answer I think around 0.006 minute inverse I will get. Okay, 0.006 minute I will get. Okay, I hope you guys got the answer. Yes, 0.0063. Okay, yes, great. Okay, great. So 0.006, correct only, sir? Yes. Yeah, 64 will be coming. So then again they are asking one more question here. That is very important. Okay, that's very important. What they are asking? What time will the reaction 90% completed? So that means you have to calculate the T 90%. Either you can remember a shortcut. T 90% is equal to this one. This one, you know the integrated rate equation. This one, the initial part is T 90%. Or else I will show you how to commit. Okay. So they are asking about T 90%, sir. T 90% means what, students? I already told you. Out of 100, if you are taking 100 initially, 90 gram is reacted. Remaining only how much? 10 gram only there. So 2.303 by K log initial how much? 100 we are taking. And final how much? 90 is remaining. Only 10 remains. So 100 by 10 means what is coming? 2.303 by K log 10. Log 10 is how much? 1. So 2.303 by K. K how much we got, sir? 0.0064. Yes. Okay, 0.0064. So while you are dividing this one, you will get approximately 360 minutes. I hope 360 minutes you will get. Yes. How many of you got the answer, dears? How many of you got the answer, dears?
Given the correct answer.
Tell me. Yes, I hope all of you are getting the answers. Okay.
Yes, most of them already given that.
Yeah, all of them are telling the answers. Okay.
Yes,
360 minutes.
We can definitely expect a question related to the first order reaction, K value calculation and half-life.
Yeah, half-life period.
Maybe the relation also, the 99%, then the 90%, the relation, we said the double of that one, that kind of relation also we can express from the first order kinetics questions.
And they are asking one more question, sir. Do we need to convert minutes to second? No need. Here already they given. You see now. while you are looking the question here, they are telling in minute, so no need to convert it into second. Don't waste your time. We can answer everything in second. Okay, no
While
problem.
writing
Minute
the
itself.
answer, while writing the unit, we should write in minute. That's
Minute. That's it. Okay. So here, here we are writing now. K equal to minute inverse only we are writing. So the same thing here also we are writing what 360 minute only the answer. Okay. I hope you got the answer. What
I
will
think
be the
only
case
the
study question expected?
clarification
Okay.
needed that when they're doing the Faraday's questions, right?
Yeah.
At the time only
That time
the
second.
time you need to take in the second.
Second.
These kind of cases, if you're taking minute also no problem, but calculation is in minute and writing the answer in second, that is not allowed. Okay, let's be careful.
Okay, fine. So I think we can go to the next question,
question,
sir.
sir.
I think they are doing now. Yes. Okay, fine. Okay.
sir, very good.
So this the next question, guys. In the given reaction, they given one reaction A plus 3B gives 2C. The rate of formation of C they given. Okay, calculate rate of reaction and rate of disappearance of B. From this is the equation they given. Here they are giving rate of formation of C. What do you mean by rate of formation of C? Rate of formation of C. Okay, rate of formation of C. Rate means d by dt.
Yes.
Formation means plus. And concentration of C, that value they given how much? 2.5 into 10 raised to minus 4 they given. Now what they are asking? Calculate the rate of reaction. In terms of C, how I can tell the rate of reaction? Rate of reaction, how I can tell in terms of C? So you have to write the you have to write their stoichiometric coefficient as reciprocal. So 1 by 2 and it's a product, that's why plus into d by dt of C only will come. So that value they already given. What's the value they given? This value they already given here. 2.5 into how much, sir? 2.5, yeah, that's blinking now. Yeah. So 1 by 2 into 2.5 into 10 raised to minus 4. Yes. So 2.5 divided by 2 means what's the answer? 1.25 into 10 raised to minus 4. You check it, yeah, it's coming now.
Yes,
Ashmita is telling the answer, everyone are telling the answer, okay. 1.25 into 10 raised to minus 4. Yeah, yes, great to see that. 1.25 into 10 raised to minus 4. Okay, unit we have to write.
Yes,
don't forget the unit. Mole, liter inverse, second inverse. Any order, rate of reaction is mole, liter inverse, second inverse. Okay, any order, rate of reaction is mole, liter inverse, second inverse. Okay, fine. Then again they are asking rate of disappearance of B. So in the case of B, by using B, how I can write the rate of reaction? Minus 1 by 3 d by dt of B. In the case of B or in the case of C or in the case of A, in any case if you are writing rate of a reaction, answer will be same only. What's the answer? 1.25 into 10 raised to minus 4. Then they are asking rate of disappearance of B. That time no need of this 3 here.
Yes.
We have to take that 3 to right. So this will be minus d by dt of B equal to 3 into 1.25. 3 into 1.25 is 3.75 into 10 raised to minus 4. So answer is this is the answer. What's the answer, sir? 3.75 into 10 raised to minus 4. What's the unit, sir? Mole, liter inverse, second inverse. Mole, liter inverse, second inverse. Everyone are telling the answers now?
Yes. Good.
Yes. So Ashmita Chakrabarti, not minus, okay. Minus won't come there. Minus will be here itself. Don't tell right in minus, okay. So that minus we are telling already we know that is a decrease. So that to avoid that minus only we are putting one minus here, okay. Yeah. So that's the answer, I hope.
Rate of, they already said the rate of disappearance.
Of B. So
Rate
already
of
minus. So that minus we have to keep here itself.
Yes.
Okay, now ready?
Yeah, let's go for the next.
Yeah, yes, okay. Ashmita got the answer. Okay, if it's so, then we can move to the next question, guys. We can move to the next question.
Yes, next.
This is the next question, guys. Yes. They given one question for a reaction 2H2O2 in alkaline medium. They are disproportionate into 2H2O plus O2. And they are telling the proposed mechanism is as given below. They given one mechanism. This actually taking place in how many steps, sir? Two steps. So one step is there, slow step is there, H2O2 plus I minus gives H2O plus IO minus. One slow step is there. Again H2O2 plus IO minus gives H2O plus I minus plus O2. That's the fast step is there. So which step is the rate determining step? Slow step is the rate determining step. Okay, slow step is the rate determining step. Don't forget, okay, slow step is the rate determining step. So they are asking rate the rate law for the reaction. So while we are rating the rate law, we have to use the slow step. So what's the rate of reaction? Rate is equal to K into which all are the things coming reactant side. Here H2O2 is there, concentration of H2O2. What's raised to? No need to raise X because here already it is a elementary reaction. That time what is the stoichiometric coefficient coming here? 1. So that is 1, and here what is there? I minus raised to 1. So that's it. That's the rate law. Then write the overall order of reaction. What's the overall order of reaction? We have the sum of powers of concentration terms in the rate law. So this one plus this one, how much we will get?
Equal to 2.
Equal to 2 we will get. Okay, we will get. So order equal to how much? 2. And what's next idea? Out of step 1 and 2, which one is rate determining step? That we already told. The slowest step will be the rate determining step. Is it okay? Clear? Ready?
Yes.
Okay now?
Yeah.
Yeah. If it's so, then we can move to the next question, guys. We can move to the next question. This is the question, guys. Listen to me very carefully. Define order of reaction. What's the order of reaction? It is the sum of powers of concentration terms expressed in rate law equation. In rate law equation, we have to add the sum of powers. That is what is called order of reaction. Okay. Then they are asking, predict the order of reaction in the given graphs. So they given the graph between T half and R0. Here also T half and R0. So there is a simple idea, you are learning mainly zero order reaction as well as first order reaction. Okay. So T half is equal to R0 by 2K. This is for which order? Zero order. This is for zero order, and T half is equal to 0.693 by K. This is for which order? First order. This is for first order. Okay, this is the half-life period for zero order. This is the half-life for first order. Okay, so here you can see, while you are looking this one, sir, you can see here T half and R0 are directly proportional because 2 is a constant and K is also a constant. So T half is directly proportional to R0. So that means whenever R0 increases, T half will increases. So it's of the form of Y equal to mx. Likewise also we can tell, no problem. It's a straight line. And here instead of C, here 0 is there. That means a slope passing through the origin. So that means the second one, this one represent the which order? Zero order. And this one represent what? So here, whatever the initial concentration you are taking, if you are taking 2 kilogram, 100 kilogram, 1000 kilogram, whatever be the initial concentration, T half will be same for the first order. So here there is no R0 is not depending. That's why whatever the R0 you increase also, T half value will be constant, not changing. So the graph A represent for which order? First order. I hope you guys got it. Yes or no?
Yeah. Okay, fine.
Yeah, okay, fine. Okay. Yes. If it's so, then we can go to the next one.
Graphical based question, I think we have two more graph of the first order reaction and zero order reaction. See, all of you, the integrated, you ask the question whether they ask the integrated rate, the derivation or not. See, there are graphs. The graphs are important and the final equation
are important. That's important. Okay. So they are asking, sir, should we mention the formula while writing the answer? If you have the time means you can write it, no problem. If you have the time means they can mention, that's it. Or else no need.
Yeah, whenever there is a numerical questions and all
that time you have to write the equations.
The correct equation we have to write it, then only we have to do the substitution. Even these kind of questions, we can just write this equation and show the relation.
So you just use your common sense. Okay, while we are writing this one and we are explaining means what the teachers will think. Yes. So they will think, yeah, the students know everything. Yes. Then they will give the full mark. Yes. That's it. We need full mark, guys. Okay, now. Yes.
Don't give a chance. What we are discussing in class like that, don't give a chance to reduce marks. Okay, don't give any chance. So what all points you know regarding that concept, you write it, your 3 hour is there. Most of the students which you see in that 2.5 hour, they're completing the examination and leaving. No, 3 hour, you should sit and study. Maximum what you learn in this 1 year, present it. Okay, don't give a chance to reduce marks.
This is the last chance. Hereafter, no chance now.
No
so
chance.
Nothing. Okay, yes.
Okay.
They will do it, sir. They will do it. They are showing the every energy in the comment box. Means that's it. Okay. Yes. We can see the energy. Yes. Okay, on one more, will it come for 2 or 3 mark question? Yeah, it will become like 2 mark question only. This one will come. Okay. Yes, next one.
Yes, I think that first order zero order reaction, that see the textbook, there is a graph. That's one.
Yeah.
Same type.
Okay. So we can go to the next one, sir. Okay. So this is the next question, guys. This is a very important question again, many times. Okay. Most expected. Okay. Many times they usually used to ask this kind of question. Okay, they are telling the following data were obtained for the reaction. They are telling they did 4 experiments already. For the initial concentration of A, they took 0.2, and that time concentration of B, they took 0.3, and that time they got the initial rate of formation of C, 4.2 into 10 raised to minus 2. So while we are writing this one, what's the question? Find the order of reaction with respect to A and B. So that's why to find out the order of reaction with respect to A and B, we have to write the right equation.
First
What's the right equation? Right equation equal to K into, here the reactants are A and B. So concentration of A raised to X, B raised to Y.
Don't
write 1 and 2. If you write means that's wrong.
Experimental quantity, don't forget. That's a value we need to find by using the value.
To find out that only they given this experiment.
And also they given 0.2, 0.4, 0.3, 0.3. This is to make your calculation easier.
Easier.
Okay.
Okay. So what we can do? We can consider the first experiment. This experiment, while we are considering, what's the rate they given? Rate they given 4.2. So I will write here. You can see instead of 4.2, I am writing 42, sir. 42 into 10 raised to minus 3 equal to K into, what's the concentration of A? A is 0.2. 0.2 raised to X into 0.3 raised to Y. I hope they can see. 0.3 raised to Y, equation number 1. Okay, then again, that's the equation number 1. Okay, then again I am taking the second condition. This one I am taking, second one I am taking. That time what's the rate? 6 into 10 raised to minus 3 equal to K into 0.1 raised to X into, again 0.1 raised to Y. Okay, 0.1 raised to Y. That's the equation number 2. Right. And the third condition, this is the third condition I am taking. That time what's the rate? 1.68 into 10 raised to minus 1. That I am taking 168 for calculation. Okay, 168 into 10 raised to minus 3 equal to K into 0.4 raised to X into 0.3 raised to Y. This is equation number 3. And one more last one, I am taking 2.4 into 10 raised to minus 2, this one. I am writing, sir, 24 into 10 raised to minus 3 equal to K into 0.1 raised to X and 0.4 raised to Y. 0.4 raised to Y, this is equation number 4. Now what I have to calculate? I have to calculate X and Y. So 4 equations is there, then I have to calculate X and Y. This is purely mathematical, nothing chemistry there, okay now? So this one only we have to calculate. So what I will do, while I am looking this one, you can see, while I am looking this one, this equation while I am looking, that time I will take this 1 as well as 3 I am taking, sir. So while I am dividing this 3 with 1, 3 divided by 1, third equation with the first equation, what I will get? 3 here, 168 into 10 raised to minus 3 divided by 42 into 10 raised to minus 3. Okay, 168 into 10 raised to minus 3 divided by 42 into 10 raised to minus 3. K get cancelled.
Yes.
And 0.4 divided by 0.2. 0.4 divided by 0.2 all raised to X I can write. 0.3 will get cancelled. So 10 raised to minus 3, 10 raised to minus 3 I can get cancelled. 42 into 4 only 168, I hope. 42 into 4, 2 into 4, 168. Yes, correct now? Correct. So that is 4 times. 4 equal to 0.4 by means 2 raised to X. Yes. So that means 2 raised to 2 equal to 2 raised to X. X equal to 2. I got X equal to 2. Yes. Similarly, I can find out Y value. For that, what I will take, sir? What I will take? Here, I can take 2 and 4.
Yeah, that's better to cut.
2 and 4, 0.1 will get cancelled. Yes. Okay. So I am dividing. Can I do here now? No problem now. 4 divided by, I hope students can see. I hope so. 4 divided by, not 1, 2. 4 divided by 2. Okay now. Yeah, 4 divided by 2. So 24 by 6 will come. 24 by 6 equal to K will get cancelled. 0.1 will get 0.4 by 1. So 4 raised to Y will come. Yes. Is it okay? Yeah. So 4 equal to 4 raised to Y. Y equal to 1. So X equal to what I got? X equal to 2 I got. Y equal to 1. So that means what's the rate law? Rate equal to K into concentration of A raised to 2 and B raised to 1. That's it. That's the first question. Find the order of reaction with respect to A and B. Order of reaction with respect to A, 2. With respect to B, 1. So what's the power in A? That's with respect to A. With respect to B, 1. That's it. And write the rate law and overall reaction that we already wrote it now. Okay, no problem. Calculate the rate constant K. How we can calculate the rate constant, dears?
We can apply
Simply
any one of these.
we can take any of the 4 of the equation. Out of that, what I have to do? I have to apply x and y value. I am taking the second one. That's very easy for me. Why? So there the equation is actually, you can see, I will write the equation here. 6 into 10 raised to minus 3 equal to k into 0.1 raised to 2 into 0.1 raised to 0.1 raised to 1. So the idea is here 0.1 square means 0.1 square into 1 10 raised to minus 3. 10 raised to minus 3, 10 raised to minus 3 will get cancelled. So what's the value of k? 6 will come. 6 will come. K value is 6. I hope you got the answer. Okay now? Ready?
Yes.
Okay now?
Sir, okay, fine.
I think all of them got the answer. I hope k equal to 6. That's
Yes,
it.
okay.
That's all the idea about what? Rate constant. So this is the 6th question. I hope you guys got it very clearly. Ready? Yes, if it's so, then we can move to the next one now. Is there any doubt there? No, no? Okay, okay, no.
And overall order is the rate law of the whole reaction.
Yeah,
we
yeah.
have to
That's
consider
the thing that we already
overall.
find out. Overall order is 2 plus 3.
2 plus 1.
2 plus 1 equal to 3. 2 plus 1 equal to 3. That's the overall order. With respect to A plus with respect to B, if you are adding, that's the overall.
Okay, let's
Okay,
go
if
for
it's
the next
let's go to the next one. This is the next question, guys. This is the another most expected question they usually used to ask from
Activation
Arrhenius
energy.
equation. Arrhenius equation. Okay, so the rate of a reaction become 4 times when the temperature changes from 293 Kelvin to 313 Kelvin.
So T1
calculate
and
the
T2 we can-
calculate the energy of activation. They are telling the rate of reaction become 4 times. That means we can take initial rate is K1 and final rate is K2. Then they are telling K2 equal to 4 times K1. Rate constant is nothing. It is rate of reaction only. And T1 and T2 they given. They are asking about EA. We have the equation. What's the equation? Logarithm of K2 by K1 equal to EA by 2.303 R into 1 by T1 minus 1 by T2. Okay, 1 by T1 minus 1 by T2. Here what is K2 equal to 4 K1. So automatically K2 by K1 equal to what? 4. So I can substitute log 4 here. Log 4 equal to EA divided by 2.03 R 19.14138 we can write. Okay.
That value just
That
remember.
1 is 90.1 is enough. Okay, 13 into 1 by T1. What is 1 by T1? 1 by 293 minus 1 by 313. Okay, 1 by 313. Here some of you maybe think like that. Here R value we are taking what only? That SI unit only. Here we have to take 8.314 joule Kelvin inverse mole inverse we are taking. Okay, in this calculation we are taking R value 8.314 joule Kelvin inverse mole inverse. So what I have to do? I have to take this value into left hand side. Then I have to calculate. Sir, here while we are looking here log 4 equal to log 4 into log 4 into 19.13 divided by this one will be this one we can write it as 293 into 313 into 20 will this will be go to top now. So this will be go to top. I'm sorry. This will be go to top. 293 into 13 into 293 into 313 divided by how much it will come. This one difference is 20 only. So that's equal to how much? EA. That's equal to EA will come. So once you are solving this one, what is log 4? What is log 4? So
4.6.
yeah, this is actually 19.13147. Okay, 19.147 will come. So 19.147 into that value while you are doing, you will get the answer 52.86 kilojoule. Okay, 52.86 kilojoule you will get. Okay, I hope you are getting the answer. Yeah, 816. Okay, 2 log 2. Yeah, log 2 if you want to calculate means log 4 you want to calculate means log 2 square. Log 2 square means 2 log 2. Then no na. Log 4 they directly they given. No problem. Directly they given 52.86. I hope all of you got the answer. Ready? Yes. Everyone are telling the answer now. Yes, Ridhya Srini is telling yes, everyone are telling the answer. Okay, I think we can go to the next one. I think, yeah, time is going on. Okay, we can move. We can move to the next one. Yeah, more chapters are waiting now. Okay, this is the next question, guys. A reaction is second order in A and first order in B. So we can write the rate equation directly. What's the rate equation? Rate equal to K into A square. Okay, second order in terms of A. So means A square. And first order with respect to B. So B. This is enough. A square into B. Then what's the first question? Write the differential rate equation. So rate means minus d by dt of concentration of reactant equal to K A square into B. That's called differential rate equation. What's the next idea they are asking, sir? What's the next idea they are asking, sir? How is the rate affected on increasing the concentration of A? 3 times. You are changing A become 3A. What will happen? How it will affect? So simply I can write rate dash. I'm writing rate dash. They are telling the answers, I hope.
Very fast you will say that.
Yeah, 9 times. Yeah, great to see that. Yeah. Nothing. Rate dash I'm taking. K into A become what, sir? 2A, 3 times. Okay. So 3A square into B become B itself.
Yes.
So here this will be 9 into 3 square means 9. K A square into B will come. This K A square into B means that is nothing, that is rate only. So 9 times rate.
And during the examination we saw that you know the answer already. Yes, fine.
But
And
you have to write like this.
Initially they will write immediately 9 times finish. They are all they won't give full marks. Okay. All.
So
the
you have to
steps
write the
we have to
steps.
write.
You have to write the steps. Okay, that is very important. I mean, unless and if it is a MCQ question, you can do like that.
That's-
But it is
but
a
step
2-mark
is
question.
mandatory.
That time step is must. Okay, step you have to write completely. You
called
have to write.
descriptive exam.
That's why only we are writing like this. Okay, we also getting the answer 9 times initially. Okay, like you, we already got it. But you have to write like this. Okay, 9 times write. Okay, now ready. So then again,
Next question.
next question. How is the rate affected when the concentration of both A and B are double?
Yes.
Hridya, you got the wrong answer. I think 8 times.
I think they're saying
They're
about
telling
the second one.
third question only.
Third question they
Okay.
are telling.
They're telling the
Yes,
third question. Okay,
correct.
correct. Okay. How is the rate affected when the concentration of both A and B are doubled? We are doubling A and B. I will take the another thing, sir. Okay. So rate is equal to what's the formula we have? K into A square into B. So here now what you are doing, sir, we are doubling both A and B, we are doubling. A become 2A, B become 2B. That time you may be thinking like that, why sir K is not changing? K will change when and only when the temperature change. Okay, the temperature change. That idea you have to remember. So rate dash I am taking. So K will be remains constant. What will be happen to A? 2A square. What will happen to B? 2B. It will be become 2B. So 2 square into 2. 4 into 2 will come. Then K into remaining A square into B will be there. What is K into A square into B? So 8 into rate. So it will be become new rate. Rate dash means 8 times the initial rate. So answer is 8 times the initial rate. I hope you guys got it.
Yes.
So here while you are looking the third question, that's the correct one. I hope you got it. Ready? If it's so, then we can move to the next question. What they are telling. Again, this kind of question we already did it. Anyhow, we are doing one more time. A first order reaction takes 40 minutes for 30% decomposition. So 30% decomposition occur. Okay, so T 30%. So they given what? T 30% they given. Okay, I will take one more. So T 30% they given. T 30% is equal to 40 minutes they given. Okay, 40 minutes they given. Okay, then they are asking you to find out what's the question they are asking you to find out. They are asking you to find out T half for the reaction. Okay, they are asking you to find out T half for the reaction. Okay, so
first we can calculate the rate.
rate constant. If we know the T half means first order means 0.693 by K only. So if we want to know the K means we must have to know the we must have to solve this one. What is T 30%? 2.303 by K log R0. What is initial I am taking? 100 I am taking. 30% decomposition takes place means remaining 70%. Okay, initially 100 I am taking. 30% completed means remaining is 70. So initial by final. Okay, equal to 40 they given. So I am taking K to left hand side. So K equal to K I am taking to there. Then what is remaining there? 2.303. That 40 will come down. Then into log 10 by 7. Log 10 by 7 value already they given in the option. Where here they already given in the question they given 10 by 7 equal to 1.428. Okay. So their log 1.428 is 0.1548. Okay, what's the value? 0.1548. Okay, so I can substitute 2.303 divided by 40 into 0.148 only, right? Yes. So we will get, while we are solving this one, we will get the answer 0.0089. Okay, 0.0089 minute inverse. Okay, the unit is minute inverse. 0.0089 minute inverse we will get. Okay, then they are asking you to find out T half. What's the T half? 0.693 by 0.693 by 0.0089. So we will get How much we will get? Already they are telling the answers. Yes, 77.7 minutes. Yes. Sir, while I am seeing the answers that time itself, I am becoming so much happy. That much effort you took, Digna. That's the thing. Yeah.
You are already prepared, I think.
Yeah, they are prepared. Okay,
So
that
you have to
confidence
just
we need. Okay, yes.
Just polish and we want to recollect all the things.
That's why only this Maha Marathon. Okay, that's why only we came to boost your confidence. Okay, so I think we can go to the next question, guys. Okay, we are not wasting your time. So we are going to the next question, sir. Listen to me. Next question. Explain the following terms. Order of reaction that we already told. I already told you. Order of reaction is the sum of powers of concentration terms expressed in Raoult equation. That's it. What is molecularity of a reaction? It is the number of reacting species which may be atoms, ions or molecules which collide simultaneously in an elementary chemical reaction. Okay, elementary chemical reaction. It is the number of reacting species which collide simultaneously in an elementary chemical reaction. That's called the molecularity of a reaction. Okay, fine. Then the next question, calculate the overall order of reaction whose Raoult expression was given. Raoult expression they already gave. Then they are asking about the order.
Of the reaction.
What's the order? Order means it's the sum of powers of concentration time. 3/2 plus 1/2. 1.5 plus 0.5. So that means 2 is the answer. Order is 2. That's it. I hope you guys already got it. Yes. Hanna is Hanna. Okay, Hanna got the answer. And Mohapatra got the answer. Yes. Yes, Nambudiri, great. Hiridya Srini. Yes, nice to see that. Where is Ramanujan? Okay. Yes, we can go to the next one. Okay. Yes. I think Ramanujan, initially he came, now he is not there. Okay. Yes. Salman Shihab, great to see. Okay. Yes, we can go to the next one. Next question. This is the next question, guys. What is mean by the rate constant K of a reaction? What do you mean by rate constant K of a reaction? You know, if I am having reactant react to give products, how I can write the rate law? Rate is equal to K into concentration of R raised to X. R raised to X. I don't know what is X. I don't know the order. Okay, if it is 0 order means 0. If it is first order means 1. Second order means 2. Nth order means N. Okay, I am writing like that. Then I am telling if concentration of R equal to 1 mole per liter. 1 mole per liter. Then what will be happen to rate? Rate equal to K. So rate constant is nothing but it is the rate of reaction when the concentration of reactants are taken as unity. That's it. Okay. Then if the concentration is expressed in mole liter inverse unit, then and time in second, what will be the unit for K for a zero order reaction? You know, for nth order, we already learned, they already learned mole liter inverse all raised to 1 minus n second inverse. This is the equation for nth order. So for first zero order, what will be the unit of rate constant? Nothing to think. If you don't know that one also, you can write the zero order case, the rate constant as well as rate has same unit. You can substitute n equal to 0. Then what you will get? Mole liter inverse second inverse is for zero order. And for first order, you can substitute 1 here. So 1 minus 1, that will go. Everyone will know, I hope. Everyone, those who are studying in +2, everyone know the value. That is second inverse only for which order? First order. Very simple. Anyhow, if you remember this one means, if they are asking to second order, third order, they are not going to ask that one. Okay. So anyhow, zero order and first order you have to remember. This is the idea. That's it. Okay. You got the concept, I hope. They are telling the answer, no sir? Yes. So we have to see that fire. Show me that fire. And energy. We have to see that. Put that heart in the comment box, please. Yes. Come on everybody. Sir, come sir. Deepak sir, where is the students? Yes, Muhammad Isham, Hanna. Yes.
How many are there?
Yes, we want to. I hope you are not at all be sleeping. Okay. Yes. Satvik is showing 100. Yes, Satvik. Great. Yes, Nachiappan. Yes, Anna MS. Yeah, now that's the spirit. Okay, you have to show that energy. We are showing this much energy. That time you have to show that energy there. Okay. Yes. They are there. Okay. Yes, we are racing the board with this one. Yes, great to see that, Babu. Okay, we can go to the next one.
Okay,
yes, we can go to the next one. That chapter is over. Okay, 10 questions we already completed, guys.
Yes.
Chemical kinetics is over. Now we are moving to coordination compounds. Okay, coordination compounds. Here mainly we have to learn about type of ligands. which all are the ligands and all that idea, monodentate, bidentate, blah blah blah, that idea you learned, EDTA, hexadentate, that idea they learned, no, sir? Yes, they learned. Then IUPAC naming, that's very important. At least minimum one question they are going to ask, I hope.
They can ask
Definitely
either
that.
by giving the structure
Yeah.
to name or name to structure.
Yes,
what kind
yes.
of question we can
Any one question will be there, okay, note down. And next one, primary and secondary valency. Primary and secondary valency, yeah.
Last year, 2023 board exam.
Werner's theory, Werner's theory.
From this one.
Werner's theory, don't forget, okay. And homoleptic and heteroleptic.
Last year, the I think the
Nothing to
MCQ
think,
part they
nothing to
asked
think.
from
Homo,
heteroleptic
same,
complex.
same, hetero, same but different, okay. Homo means same, yes, yeah. Hetero means different, okay. That idea they know. VBT, valence bond theory.
Sure question from VBT, the 5 questions. Maybe they ask you the geometry, inner or outer, low spin or high spin, para or dia, whether it is colored or colorless, everything we can
Everything they can ask.
VBT.
Then CFT, crystal field splitting theory, that idea,
Expected
okay.
question in
That
this
idea.
year.
Colored and stability of complex, okay. Color and stability of the complex, that idea. Whenever there is a chelating ligand is there, that time stability will be there, okay. Yes, I remember all the thing, same but different, okay. They are also telling the same song, okay.
Yeah.
Nice to see that, okay. So metal carbonyl, okay. Metal carbonyl synergic bond and idea. Then isomerism is there. Then application of complex, okay.
So this last part, most of the students are leaving this application of
complex.
coordination
That
combo.
idea also you have to remember.
Cisplatin, the Prussian blue colored complex.
Prussian blue colored complex.
Please study
And
once again.
cobalt is actually that vitamin B12, that idea. Cyanocobalamin, that idea. Okay, that idea. Where and all using, okay.
Let's go for the questions, right?
Let's go to the question, guys. This is the first question. Yes, that's the question related to IUPAC nomenclature. What's the question? Penta-amine, carbonato, cobalt 3 chloride. We have to draw the structure. Penta-amine.
Students already, those who know already the answer, I think you made little difficult to type in the chat box, but still we are waiting for that answer. Can you comment in the chat box, all of you? You just ready? Others, please listen here.
At the same time, I'm writing, okay. So penta-amine. So NH3 5 times, okay. NH3 5 times. Carbonato, CO3 and cobalt. I can write cobalt here. This cobalt, CO in small letter O, this one in capital letter O. Okay, I think they won't forget that one, okay. So into chlorine. Here chlorine should come, but you have to remember the cobalt to oxidation state is 3. Cobalt to oxidation state is 3. Sir, cobalt to oxidation state is 3. Here carbonate is -2. Chlorine is -1. Automatically no need of number. So that's it. Correct. I hope you got it. Cobalt, NH3 5, CO3 Cl. That's it.
So sometimes maybe even the arrangement itself, it is correct, mean please don't do any adjustment. Otherwise, what we can do that, we can adjust the number of
the counter ion, okay. At that time only we can adjust, okay.
Okay, right?
Yeah, that's okay.
Yes,
next question, guys. Potassium tetracyanidonickellate. While you are seeing nickelate, that time itself you have to remember our coordination sphere is negative. Our coordination sphere is negative, so potassium is the counter ion, K. Then I am writing coordination sphere, I am writing tetracyanido. So Cn 4 times and nickel. Nickellate means nickel. So now I have to arrange it. What's the value of nickel should get? Nickel should get the value 2. Here potassium is +1 only. Okay now. And here while you are looking this one, Cn is -4. This nickel is how much? 2 only. Nickel is +2 only. So the entire coordination sphere will get +2 and -4. While you are adding, you will get -2. And potassium is how much? Potassium is how much it will come? It will come tetra only, sir. Okay. Potassium is how much will come? +1 will come. Now you have to write this one here and this one here you have to write. So what's the formula you will get? K2 Ni, okay, Cn 4 times. That's the answer. K2 Ni Cn 4 times. Okay.
Really, we need to appreciate those students who are giving the comment in the chat box because they are typing.
They are taking that much effort. They are taking that much effort. Yes, great to see that.
Very good, all of you. Keep going.
Nice. Okay. So then we can go to the next question, guys. This is the next question. Give the IUPAC name. Again, we are putting the IUPAC name. So don't forget that idea. That's why only we are putting that question again. Okay. So give the IUPAC name and electronic configuration of central metal atom in terms of T2G and EG of K4MnCN6. Okay. They gave K4 MnCN6. Okay, it's IUPAC name. First of all, we have to write. What's IUPAC name? Potassium. Whether I have to write the number? No need. If the counter ion number is no need, then no, I hope. Okay. Potassium hexa. Cyanido. Manganate. Manganate. And I have to write the charge. What's the charge? Here potassium is plus 1. Manganese X, this is minus 1. So 1 plus X minus 6 equal to 0. While I'm adding all together 0. X equal to how much I will get? So sorry, 4 is there. 4 potassium. 4. So X equal to how much I will get? Plus 2 I will get. I am writing all the things here because you don't want to forget it. You have to recollect it. Okay, that's it. So what's the name? Potassium hexacyanide two. Okay, that's it. That's the name. Then they are asking another question. Write the electronic configuration of central metal atom in terms of T2G and EG. So here central metal atom is manganese. Manganese is in which oxidation state? Plus 2. Plus 2 oxidation. We know the atomic number of manganese, that is 25. So its electronic configuration is argon 4s2 3d5. Okay, na dears? So while it is Mn2 plus means this 4s2 electron is missing. So only argon 3d5 is there. Okay, 3d5 is there. That means D have 5 electrons. But here you can see this cyanide is a what kind of ligand? Strong or weak? That's a strong ligand. Strong ligand means the splitting energy will be more. So what will happen? We can write the electronic configuration T2G and EG. So they cannot go to EG. So all the electron will be available in where only? T2G only it will be available, and here it will be 0. So T2G 5. EG0. Very good, very good, very good. Hridya Srini, nice to see that. Okay. And Smriti Ganesh, Anna MS, all of you are telling the answers. Great to see that. So T2G5, EG0. That idea, that's the thing. And again, next one. What is mean by chelate effect? Give an example. This is an important one. Chelate ligands are the ligands which they are bidentate or polydentate ligand. Bidentate or polydentate ligand which can bind to the central metal atom through more than one atoms, and they will form a ring-like structure. They will form a ring-like structure. Okay, ring structure with the central metal atom. That effect is called chelate effect. Okay, or chelation, and the ligands are called chelating ligand. So they should be minimum. They have to give 2 atoms. 2 atoms. Okay, 2 atoms are ready to donate the electron pairs. So they are asking about, give an example. We can give the example. Which example, sir? We can take ethane 1,2-diamine.
Yes.
So I will write NH2, CH2, then again CH2, then NH2. Okay, here one lone pair is there, here one lone pair is there. Here our central metal atom is there. Yeah. What will happen? This nitrogen will donate electron to central metal atom. Here also they will donate electron to central metal atom. Automatically they will form what?
Ring structure.
Ring structure. They will form a ring structure. Or else you can take, you don't want to write this much. Instead of that, they can write EN. Okay, you can write like that also. I hope you got the idea. Yes. EDTA also chelating ligand only.
And
EDTA also.
From this coordination compound chapter, since it is inorganic chapter, my dear student, you can expect lot of definition questions like what is ambidentate ligand, what is chelating ligand, what is the spectrochemical series definition, what is CFSC.
And that idea.
I think some students ask that whether they ask the limitations of VBT and all.
They will ask. Okay, limitations of that idea. They will ask. So that you have to remember. Okay, color cannot be explained like this. So many things. Stability they cannot explain. There are a lot of assumptions. That all are the important drawbacks of VBT that you have to remember. Okay. If it's so, then we can move to the next question, sir. Okay, students are ready. I hope they are ready, sir. How do we remember the example for different questions? Okay.
Just they are asking which all are the bidentate ligand.
Bidentate.
Even you just open the your question paper related to coordination compound. Lot of
so many questions will be there. There you can see. Okay. First you have to read all the questions. That time itself, some questions answer will be there itself.
Will be there.
There. Okay, no problem. Okay, Smriti, I think we can go. We can go to the next one now. So this is the next question, guys. Write the IUPAC name again and the hybridization of the following complex. This is again related to valence bond theory only. While you are finding the hybridization means valence bond theory you are using. What's the name of this one? First one I will write here, sir. CO NH3 6 times 3 plus. What's the name? Hexaamine cobalt. What's the oxidation state? Here it is Xa0, then that will be 3 will be coming. Okay, 3 ion. That is better. Yes. Okay, ion. So ion, so you have to write ion. Then they are asking about the hybridization. How I can start the hybridization? Here the central metal atom is what? Cobalt. Cobalt is the central metal atom. Cobalt atomic number is 27. Argon 4s2 3d7. But here the oxidation state of cobalt is 3 plus. So cobalt 3 plus means 3 electron is missing. So argon 3d6 only will come.
Yes.
Okay, argon 3d6 only will come. Then we can draw the ground state here. What about ground state, sir? In 3D, how many electrons are there, sir? 6.
electrons are
So
there.
6 electrons are there. 1, 2, 3, 4, 5. 6 electrons are there. This is 3D. After here, 4s is there.
4p
Here
is
what
there.
is there? 4p is there. Okay, here 4p is there. Now tell me, guys, what about the case of ammonia? Is it a strong ligand or weak ligand? Tell me, what about this one? Ammonia.
Ammonia is a strong
Ammonia,
ligand or weak
cyanide, carbon monoxide are strong ligand. Ammonia, cyanide, carbon monoxide are strong ligand. So what will happen whenever this ammonia approaching this cobalt 3 plus, they will undergo excitation. How they will excite? If it is a strong ligand means they will pair it up. They will pair it up. So how the
All
pairing?
4 electrons get paired.
All will be paired. Okay,
two,
all will be
two.
paired. So 2 will be there, 2 will be there, 2 will be there.
Yes.
Then how many ammonia are coming? 6.
Six.
So automatically how many orbital undergo
Six.
intermixing? 6.
Six
Here this is
orbitals.
3D, this is 4s, this is 4p. How many orbital undergo intermixing, sir? Here
Six
this
are
one,
there.
this
So
2, this one, then
4, 5, 6.
this one. So 1, 2, 3, 4, 5, 6. That means 2 3d orbitals plus 1 4s orbital plus 3 4p orbital undergo intermixing and they will produce
D2
6
sp3.
D2 sp3 hybridized orbital. And from here you have to remember one more thing. All the electrons are paired. That's why diamagnetic. If there anyone is unpaired, paramagnetic. And also they are taking the D, inner D they are taking, not outer D. You are telling D first. That's why it is inner D orbital complex. And all are paired. So that's why it is low spin complex. That's it. That much idea we will get. Okay. Anyhow, here they are asking only about hybridization. So answer is D2 sp3. They got the answer, I hope.
Yes.
Okay. Then if it's so, then we can move to the next one. NiCl4 2 minus. I will do it here, sir. NiCl4 2 minus. Okay. NiCl4 2 minus. What about this case? What's the name of the compound?
Chlorido.
Chlorido,
Nickelate.
not nickel. Nickelate, because the coordination sphere complex is
the
negative.
anionic part.
Yeah, nickelate. What's the charge? What's the charge?
2.
So x, this one is -1. So x minus 4 equal to -2, x equal to 2.
2.
Ion. That's the idea you have to remember. Then I am writing the what? Their hybridization I want to find out. So nickel is the central atom. Its atomic number is 28. Argon 4s2 3d8. Okay, argon 4s2 3d8 is the nickel. But here nickel oxidation state is 2 plus. So that's why nickel 2 plus. How it will be? 4s2 is missing. Then only 3d is there. 3d8 is there. I am drawing the ground state. What about ground state? 3d contain how many electrons, sir? 3d 1, 2, 3, 4, 5, 6, 7, 8 are there.
Yes.
Then here S
4s
is there
free.
and here
4p is
P
free.
is there. Okay, this is 3d, 4s,
And
4p.
4p.
Now what happened to excited state means whenever this chloride is approaching our nickel 2 plus. This chloride is a ligand that is approaching our nickel 2 plus to donate electron. That time this nickel 2 plus become excited. How they will excite? Here in the chloride is actually a weak ligand. Excitement will be similar to the ground state. So there is no pairing. Pairing won't happen. Okay. Pairing won't happen. So the same state only I can draw. Here I am drawing again. Okay. I hope you guys are seeing this one properly. Okay. So here 3D, 4S and 4P. Here 1, 2, 3, 4, 5, 6, 7, 8. Okay. So like that. Okay. Okay now. Ready. Here one more will be there.
Yes.
6 and 7, 8.
Yes,
Okay.
7, 8.
So then what's the idea? No pairing only. Correct only.
Total how
Then
many ligands are there?
four chlorine atoms are coming. So 4 chlorine ions are coming, Cl minus are coming. Automatically we required 4 orbitals. Which all are the orbital undergo intermixing? Here the one with vacancy one only will intermix. So here 1, 2, 3. So that means 1 4s and 3 4p are mixing. So they will produce 4 sp3 hybrid orbital will form. So tetrahedral. Is it paramagnetic or diamagnetic? It is paramagnetic because unpaired electrons are there. And then we cannot tell about inner or outer because we are taking sp3. Okay, if it comes D only, we are tell inner or outer. Then one more thing is there. Is it high spin or low spin? It is high spin because if more than one unpaired is there means high spin complex. Okay, that idea is there. You have to remember. Okay, ready. Hridya Srini, yes. Okay, so paramagnetic. Okay, great to see that. Okay, if it's so, then we can move to the next question, sir. Shall we go to the next question? Yes or no?
So I hope you all are getting the concepts and all, and I hope you can able to revise everything. So now still we are in the physical chemistry. and
Sir,
organic
we
chemistry,
have
one of the
to
important
we have
area.
to appreciate them, sir. They are now the time is 5:27. We started at 3 o'clock. Around 2.5 hours they are waiting. They are eagerly waiting and they are watching and they are doing. Yes. Nice to see that. Okay, guys.
Yes.
Okay.
3.5
So
thing around
the love and the affection. Okay, great. Yeah.
3.5 hours now we completed.
Now we completed. Okay, now we completed our journey. Only half completed. Remaining is there. Organic is there. Now we are with the inorganic only. Okay, organic is there. Yes.
let's go for the next
Yeah,
one,
next
sir.
we can go to the next one. Okay. What's the thing?
So should we show the working of hybridization? Can we just write the answer? So if they ask, that's depend on the marks, Ash. If they ask 3-mark questions and all regarding VBT,
You have to explain it
definitely-
fully. You have to explain.
Yes, definitely we have to explain. Even they given 2 compound means step 1, step 2, step 3, step 1, step 2, step 3, it is required. Okay.
Then only you will get the mark.
Yes.
So next question. This is the next question, guys. Out of cis platinum En twice Cl2 2 plus and trans platinum En twice Cl2 2 plus, which one is optically active? That idea you already learned. Cis one is optically active. Trans one is not optically active. If you want to explain it means you can take in the case of cis, while we are considering cis around platinum, what is the coordination number? En is 2 only, so 2 into 2 4 plus 2 6 will come. So here 6 ligands are there. I mean octahedral only the complex. I can draw the structure like this while I am drawing. Okay, you can see here En will connect with the 2 bonds like this. This is one En and this is another En, guys. Okay, here Cl, here Cl. Okay, the entire charge is 2 plus. Okay, I am not representing that one. Okay, if you want means you can represent 2 plus. Okay, so this one 2 plus and its mirror image while I am taking. This is cis only. This is cis only. While I am taking the mirror image, what will happen? The entire thing will be reversed. Here it will be coming like you can see guys. It will be like this. Okay, it will be this En will come here. This side En will come and this En will come here. En will come here. Cl will be here. Cl will be here. 2 plus. Actually, they are not superimposable. They are not superimposable. That's why they are optically active. Cis is optically active. That idea you have to remember. Cis is optically active. If they are simply asking for one mark or half mark means directly you can write the answer. If it is 2 mark question means you have to draw the structure and you have to answer it properly. If it is the case of trans, how I can draw? If it is the case of trans, how I can draw? Platinum is there. Around it 6 ligand. I mean 6 coordination number is there. Trans means I am taking En here. Why I am writing like this? En have density 2, so that's why with the 2 atom they are connecting our central metal atom. Okay, here also another one is coming and here Cl, here Cl. This is the charge. Okay, 2 plus. And if I am taking the mirror image means what will happen, sir?
That
What will happen?
Super impossible.
Then same only I will get. Okay, same only I will get. Here Cl will be there. Here Cl will be there. En will be there. So automatically. They are superimposable. They are superimposable. Trans is superimposable. Cis is not superimposable. That's why cis is optically active. That idea you have to remember. Okay, now if it shall we go to the next one?
Yes.
Okay, we can go to the next one, sir. Next question is write the IUPAC name of the complex. We have to write the IUPAC name of this complex. Okay, COEN twice NO2 Cl plus. Okay, here the coordination compound name is actually chlorido. Okay, here En is ethane 1,2-diamine. So we have to use bis ethane 1,2-diamine. Bis ethane 1,2-diamine. Okay, bis ethane 1,2-diamine. Bis ethane 1,2-diamine. Okay, bis ethane 1,2-diamine. Nitrate. Okay, can I write here, na sir? Yeah. Nitrito through N.
Nitrogen.
Then cobalt. Its charge is 0. Here it is 0. This is -1. This -1. So x, this is x plus 0 plus -1 plus -1 equal to +1. So x equal to 3 ion. That's the answer. Then again they are asking what type of structural isomerism is shown by this complex. Here you can see ambidentate ligand NO2 is there. That NO2 can attach the central metal atom through N as well as through O. So that's why they can show which isomerism? Linkage isomerism. They can show linkage isomerism. What is the linkage isomer of this one? CO, En twice, ONO, Cl plus will be the linkage isomer. If you write that one means it will be more easy.
Yeah.
You will get the maximum mark. Yeah.
One thing I will just inform you that sometimes they ask you write the IUPAC name of the linkage isomer of this complex.
That time you have to write the this
name
one.
of this compound. So immediately don't write the name of this compound. Read the question carefully. Write the name of the ionization isomer. Write the name of the linkage isomer. So make the isomer first, then write to.
Here
name
they
of
are
the
asking directly, so no problem.
Yes.
Okay. Shall we go to the
Yes,
next one, sir?
next one, speed.
Yes. Okay. This the next question, 36th question. Although both NiCl4 2 minus and NiCO4 have sp3 hybridization, they are telling this one is sp3 and this one also sp3. Yet NiCl4 2 minus is paramagnetic and NiCO4 is diamagnetic. Give reason. If they are asking like this, if it is a 2 or 3 mark question means you have to write everything. Everything you have to write and you have to show. About NiCl4 2 minus already we shown. Okay, whether I have to write it, sir, or we have to show it again.
I think they can able to understand.
Yeah,
that.
they can understand. Here it is there.
Only
Okay.
the confusion is students still asking. We can able to understand.
Yeah.
So you are thinking, you are always trying to reduce the content of that. That depends on that.
This
they
one.
will reduce your marks. That you careful. Chemistry point of view, when you answering the paper, more points you should write, all of you. There is no compromise in that one. So please don't ask the questions like, sir, we need to write this point, that point, like that. We need to write everything. We need to write everything as per chemistry marking scheme that I am saying. Okay, please.
Okay. So this is the one NiCl4 2 minus. This one we already did it. Okay. So here sp3 and it is paramagnetic. Why it is paramagnetic? We already told. Here what is there? Unpaired electrons are there. That's why it is paramagnetic. Okay. That idea we know. Okay, na sir? Okay. Then we can move to the next one. That is NiCO4 also they are asking. About NiCO4 they are asking. NiCO4 they are asking. Here in the case of carbonyl, it is oxidation state is, carbonyl charge is 0. So that's why nickel is in 0 oxidation state only. Argon 4s2 3d8. So in ground state, excited state, both are they are like this only. Nickel oxidation state is 0 only. So directly we can draw the structure. 3d8 is there. Okay, ground state we can draw. There is no need of oxidation state. That only I am telling. Ground state 1, 2, 3, 4, 5, 6, 7, 8. And here 4s also contain 2 electrons. Here there is a very important thing you have to remember, guys. Here 4p is there. Okay, here 4p is there. Then what about the case of excited state? That idea you have to remember. Don't forget. Excited state means whenever carbon monoxide is coming to donate electron pair to nickel. Carbon monoxide is a strong ligand. Pairing will occur. So how the pairing will occur, guys? How the pairing will occur? That is very important. So here 2, this 2, this 2, and this will come to here. This will pair up as well as the electron from 4s also will come to 3D. 4s also will come to 3D. Then 4s is empty and 4p is also empty. Now how many are coming? 4 carbon monoxide are coming. Automatically we have to take 4 orbital, vacant orbital we have to take for hybridization. 1 4s plus 3 4p we have to take. That's why 4 sp3 hybrid orbital we will get. What about the magnetism? Here all are paired, automatically diamagnetic. In the case of NiCl4 what's the case? They are paramagnetic. That's the idea. I hope you guys got the idea now. Ready? So that's the reason. Write the electronic configuration of D5 on the basis of crystal field theory when delta O is what? Octahedral crystal field splitting energy is less than that of pairing energy, and if it is greater, what will happen? I will take the next slide here. So we are having D5 configuration. If delta O is greater than P means what? There's a strong field ligand. So T2G and EG will be having large difference. So that time Oh, electron cannot go to Eg. All the electron will be come over where only? T2G only. T2G, Eg0. That's it. Okay. And if delta O is less, pairing energy is more. Whenever the fourth electron coming to T2G, again there is a pairing. There's a repulsion is more, means electron will go to that splitting is less.
Yes.
So that means T2G will be filled with 3, then 2 will be go to 2. T2G, Eg2. That's all. I hope you guys got it. Ready? Yes, answer is coming. Answer is coming. Okay, great to see that, guys. Okay. So that's it. Yeah, AB. That's it.
So the same thing.
If they're asking about
they can ask you D4,
D4, D6.
D8, any system they can ask. But remember, delta O less mean what? There is a pairing won't happen. Delta O greater mean pairing can happen.
Pairing can happen.
Accordingly, arrange the
A
electron.
delta O greater means that large splitting. So pairing only possibility. They cannot go to top. That's it. Okay, fine. If we can, then we can move to the next one. This is the next one, guys. Give one chemical test as an evidence to show that CONH3 okay, listen to me very carefully. CONH3 ClSO4, okay, as well as CONH3 SO4 Cl.
I think
While you are
just wait. Let us see how many of them are giving the correct answer. Can you say, dear students, which test you can use to distinguish between these two compounds? Can you please comment? Which one?
Yeah, you comment. Snowflake is asking one, should we mention 4sp3? Actually, I am writing the number. If you are mixing 4sp3, 4 are coming now. That's it. Okay.
Yes, Rida.
Yeah, Rida is telling the correct answer. Great, Rida. Hands up. Okay, yeah.
Silver nitrate or barium sulfate.
Barium sulfate, okay.
Silver nitrate or barium sulfate.
So here, while you are taking this one, Cl is here. While you are taking silver nitrate, guys, while you are treating silver nitrate with this two, okay, if you are taking this one in one beaker, this one in another beaker, that time while you are treating with the silver nitrate, this one, the chlorine is coming as a counter ion, that only will react with the silver nitrate, okay, and it will produce what? AgCl. So it is a white precipitate. It cannot give white precipitate. That's it. Instead of that, if you are using
barium
sulfate,
then
okay, what will happen?
Barium will combine with this first compound.
Barium chloride.
Barium
Barium chloride. That time, barium chloride. Once you are taking barium chloride, you are taking that time. Barium chloride will react with this one. Barium sulfate. That also white precipitate. So anyone you can take either AgCl, AgNO3. AgNO3 will give AgCl. Only this one only will give. Yes. And barium chloride, if you take, means barium sulfate will be given by this one only. Anyone you can take. Okay, distinguish. Find the magnetic moment of the following complex. Sir, next question, I think they are okay now?
Yes.
Yeah. Next one, find the magnetic moment of the complex FeH2O. That I will take the next slide, sir. FeH2O 6 times 2 plus. Here the oxidized state of iron is 2 plus. Okay, I can write iron 2 plus. Directly I can write. No problem. Now argon 3d6 will come. 4s2 3d6 only. So 2 plus means 3d6. I can write 3d. 3d I can write like this. You can see 1, 2, 3, 4, 5, 6 electrons are there. What about H2O? Is it a strong ligand or weak ligand? Comment please.
H2O is a weak ligand, I think.
Weak ligand or strong ligand? Tell me. It's a weak ligand. Automatically pairing won't take place. Okay, pairing won't take place. So pairing won't take place means how many unpaired are there? 4 unpaired are there. Then how we can find out the magnetic moment mu? Equal to root of n into n plus 2 Bohr magneton. Okay, so root of how many are unpaired? 4. So 4 into 6. So that means root 24 Bohr magneton.
Yeah.
Root 24 means 4.9 will come or 4.8. Okay, 4.9 or 4.8 Bohr magneton will come. That's the answer. Okay. So here, while we are looking the comment box, one person is commenting, sir, at least give me some 2 or 3 minutes, sir. Okay, like that they're telling. So you have to think like that. This is the last minute.
See,
last lab.
Yeah, after this examination, you have enough time.
To relax. Okay.
This time,
So the thing is that before reaching destination, if you take a rest means the entire life you have to take the rest.
Yes.
Okay.
Please don't ask
Nothing
any
to tell.
excuse now.
No, don't ask any excuse now. Okay. We have to be energetic, guys. Okay, we have to be energetic. We have to do these things. Okay, we have to get the maximum mark.
Even it's a 10 o'clock or 11 o'clock, we will.
We are ready. We are ready here. Okay, you just look at our faces.
Yeah.
How energetic we are. Yes or no?
Because we are not the one thing you keep in mind. We are not the guys. We are going to write the examination.
You are only right there.
You are the one writing the examination. So you should have a lot of memory power regarding these kind of things. So that what we are doing means. So please don't take tea, take water and everything. Please ask your father, mother, mom, bring this one and be ready with all these things. We should be healthy at the same time. Okay, don't be sleep and don't be afraid of this one. Chemistry exam will be there all. We will make it easier.
And we have to get the full mark.
Yeah, definitely.
Power. Okay, yes, okay. So shall we go to the next
Yes,
one?
next question.
Okay. So we can go to the next one.
Yeah.
Yes. This is the next question, guys. 38th question. When a coordination compound CrCl3.6H2O is mixed with AgNO3, 2 moles of AgCl are precipitated. So while I am mixing CrCl3.6H2O, while I am mixing with AgNO3, they are telling mixing with AgNO3, they are telling how many AgCl? 2 AgCl are precipitated, meaning in this compound 2 Cl are present as counter ion.
Yes.
So how I can write? Cr, then Cl, only one Cl will be inside. And H2O 5 times, because we have to know chromium is a hexa and hexa only, its coordination sphere is 6 only. So Cr, Cl, H2O 5 is coming, then outer side Cl2 is there, then dot 1 H2O is there, because this 2 Cl2 only will react in with the AgNO3 and produce 2 AgCl. Okay, that's the idea you have to remember. Then next question, along with that, what is the structural formula of the coordination compound that we already wrote? Cr, Cl, H2O5, Cl2 dot H2O. Idea is clear, I hope.
That maximum 6 ligands we can place it inside. So what all? So 2 AgCl formed mean 2 chlorine outside.
If suppose if the question is like this, if they are telling only 1 mole of AgCl precipitated, what will happen? 1 mole of AgCl means this Cl also will come inside.
One Cl
so
inside.
Cr will be there, then
Cl2,
then
H2O
4 times. Then Cl
and
dot
2H2O.
2H2O.
Yes.
If they are telling 3 AgCl means what will happen? All the Cl will be outside.
and
That's
all
it.
6 H2O
6
inside.
H2O will be inside. That's it. That idea you know, I hope. Yes, everyone are telling the answers. Great to see that. Okay, great. I think we can move to the next question,
Yes,
sir.
next one.
Okay, this is the next question. Arrange the following in increasing order of crystal field splitting energy. That is what? That is the land.
Compulsory to know, my dear students, spectrochemical
series.
The definition and the complete order.
Order.
Complete.
Yeah. So here the thing is that cyanide is there, NH3 is there, Cl is there. We know halogens have low crystal field splitting energy. That's actually the demerit actually.
Yes.
So here,
energy order we can say first.
yeah, you're right, sir.
Which is the highest, which one the crystal field splitting energy, which one can make, which is the strongest ligand, whether cyanide or amine. Can you say?
Can you say? We are waiting.
Amine, which is the strongest ligand in the spectrochemical series. Immediate answer. Immediate, very cute.
Not this one, not this. Okay, cyanide or Cl?
Cyanide.
Yeah,
is
cyanide. Cyanide will
ligand.
strongest one. So
Yeah.
Cr, Cn6, 3 minus will come first. Then after that, which one will come? Cr, NH3,
plus
6, 3 plus will come. Then which one will come?
Cr,
Cl6, 3 minus will come.
Yes.
That's it.
This
So
is
meaning Cl minus here is a weak ligand. Then NH3, then Cn minus. That's the idea.
And don't forget the question here. This is energy question. We studied a question related to wavelength.
Wavelength also. That will be just opposite.
Energy is what that is inversely proportional.
Energy is
what
equal
lambda.
to Hc by lambda. That's a formula. This Hc is a constant and energy and lambda are inversely proportional. Okay, guys,
Let's
ready?
go for the last question, right?
Yes. Cyanide. Yes, great. Okay, we can move to the next one. Which of the following is more stable? This is the last question in coordination compound. Which of the following is more stable complex and why? We are waiting. Yes, come on, everybody.
Which is the most stable complex? You know what are the most things which stabilize a complex? Oxidation state.
Yes, they are telling the answer. DK sir.
Ligand is
They are
there.
telling. Come on, DK sir. They are telling the answer. Okay. DK sir is again here DK sir, okay, because of chelate ligand. Yeah. Yes. En complex, yes. While we are looking this one, CONH363 plus as well as COEN33 plus. Here while we are looking this one En is a chelating ligand. Okay, chelating ligand comes means the coordination compound strength will increase, stability will increase. There are mainly three factors are there. I mean, the charge of cation increases as well as the ability of the ligand to donate electron pair, that increases basicity, and the last one chelating ligand. Then that will be the most stable one. That's all about coordination compound. I hope you guys are okay with the coordination compound. Ready now? If it's so, then again DK sir is in the stage. Okay, he is going to take the D and F. I will be here. Okay, no problem.
D and F is, I think, sir, their favorite chapter, right?
Yes.
All
Okay.
will respond.
They were asking, Satvik is asking about what? What about potassium permanganate, K2Cr2, ozone, okay. Yes, let's see.
Yes.
Okay, sir.
Yeah. So, dear students, we are not going to give any break. All should be there. Be active. Okay, only for today. Tell your parents to bring some snack and tea. So, we need to continue. Okay, so we need to finish all the chapter. Next chapter, D and F. I know that one. Okay, you guys are very happy to hear that name. Yes, Asim, Naveed, thank you so much. Yes, we are going to continue that D and F block element chapter. Okay, we need to discuss all the points. Yes, hope you all are there. Guys, be active, note it down all the important points. The inorganic chapter, the next one, you know that one 7 mark weightage is there, and you can easily score mark from D and F, don't worry. Okay, all the question, most of the question will be repeating the pattern. If you have checked with the previous board papers and all the questions, you know that one, it will be same, they will be asking. See what all points we need to focus, that we can go through first. Yes, Ansh, Satvik, yeah, all are there. See, D and F block elements, D block elements, you know that one, most of the part of the chapter is discussing about the transition elements, their properties, electronic configuration, exceptional things and all will come. And the next part, you know that one, lanthanide contraction and actinoid contraction, lanthanide contraction consequences, you know that one, preparation of K2Cr2O7 and the acidic and basic, that stability. Then KMnO4 preparation, you know that one, even the structure of both are very important. Manganate, permanganate, dichromate and chromate. You know that one, balanced equation in acidic and basic medium, both KMnO4 and K2Cr2O7 are strong oxidizing agent. KMnO4 will act as both acidic and basic medium, and K2Cr2O7 will act only in acidic medium. That all equation, one equation they can ask for completing reaction. Hope you all are there. Shall we start? Dear students, note it down the important one. Yes, Pooja, yeah, we are going to do the chapter D and F block elements. Let's see what all questions we have. See, these are the same type of question you can expect. Last year also the question pattern was same. Yes, Ashmita, yes, we can go now. Listen, following ions are given: Cr2 plus, Cu2 plus, Cu plus, Fe2 plus, Fe3 plus, Mn3 plus. Listen very carefully, you can note it down the important points if you want. Okay, so the same type you can explain. Identify the ion which is a strong reducing agent, and see students, along with this one we will give the reason as well. They are asking for the reason for each one. So they are asking a strong reducing agent. See guys, whenever they are asking strong reducing agent, keep in mind that should undergo oxidation very easily. Okay, so here which will go oxidation very easily, you know that one, here Cr2 plus will go oxidation very easily. How? Cr2 plus, listen, Cr2 plus will readily turns as Cr3 plus by losing one electron, correct? This is called oxidation. Species undergoing oxidation, okay, is a strong oxidizing agent. So answer for the first one is Cr2 plus. Reason I will tell you why this Cr2 plus readily turns as Cr3 plus. I think answers are coming. Yes, answer is, yeah, well done. See, here why it is more stable, because Cr3 plus is more stable due to half-filled T2G, okay, half-filled T2G. So we gave the ion as well as the answer. What is the ion? Cr2 plus. Cr2 plus will readily undergo oxidation because when it turns to Cr3 plus is more stable due to half-filled T2G. You will get 1 mark. Second one, which ion is unstable in aqueous solution? The very repeated one, you know that one. The ion which is unstable in aqueous solution, dear students, keep in mind that is Cu plus ion.
right? So CO plus ion, that CO plus ion is unstable. If they are asking why it is unstable, because of low hydration enthalpy. Keep in mind, what is that? Low hydration enthalpy. Along with that one, I will tell you one point. So here you can remember why Cu2 plus is highly stable. That also they asked.
Even the reasoning question also, I think we can expect, right?
Yes,
Copper
yes.
plus
Yeah.
1 white stable,
Yeah.
why Cu2 plus.
That is why we are keep on adding the points to this one. Cu plus is unstable because
Unstable in
of
water.
low hydration enthalpy in aqueous solution. At the same time, Cu2 plus is more stable due to high hydration enthalpy. So here anyway they are asking unstable in aqueous solution. You should tell it is Cu plus and it has due to low hydration enthalpy.
Yes.
We can go for the third one, a strong oxidizing agent. Guys, it is species which undergoing reduction very easily. That means you know that one, it is Mn3 plus. Mn3 plus will readily gain 1 electron and convert it as Mn2 plus. This process is called reduction, and species undergoing reduction is called oxidizing agent. And why it undergoes this one easily? Because Mn2 plus is stability due to half-filled. Okay, half-filled D we have to write. I think almost all are giving answer. Now they have confidence in even D and F. Yes, all are giving. Ashmita, correct. Yes, Hanna. Yes, half-filled D. So this one, each ion you need to identify and the reason also you have to give. I hope you got.
I think most of the compound, most of the species, when they given from the configuration itself, they can get some idea.
Yeah.
So if you're stuck with any point, write the configuration. Some ideas will be there.
Yeah, and wherever they are giving the Cr2 plus, keep in mind you have to write the answer in terms of Cr3 plus. Cr3 plus is stable due to half-filled T2G. That only will come for that. Wherever they are giving Mn3 plus, you have to write Mn2 plus is stable due to half-filled D. Wherever they are giving Cu plus, you have to say that unstable due to low hydration enthalpy. Wherever they are giving Cu2 plus, it is stable due to high hydration enthalpy. That you write, definitely you will get the mark.
It's the most repeated question.
Yeah, very repeated. D and F you can easily score mark, no issue. Yeah, this one, you know that one, as I told you just before, preparation for MnO4 or K2Cr2O7, sir, they will focus on that one. Any preparation can ask. So it is very important. See, here indirectly they are asking FeCr2O4. You know that one? Sometimes they will give the name of this one. It is chromite ore. Keep in mind, dear students, it is chromite ore. So sometimes they can ask, how will you prepare K2Cr2O7, potassium dichromate from chromite ore? So chromite ore when fused with, so all the hint they are giving, you know that one, preparation has different steps. Step 1, we will be taking that FeCr2O4 chromite ore when treated with the Na2CO3 and atmospheric air or oxygen. You know that one, you will be getting, the compound will be Na2CrO4 plus Fe2O3 plus CO2 you will be getting.
Yes,
and see, this is, here you have to keep in mind balanced equation they will be asking in board exam. So we used to tell, this is the way you can remember, otherwise balancing manually it will take time. So you have to write 487, you remember. Okay, 487. Accordingly you can balance the other side also. You know that one, here it will be 2 Fe2, here it will be 8 and here it will be 8. Okay, then the equation will be balanced. You can check later on, it will be balanced. Then you know that one, the second step you have to keep in mind.
The sodium chromate we have to make into sodium
so we have to
dichromate.
take that Na2CrO4. Keep in mind, this chromate is unstable in acidic medium. It will convert it to dichromate. That point also you keep in mind.
Medium.
So acidic medium, so I'll write the balanced equation. So I can write H plus. So I'll write 2H plus. So balancing is, so you'll be, here I will be using 2Na2. So this is the second step, 2Na2CrO4. You will be getting Na2Cr2O7. Dichromate will be getting, okay, plus H2O guys, then plus 2Na plus will come. Now again we got the balanced equation. Why we are writing the balanced equation? Board exam they will ask, write the balanced equation. I hope you got. Third step also they are asking, because KCl forms an orange red. KCl means that sodium dichromate, Na2Cr2O7 plus 2 KCl. I am writing that directly. Equation you will be getting K2Cr2O7 plus 2 NaCl. Now hope you understood the preparation. This preparation you definitely should learn. One preparation can come. So they are asking to identify. It gives an yellow solution of compound A. I think this is the sodium chromate is the A.
Yes.
Then after that they are asking acidification gives a compound B. That is sodium dichromate. That is B. Then after that this is the C, potassium dichromate.
Yes.
Correct, sir? Yes. After that they are asking, there is one more part D they are asking, I think, an acidified solution of compound C. That is this one, compound C, potassium dichromate, oxidizes. That also we know, That also we know that one we learned. You know that one potassium dichromate means we can write Cr2O7 2 minus. It will converted as Cr3 plus in acidic medium, and you know that one SO3 2 minus converted as SO4 2 minus. That only you need to write. So they are asking C oxidizes Na to SO3 to D. That means if you want, you can write it is Na to SO4 directly, or if you are writing SO4 2 minus also, you will get the mark. That all conversion we learned in acidic medium. Yes, NO2 minus converted as NO3 minus. We taught SO3 2 minus converted as SO4 2 minus.
Yes.
Okay, Fe2 plus converted as Fe3 plus. That all you have to keep in mind. Yes. Yes. So now all we identified D. Hope you got the one. Yes, I think. Yeah. Send your comment in the comment box if there is anything, any concern you have. So these all things you have to keep in mind, dear students.
Yeah.
Yes.
So day after tomorrow we can expect a sure question from which one, the potassium dichromate, potassium permanganate, either preparation.
One preparation you can expect in the question paper.
Maybe direct question or like this.
Yeah. Then this one you keep in mind FeCr2O4, that is chromator. If they are asking chromator, that you have to give. Okay. It's same only. So we will move to the next question, dear students. It is 43. So question number third question from this chapter. Account for the following. Manganese shows maximum oxidation, maximum number of oxidation state in 3D series. You know that one? That maximum number of oxidation state is nothing because Mn is 25. You know that one, it will be coming 3D5 4s2. So maximum number of oxidation state, because you know that one variable oxidation state is there. Maximum number of oxidation state because 3D and 4s has
Both
same
are
energy.
part, right.
Okay,
Both
or comparable energy you can say that. Okay, 3D and 4s has comparable energy or same energy means electron will participate from both 4s and 3D. Okay, yeah. So total, yeah, 1 by 1 electron when you participate, we will be getting +2 to +7. Okay, yeah. So we can write from +2 to +7. They will show these many oxidation state.
Yeah. So that I think 1 mark questions, they have to be careful that which will show only one oxidation state.
Yeah,
which
yeah.
will show
That
the
type of
most
question. Yeah, that type of question all, and you have to
mark
keep in mind. Yes. So dear students, send your answer, right answer in the comment box. We are not getting your correct answer in the comment box. Be active. Hope you all are there.
Yes, all
send
are
your
getting answer. Very good,
yeah.
very good. Okay, let's
Okay,
go.
so this is the question number 1. Then we will go for the second one. Second one, see, this type of one question you can expect again.
Electrode potential, right?
E naught, yes. Based on the E naught value and the spontaneity of the reaction, they will connect. See, any form they are asking, whether it is Mn3 plus or Mn2 plus, guys, don't get confused over here, or don't worry, I'll give a easy idea. See, wherever they are asking this E naught value or for this one, and they're telling that this is much more positive. So whether it is positive or negative, you are getting, what you need to write the answer is, always you write the answer in terms of which one, Mn2 plus.
Positive means go to
positive. So you have to say that Mn2 plus is more stable. Wherever they are asking any question related to Mn3 plus / Mn2 plus, you have to say that, yeah, that only Mn2 plus is more stable. That statement should be there, more stable due to half-filled. Okay, due to half-filled stability of which one? Half-filled stability of D. That you write. That is then. And what about then that of Cr3 plus? Okay, E naught value of Mn3 plus couple is much more positive than that of Cr3 plus, this one. And you know that one here also, Cr3 plus to Cr2 plus. That you know that one here, this conversion will not take place, reduction.
Yes.
You have to keep in mind, you have to say that here Cr3 plus is more stable. Whatever the question, these type of question they are asking, you have to say that Cr3 plus is more stable due to half-filled. Okay. Half-filled T2G, that you keep in mind, half-filled T2G. So that always you write. So here Mn3 plus readily turns as Mn2 plus. Okay, that is why we wrote answer in terms of Mn2 plus, more stable. That is why much more positive. And keep in mind Cr3 plus never turns as Cr2 plus, because from a stable condition, none of the ion will try to turn into an unstable condition. No. So Cr3 plus never turns. So answer should be like this one. Mn2 plus is more stable due to half-filled stability of D. Cr3 plus is more stable due to half-filled T2G. Hope you understood.
So these type of questions, whenever you are answering, please write the electronic configuration and then explain.
Yeah.
All right.
So that will be fine. So titanium 4 plus is colorless. Very easy. You know that one titanium is atomic number is 22. You know that one titanium will be 3D2 4s2. So here titanium 4 plus
plus
means you know that one 3D has 0.
Yes.
So you have to say that no unpaired electron in D and no DD transition.
Transition. That
So
means-
wherever they are asking, yes. sir.
Exact that term should come. DD transition should come in that if they ask about color.
Yeah.
Even in coordination compound also,
Exactly.
we can
Yeah.
expect this color related
So
questions.
yeah, wherever they are asking color, that point, okay, unpaired electron in D and unpaired D subshell and DD transition. So
Yes.
here no. At the same time, you can take the vanadium 4 plus vanadium is 23. So you will be getting 3D3 4s2. So vanadium 4 plus, even though it is 4 plus, you will be getting 3D1. Then
Yes.
4s0.
Yes.
3D1 means there is one
One
unpaired electron. Yes, unpaired electron
good,
and
very
DD
good.
transition. Yes, very good. All are there. Atul, due to first one due to no unpaired electron in D, no DD transition. Second one, unpaired electron in D and DD transition. See, next one they are asking. Write the chemical equations for the preparation of KMNO4 from MNO2. Why does the purple color of this one? So, okay, I will explain over here itself. I will write that only 2 steps we have. KMNO4 preparation from MNO2. You know that one. MNO2 when reacts with the KOH, okay, plus oxygen, air oxidation. So, in presence of atmospheric oxygen, potassium hydroxide and MNO2 will react to form. You know that one. K2MNO4 plus H2O will come. Okay, you can balance this one 2 MnO2 plus 4 KOH plus 5 O2. Okay, you can check the number later on, it is same only. So you will be getting 2 K2MnO4 plus 2 H2O.
Yes.
Okay, it's a balanced equation. You know that one, the second step, this is the step 1 we can write, step 1. Step 2 means you know that one, that K2MnO4 is nothing but MnO4 2 minus. It's an ionic equation I'm writing, electrolysis, MnO4 2 minus. Yes, it's the manganate ion, that means electrolysis. So we will carry out electrolysis. So if you are carrying out electrolysis, you will be getting MnO4 minus plus 1 electron. So don't get confused that this one is different. No, K2MnO4 only this one. We wrote the ionic part only, MnO4 2 minus means same. That when converted as MnO4 minus by losing electron, its process called electrolysis. This is the easy way. One more, either for the second step we have one more disproportionation. This one or the disproportionation we can write. Better this is the easy one. Okay, that you can remember easily. So
Yes,
that one. Yeah, that is the right answer. Preparation. Yes. One more they are asking, why does purple color of acidified potassium permanganate solution decolorizes? When? That you have to see that you know that one when Fe2 plus is added, that MnO4 minus converted as Mn2 plus. Yes. That is why it decolors, because Fe2 plus undergo reduction. This one Fe2 plus converted as Fe3 plus. It undergo oxidation and acts as a reducing agent.
Yes.
It reduces MnO4 minus to Mn2 plus. Okay. So that is why color decolors. You have to say this much only for that 1 mark. MnO4 minus ion converted as what? Mn2 plus ion. Mn2 plus ion. That is why that permanganate color does not retain. Yes. Because permanganate color is only for MnO4 minus ion, that is permanganate ion. Over.
That is a purple color.
Yeah, that is a purple color.
Yes.
So MnO4 minus converted as Mn2 plus, that is one. Hope you understood this one. Okay, we will go to the next question.
Yes, sir.
Yes, 44. Question number 44. Listen guys, again. Account for the following. Mn shows the highest oxidation state of +7. Another important one with oxygen. See, this question they generally also they asked in so many cases. Why transition element exhibit the highest oxidation state with the oxygen, not with the fluorine? Yes. Because we are expecting that it will exhibit max oxidation with the fluorine, though since fluorine is the most electronegative.
Yes. And even inside there is another question like why oxygen makes more stability than fluorine.
Yeah.
That's also because of the double bond.
Yeah.
reactor.
So here you have to say that we are expecting that fluorine will be exhibiting, but you know that one with the fluorine and all, it's only +4 will be coming, and with the oxygen it will be coming. That only before we wrote MnO4 minus will be +7.
Yes.
That is because oxygen is a divalent element, or it makes multiple bonds. Means logically you can remember like this one. One oxygen can remove 2 electrons at a time. One oxygen can remove 2 electrons, but if fluorine approaches, fluorine can remove only 1 electron. Okay, so oxygen is a divalent element. That is why it makes
+7.
These many.
More stable.
This way you can present the answer. First one, oxygen is a divalent element and it can remove maximum electron and will go to the highest oxidation state. Cr2 plus is that already we discussed. I think Cr2 plus is a strong reducing agent because Cr2 plus readily turns as Cr3 plus by removing 1 electron. This process is called oxidation. You have to, but no need to write this one. You have to say that Cr3 plus is more stable due to half-filled, half-filled T2G. That is your answer.
So
Okay,
it
that
undergo
you will get the
oxidation
mark.
means
Yeah.
act as strong reducing agent.
2 points should be there. It readily turns to Cr3 plus and Cr3 plus is stable due to half-filled T2G.
Yes.
Yes, Atul. That is the correct answer. Last one, sub-question. This is the answer for the sub-question second. Sub-question third. Sub-question third, Cu2 plus salts are colored. You know that one, Cu2 plus, I'll write the electronic configuration directly, 3D9 4s0. 3D9 means unpaired electron is there. Okay, one unpaired electron will come.
Yes.
In case of this one. One unpaired electron. But what about in Zn2 plus? Zn2 plus means you know that one, it will be 3D10 4s0.
Yes.
So 3D10 4s0 means
There
no
is
unpaired electron.
electron.
So no unpaired electron means you know that one, no DD transition,
won't
no
happen.
color. Hope you all are there, dear students. So these are the type of question you can expect from D and F chapter.
Mainly reasoning questions. You know that which all, if you search the last previous year question paper and all, these questions are again repeated.
So D and F you can easily score mark.
Yes, definitely.
So that previous year question only you follow because there is no application level, nothing. All the question will be like in between the gap they will be asking the same only.
You have to concentrate on the lanthanide actinide part also because last year there were less question from this lanthanide actinide part.
Yes.
Contraction, their consequences. Hope you know everything.
Yeah, yes, Smriti Ganesh, that is the right one. Whenever there is unpaired
process
electron
of
in D, they will undergo DD transition.
transition.
That is the reason
for
behind the
color.
color. Yes. Question again, see, again the type, again they are asking because here they gave the 3D series. You know that one scandium to zinc is called 3D series. So 3D series elements are given. So answer the following, write the element which shows maximum number of oxygen state. Here you know that one Mn. Already we discussed that Mn will show from +2 to +7 and
Yes,
along with
answer
this
is
one,
there.
this one you keep in mind, +2 to +7, correct. So right answer is Mn.
Let them say the answer for the second question, sir. Which
Yes,
element has the highest melting point, all of you? Can you say?
Should not make mistake.
in
read
3D series.
in
which
3D
one?
series.
Which one shows highest melting
Really?
point? You may see.
Let us share it.
This question you can expect as a graph.
Yes,
Right, with the graph
that
also.
graph you have to keep in mind.
Yes.
Yes. Very good, very good.
Which one?
All
Yes,
should.
correct.
Karthik. Yes.
Correct.
Well done, well done.
Yes, Bhavana, Anna,
yes.
Ashmita, Babu.
Yes, all are
Ashmita,
selling. Yes.
Sabia,
Mohammed Sabih. Good. Question will be same as sample
Same
paper.
as- Yes,
Hopefully
of course.
we are expecting the same
As
type.
per
Yes.
chemistry, these are the type of question
Yes.
you can expect from this.
Yes,
kind of
well done.
practice.
Yeah, I think almost
Very
all
good.
gave the right
All given
answer.
correct answer.
Well
Keep
done,
going.
well done. Yeah.
Which is the answer?
Yeah.
So chromium.
Yeah,
is the
chromium.
one.
Yeah, so keep in mind why chromium because maximum number of unpaired electron, but at the same time you have to keep in mind manganese has exceptionally low.
Yes.
Okay, exceptionally low because of half-filled D.
Stabilization.
Yes, yeah. So now the right answer is this one. So here which
CR.
element has, so we will write chromium. So you can easily score mark 1 mark. Which element shows only +3? See, that is also very easy one. We can give you time. Yes. You can give the right
Which
answer.
one shows the plus
Plus
3
3.
oxidation state?
Yes.
Plus 3 oxidation state.
Only
Yes.
+3 because all other elements
Smriti
other
given the correct answer.
than +2 and all. Yes, well
Yes,
done.
Ashmita,
Tanvi,
Diya, Atul.
good. Sabih,
Yes.
good.
Which one? Scandium.
Yeah,
Scandium
so,
shows the one.
yes, scandium has only +3 oxide
Plus
state. That reasoning question also you can expect. Why scandium only showing +3 oxide state, not +2?
Yeah, after
because
scandium
D1,
3+ you will
yeah.
get. That's argon.
Yeah, because SC 3+ is stable with the stable noble gas electronic configuration.
Yes.
Yes.
Okay, yes, correct one.
Yes,
Scandium.
all are there. Well done.
Next
So
one.
fourth one, which element is a strong oxidizing agent in +3 oxide state? That is very easy. +3 oxide state, you know that one Mn3+, okay, will readily accept 1 electron and converted as Mn2+. So this process is called what?
Reduction.
So gain of electron is the reduction. Reduction undergoing means oxidizing agent.
Yes, they are the oxidizing
So
agent.
oxidizing agent they are asking. So oxidizing agent, and why this one? You know that one, why they are asking? Due to half-filled stability of D. See, that's that's why I told you, this one you have to keep in mind 3. Mn2+ is stable due to half-filled stability. Yes, Bhavana. Yes.
Correct. Mn
So
is the
correct
answer.
Mn2+. Here should not write Mn and all, they won't give you mark. You should write Mn3+.
yes.
Yeah, that ion. Which element has a strong oxidizing agent in Mn3+?
stated.
Yeah.
So we can select this Mn as the answer.
Yeah, that one. Now we will go to the next one, 46. See,
46.
how do you account for the following?
Following.
Actinoid contraction is greater than
that?
lanthanoid contraction. See, actinoid contraction and lanthanoid contraction, you can focus. Lanthanoid contraction means from lanthanum to lutetium, okay, or cerium to lutetium. There is a gradual decrease in atomic radius or size, okay, due to poor shielding effect of 4f.
4f
So,
orbitals.
yeah, so wherever lanthanoid contraction, you keep in mind 4f is
4f orbital.
experiencing less shielding effect, and for actinoid contraction 5F is experiencing poor yeah.
Right.
So when you compare this shielding effect, more poor shielding effect is for 5F
orbital.
yeah, than the 4F.
So actinide contraction will be
is
more
greater
than lanthanide
Lanthanide.
contraction.
So 2 points you have to say that 4F experiencing more poor shielding effect than 4F. That is why actinoid contraction is greater than lanthanide contraction.
I think lanthanide and actinide, we can expect the questions like what are, say one or give two difference
or
and
similarity.
between
Yeah, that
lanthanide.
also they asked in so many papers.
Lanthanide contraction, 4D, 5D series,
Yes.
similar size, everything.
Yeah.
So that lanthanide actinide part last year less questions. So this year we can expect.
Yeah, that part you have to keep in mind.
Yes.
Transition metals are colored compounds, very repeated, sir.
Yes,
Another
that's
transition metals are very repeated, you know that
Due
one?
to the presence of unpaired electron.
Yes,
they
2
can
points you
form-
have to keep in mind. They have unpaired electrons in D, okay, unpaired electrons in D, and you know that one, they undergo DD transition. So wherever they are asking about question about color, so unpaired electrons in D and DD transition, both the points you should write always. Yes, DD transition and unpaired electron in D. Yes.
Yep.
Shall we go to the next one?
Next
Hello,
one,
dear
question
students.
number
Yes, question number 47.
47.
Sorry, yeah, 47. See, 47
Name
the question. Name the element showing maximum number of oxide state among the first series. Already we discussed, I think we are not,
They are asking in
scanty,
different way,
yeah,
that's
different way they are asking. Anyway, that you keep in mind, you already know the answer, it is
That is
Mn.
Mn.
1 plus 2, 2 plus 7.
Plus seven
yeah.
stage.
Name the element which shows plus 3 oxide state. Again, it is repeating. It's
Yes.
a year by question we selected. So it's the same one. You know that one. It is scandium is coming. Okay,
Plus
scandium is plus 3 oxide state. And what is lanthanide contraction?
contraction.
That is important.
Yes, definition important.
Yeah.
Name an important
Yeah.
alloy which contains some
Yeah.
of the lanthanoid metal.
So-
you will say that, I think
Yes.
they will say
we
that
will give
metal
you
name
time. Yeah.
immediately.
Yes. Yes. Yes.
Which is the answer, dear students? Which is the alloy? Which is the alloy which is created by especially
Yeah,
cerium?
they are learning in under uses
Yes.
uses of
Which
yeah
one?
yes very
That
good
the
Karthik
mish
yes yes
metal.
yeah that
Very
is
good.
very important. Mish metal, and keep in mind, dear students, mish metal has 95% of lanthanoid element. Okay,
Especially
lanthanoid
cerium,
element,
right?
yes. And the 5% is, you know,
of
that one, iron
iron,
and the aluminium, sulfur, calcium
carbon,
like elements
like
are there. Okay, that you keep in mind. So mish metal also, they asked the question uses of this one. Lanthanoid contraction, already we gave the definition from lanthanum to lutetium. There is a gradual decrease in atomic size due to poor shielding effect of 4F electron. Okay, and consequences also you have to keep in mind.
Yes, three
that similar atomic
consequences, right.
sizes, yes, decrease in basic property and all you have to keep in mind. That is also important.
Their
So
separation makes harder, and
Yes.
4D and 5D series having similar size,
Similar size.
and their basicity question, their
yeah,
consequence.
that also you have to keep in mind. That is important. Now 48, question number 48. How do you account for the following? Transition metals exhibit variable oxide state. I think we discussed already this one. You know that one transition element we will be getting N minus 1D and NS. Okay, generally when you are writing, because we are getting 3D and 4S. So generally if you are writing for the first series. So N minus 1D and N minus 1D and NS has comparable energy. So comparable energy means, you know that one, they have almost similar energy. Then what will
Yes,
happen?
they
Electron from NS as
and
well as
N
from
minus
N
1D.
minus 1D will participate
In bond.
in chemical reaction. So electron from NS and N minus 1D, one by one it's participating, means that's why we are getting variable oxide state. So 2 points you have to write. N minus 1D and NS has comparable energy. Electrons will participate in the reaction from both the subshells.
Yeah.
Then the question number C, this is what we told, zirconium and hafnium
Hafnium.
have almost identical radii. Just before we gave, it's the consequence of which one?
Lanthanide contraction.
Okay, this is comes under 4D and 5D. So 3D series, that lanthanide contraction, that effect will be coming 4D and 5D series. 4D and 5D series have similar atomic size. If they are telling, it's same. And two more example we will give you: zirconium and hafnium. You guys keep in mind. Niobium and tantalum you keep in mind, and molybdenum and tungsten you keep in mind. Okay, M1W. So these elements, these all elements have similar atomic size: zirconium, hafnium, niobium, tantalum, molybdenum and tungsten. These elements have similar atomic size due to lanthanide contraction. Yes, very good, Hisham. Well done. So transition metals and their compounds act as catalysts.
Catalyst.
Yeah.
That's important.
See that also, that 2 points I gave you, we discussed in the class, that catalyst activity, first one, they help to form reaction intermediate due
fast.
to variable oxide state.
Yes.
That you keep in mind. All transition element can form variable oxide state Due to variable oxidation state, they will help you to form, they will help the reaction intermediate.
Fast.
So yeah, whenever reaction intermediate comes in a reaction become faster.
Correct, then we have fun. Good. Correct.
Yes, yeah, and one more point, you know that when they provide surface area for adsorption, okay, surface area for adsorption means, you know that one, every reaction takes place on the surface of a catalyst. A catalyst will be a solid catalyst. On the surface of catalyst only reactants are added. So a catalyst transition element means they can provide more surface area, then more reaction will take place and the reaction will be faster.
It will be fast.
This is called adsorption.
Yes.
So 2 point, first one, you have to keep in mind, due to variable oxidation state, they help to form reaction intermediate. Second one, they provide surface area for adsorption. Adsorption means this is the way reaction takes place. Yes. Yeah, provide a suitable surface area. Yes, Sharish, that is the correct answer. Yes, yes, yes.
Yes, okay.
Yeah,
So I
yeah.
think we can go for the next question,
one
sir.
is 49. We will go. How do you account for the following? Okay, again the question based on this one, MnO4 minus EC. But this is a very important one. Keep in mind. Okay, it won't be that repeated one and all. But the question paper it was there. The oxidizing power of oxoanion. Okay, R in the order VO2 plus is given. Then you know that one Cr2O7 2 minus is given. Then
And
they gave
MnO4
MnO4 minus is given. Okay. Dear students, you keep in mind this question is based on the oxidation number.
state.
MnO4 minus, you know that one it is plus 7.
state.
Here it is plus 6.
Plus
And
6,
here you know that
plus
one it is
3.
plus 3 will
Right.
come. Okay. Why we are writing the oxidation number? Because there is a statement, that statement you keep in mind, higher the oxidation number, more easy to get reduced, and it's a strong oxidizing agent. So what is the statement? Higher the oxidation number, more easy to get reduced, and stronger is the oxidizing agent. So here which is the highest oxidation number, plus 7. So this will undergo more easily reduction.
and
So
act
which
as
means
a
the strongest
oxidizing
oxidizing agent. That only they are asking. The strongest oxidizing power is for this one is maximum.
Yeah.
Or logically you can keep in mind, sir, that plus 7 means the smallest size. Smallest size cation means it will readily accept one electron. That is called reduction.
Yes.
So this will accept electron very fastly, which means the strongest oxidizing agent. This has the biggest size because only plus
Oxidation
3.
state is less.
So very less tendency to accept electron, which means
Yes,
reduction will be very slow. Therefore, the weakest oxidizing agent.
Yes.
So statement, this one you keep in mind, higher the reduction potential, higher the oxidation
state.
number. Higher the oxidation number,
Yeah.
more easy to get reduced.
And it acts as a best oxidizing
and the
agent.
strongest oxidizing agent.
Yes.
That you keep in mind. Okay. Then the next one, second one, the third ionization enthalpy of manganese is exceptionally very high. That already we discussed. See, they are asking the question in different way. Mn2 plus, the third one they are asking means one more electron we need to remove. This will not, because this is stable because of 3d5 and 4s0. You have to say that Mn2 plus is highly stable due to half-filled. Okay. Half-filled d orbital over. Why the third ionization enthalpy? Third means after 2 plus again we need try to remove one electron. That will not be possible.
Yes.
Yes, because it is stable due to half-filled. Answer is it is 3 Mn2 plus is stable due to half-filled stability of D.
Yeah.
Yes.
From that one, removal of electron is harder.
Yeah.
So the third, that is the third ionization enthalpy, that will be very high.
Yes. So that you keep in mind. So next one again, see this
Cr2
is the Cr2 plus is a strong reducing agent. Sir, see this is the way they are asking than Fe2
Comparing.
plus. So you have to say that Cr2 plus readily turns as Cr3 plus, and this is more stable due to half-filled.
T2G.
Yeah, half-filled T2G. That always you write. But
Yes.
you will think that what about Fe2 plus are also Fe2
Fe2
plus
plus that will
also
be 3D6.
converted as Fe3 plus, but this is due to half-filled
D5
D
configuration.
subshell. Okay. Yeah, half-filled D. So half-filled D and T2G when you compare, which is more stable, half-filled T2G will be more stable. That you keep in mind. This is half-filled D and this is half-filled T2G. So no need to write in the terms of both. Only you need to write Cr3 plus is more stable due to half-filled T2G. That is enough because it's 1 mark. Okay, so Cr2 plus readily turns as Cr3 plus, and Cr3 plus is more stable due to half-filled T2G. That you keep in mind. I think the third question is over. Now we will go to the last one, I think.
Yes.
The 10th question from the chapter D and F block elements.
We
I think
can
you are
expect a short
almost all
question,
questions. Yeah, only 1 or 2 questions you might be feeling very difficult. Remaining all, I think you could answer all the questions well. Okay. Hope you are
Yes.
confident this chapter. Okay. So write the complete chemical equation.
form.
Yeah. So this one, that balance we told you, Any 1 or 2 equation they can ask, 1 mark question you can expect for the complete the reaction. Here we selected 2 equations. First one is Cr2O7. Listen, Cr2O7 2 minus, they said in acidic medium. Acidic medium it is converted as Cr3 plus. Okay, here you know that one. Oxidation number we will write. Here oxidation number you know that one. Here it is plus 6 and here it's plus 3 is given. But 2 Cr is there and here I have to make 2. So 2 into plus 6 is 12 and 2 into plus 3 is 6. So I should add 6 electron over here.
Yes.
I think charge is over. 7 means I will add 7 H2O, dear students. 7 H2O means I will add 14 H plus.
you need to add.
Now this is over. Now you know that one we have to take
Fe.
the Fe2 plus. That is very easy. Fe2 plus is
become
turns as
Fe3 plus.
Fe3 plus. Charge for equalizing I will add 1 electron. So 2 plus. Now you know that one here 1 electron, 6 electron means we have to multiply the
By
second
6.
equation with the 6 to add the electron. So means add the reaction. So when you are adding this one, you know that one 6 electron cancel. After that I will get 14 H plus plus Cr2O7 2 minus plus 6 Fe2 plus, right? Gives 2 Cr3 plus 7 H2O plus 6 Fe3 plus. Hope you understood. This is our final equation. Okay. Yes, this is our final equation. High stability to CS. Yeah. So this balancing equation you have to keep in mind. But dear students, one more we have. This is the sub question 1. Oxidation of H2O3. What you have to keep in mind is you have to keep in mind Fe2 plus will convert it as what? Fe3 plus. And Cr2O7 2 minus in acidic medium will convert it as Cr3 plus. After that balancing you can do. Okay. Otherwise memorizing or by hearting all this equation will be very difficult. That logically we taught that you keep in mind. This is the equation. So second sub question, keep in mind it is again they are talking about MnO4 minus. But keep in mind student, neutral or basic is same. Okay, slightly alkaline or neutral medium will act as same. So we can write the equation. So we will start Nasser. So MnO4 minus will convert it as MnO2. Okay,
Yeah.
MnO2
Basic
that is in
medium,
basic
MnO2.
medium. So you know that one here it is plus 7, here it will
Plus
be
4.
plus 4.
So,
So electron difference is equal to 3 electron. But oxygen 4 over here and 2 over here. So I will add 2 H2 over here. Okay, we'll skip the. So we will add 2 H2 over here. Then here it will be 4 OH minus. I think now it is balanced. So 4 hydrogen, 4 hydrogen. Here it is 4 plus 2, 10 is there. Then here it is, I think it is balanced, right? 4 plus 2, 6. Yes, 4 plus 2, 6. It's balanced. Now we have to keep in mind what is the conversion for H2O3. Okay, thiosulfate. H2O3 2 minus will convert it as SO4 2 minus. That is the change you have to keep in mind. Students, are you there? Are you there?
Right? Yes or no? After D and F block, see we are almost in the 50 range.
Yes, the last, yeah, 50
So
question
50
we are going to,
range
almost half of the part we are going to finish. I think you all guys are very confident
that 1
now.
year, right? 1
Yes.
year what we struggled for to get a good marks, that we are almost concluding here.
Yeah.
Yes, this type of questions
Sabhi,
are hard.
yes,
Okay,
yes,
no
yeah.
problem. We have time tomorrow itself just by the method, try to balance
Yes,
and follow it.
Yeah, Sabhi, these are hard. We know that one, but one question we cannot. Yeah, we cannot skip all this one. Complete the reaction question they can ask. Okay, sometimes it may not be there, but still. Okay, no.
As a general trend, we are seeing that one or maybe some question paper 2. So basically one question for
you can
balancing,
expect. Yeah.
you can definitely expect.
Yeah. So this one
Okay.
is comparatively very tough, but still. So here you have to take the oxidation number. You know that one here in SO4 2 minus it will be plus 6. And here it will be coming plus 2, I think. Yes, yeah, because 2x will come, it is plus 2. And dear students, here it is 2 sulfur is there, but 1 sulfur is there, so I will make it as 2 first.
Yes.
Then after that, we can take the number of electron. Here 2 into 2 become 4. Here 2 into 4 become 6 become 12. So 12 and 4 means 8 is the difference. So I should add 8 electron over here. Okay, because right side is more positive.
Using electrons.
So 8 electron, this is the reduction process.
Yes.
After that, we need to equalize the oxygen over here. Here you know that one 3 are there, and here it is 8. Okay, 2 into 4, 8. So here actually less. So I will add 5 H2 over here, and here it will be 10 OH minus. Okay, 10 OH minus. Hope you understood. Here it is 2 into 4, 8. Actually, here it is 3 only. 5 H2 I will add over here and 10 OH minus I'll add over here. Now everything is balanced. You know that one. 10 oxygen plus 3 oxygen is equal to 13. Here 2 into 4, 8. 8 plus 5, 13. Everything is balanced. After that, you know that one, we need to add this equation, but adding is not easy. 3 electron over here, 8 electron over here. So the first equation you should multiply with 8 and the second equation you should multiply with the 3. Hope you got. Now the number of electron will be equal, correct? So this one will be, we will be adding this one, you know that one now, 8 into 3, 24 over here, and here it will be 24. Electrons are cancelled. Okay. Now we can write everything. Even water will be cancelling, sir. We can cancel here. 2 into 8 is 16. 16 water, and here it is 15. So here 1 water will remain.
Yes.
Okay. Here 10 OH, no 10, 30 OH minus, and here it is 32. So here it will be 2 OH minus.
Left.
Here, right?
Yes.
Yeah. So here it will be 2 OH minus. So now we will write the equation H2O plus. Here it will be MnO4 minus, I think here it is H2O, MnO4 minus will be 8. 8 MnO4 minus, plus here it will be 3 S2O3, 2 minus, gives here again 8 MnO2, okay, plus 2 OH minus, okay, plus this will be 2 into 3, 6.
And 6, yeah.
6 SO4, 2 minus, because here 3 into 2, 6,
sulfur,
correct?
6 sulfur.
Yeah, plus, and here it is remaining is, I think,
over.
water, cancel. Yeah, now this is the final answer. It's there in the reader textbook. You can check. It's same. Yes, okay. See, don't worry. One question, one or two question, they can ask as a tough. Okay, why you are worrying about? You know the 90%, 99% things from D and F. One question, this type of question, if you come, don't upset. Okay.
Always,
you can
always think positively.
Think positively.
Will be easy. If you make tough, if you okay, the exam is very hard. Exam will be
Surely,
very
yeah.
tight. So the non-answers also you can't able to present in the paper. So forget about that one. Really try to approach everything, study everything,
and be confident.
Yeah.
You learned 99 things. Okay, that one thing you have time, dear students.
Basically,
that where you are
physics,
lacking,
chemistry,
where you are lacking, you can do today and tomorrow as well. Don't worry.
There.
Time you have enough time. Be confident. Okay, don't worry about that 1% thing. So I don't know about that one. Don't worry. So here equations are here. This type of equation you practice. Don't worry. Yes. You will score full marks. See,
worry, sir,
that is the confidence.
Yes,
that is the confidence. Yes.
Okay, don't be tense, please.
Yeah, that's it. So this one you just try. If you are lacking this one for solving and all, just try.
Yeah.
Okay, 2-3 equation. And
so
be confident.
Yeah. How many of you are confident? Let me. Can you just show in the chat box, all of you? How many of you are confident now? How many of you are confident now in the sense? Yes, I studied almost. Yes, I have so much concept within my mind, so I can able to present it in detail in examination. How many of you are confident in that?
Yeah, that is actually our aim. This live session, you should get that confidence. Okay, to boost your boost your confidence. Only we came. Yes,
good. That confidence you should. If you don't have a faith on you, means what? We can't do anything, dear students. So what we can do is that we can boost.
Satvik.
That's it. Yes,
so be confident. Don't worry. Yes.
We are ready.
Yeah.
Okay, so I think now the time is 6:30.
Yes.
When we started,
almost
sir,
3 and a half.
Around now we are 15.
3.5
we have
hours.
to reach at century.
Yes.
Right.
So now almost 50 questions we finished. Next 50 we are waiting. Okay.
Okay.
So all should be there with the same energy. Be active. Okay. So shall we continue?
Yes, dear all, are you ready to continue this session or not? So just ask your mother, bring the Boost, Horlicks, Bonvita, whatever you want, try to bring it and keep it on your table. Yes, I think still 91 students are there. Yes, they have to get something.
Yes,
they have to know what is the chemistry paper. Love you, all of you. And yes, I think 6:30 is over. Next till, we don't know. I told you when we starting the session 3 o'clock, we told you we don't know when it is going to supposed to over. But still,
all are there, sir. That is so. Thank you so much, dear students. Yeah, thank you so much. And thank you so much for watching.
She won't make it, sir. Who is that? Call your mother. Just give us number. Let us discuss with her. Okay. So
today you should keep that energy. Though you don't have food, snacks, tea, nothing, but we keep that energy.
Yes.
Okay. Only for 2 days. After that you can relax for a few hours. Then again for physics you can prepare.
Yes.
Okay. 2 days you struggle.
See
that effect will be there.
Even we peoples also this completed 12th grade. This is the situation. 12th grade means this is the situation. So don't think that I want to study lot of things, sir. Still I am getting tensed. Please avoid all of you. Be cool. Be cool first.
Yes, keep on
We will
practicing.
make it
Move
like
on,
a-
move on, move on for 2 days. Okay. Yes.
Atyun,
Yeah,
from
nothing is
Thank
there,
you,
but
Atyun.
you will be energetic. We know that one. Yes.
Okay, I think we can
Yes.
continue,
Yes.
sir.
Yes. Yes. Next chapter, sir. So next chapter is
So we
haloalkane.
can start from our
Sure, sure. See,
organic.
is coming. So now they are happy, I think, sir.
Yeah.
See, at least that physical and inorganic part is over. So now their expected part came.
I think how many of you love organic chemistry? All of you. And can you say, dear all, what is the overall weightage of this organic chapter? You know.
Now we have 102 students.
Yes.
that's
102. Yes.
Yeah, 102,
So when we
yes.
reach at 50, we got century.
Yeah.
Right. Okay.
Yes.
Yes. Let's go. I am ready. We are ready. All of you. We are ready with you. So I think organic chemistry. We can start now. So I think organic chemistry, and I think I didn't get the marks. All of you. Yes. Jonathan. Yes. Aistudi. Yes. They given the answer. 33 mark. Out of 73, 33 mark from organic chemistry itself. So you know the importance of that one. Organic chemistry, the first things, how to remember all these reaction. At least 1 year you are studying all these reaction. Now you have the complete idea about the reaction. Here within few times we can able to complete all the reactions, we can bring it close, and what all type question and important area. It is from the first chapter.
Yes, here
Halo.
you can revise all those reactions. Already you know all those ones, but just brush up the things and try to answer all the one along with the how we are when we are explaining. Okay.
Okay.
So be active. Now we are going for the organic chapter. Okay. Let's
Okay.
see.
So let us start from the haloalkanes and haloarene chapter, my dear student. Last year also they were asked a very simple question from haloalkane, which is a primary haloalkane, and the SN1 SN2 reaction. These type of the questions they were asked. You know what are the important area from haloalkane? You know the named reaction for your recovery already given here. So many named reactions are there. You know Woods reaction, Fittig reaction, Woods-Fittig reaction, Sandmeyer reaction, Getterman, Finkelstein, Schwartz. SN1, SN2, we know the most expected question from SN1, SN2, beta elimination, nucleophilic and electrophilic substitution, polyhalogen compound, right?
That part you should give importance as well. Last before it was deleted one.
Yes.
Now you can expect the question from polyhalogen compound.
Polyhalogen compound, I think DDT and the
Phosgene
chlorofluorocarbon
formation.
and phosgene, that you know that chloroform white is kept in dark bottle and all, that
CFC
question.
part and all.
And chirality, like an enantiomer, that which is a chiral, which is,
question will be
yes.
coming. Yes.
So I think, dear all, let us start. Just relax first, take a deep breath, let us start and try to bring all the reactions together. Now please delete all those other chapter. Please invite all the haloalkane reactions once into your mind. Let us start from the first question. Out of CH3 tri-CBr and CH3 tri-Ci, which one is more reactive toward SN1 mechanism? So SN1 means stability of the
I think
carbocation.
now they have the order.
Yes.
Yeah, order of SN1 reaction you can keep in mind.
Yeah.
Based on that one question you will be getting. I think answers are coming. Yes.
Yes, structure also we can expect
Yes,
the name
and
and which is used as a pesticide, which is used as an
pesticide.
insecticide. Yes, we can expect. So which is the answer? Yes, they already given the correct answer.
It's
I think
tertiary
both are
because-
tertiary here. So we have to just check
BR
which is
and
the
I, yeah.
best leaving group.
Yeah.
You know, iodine is the best leaving group, so it
agree
will
to
give the
that.
carbocation faster. Yes, already given the
I
answer,
minus
right?
is the best answer. Yes. I minus is the better living group.
Yes.
Very good. Very
so
good.
this will undergo SN1 mechanism faster. So dear all, if these type of question when they ask, please take the compound, write in your paper and show the mechanism. Mechanism in the sense, make this carbocation and just say the answer. Iodine is a best leaving group, therefore it will form the carbocation faster. So detailed answer you have to present. And I think, sir, we can go for the next question, right?
Yes, yeah. Sub question second.
Write the product formed when? What is the compound?
Chlorobenzene.
Para-chloronitrobenzene is heated with aqueous NaOH. Aqueous NaOH at 443 Kelvin, followed by acidification.
Yes.
I think we can able to say the answer directly. What can be the answer, my dear student? If it treated with the aqueous, NaOH first, later on treated with the acid H plus, what happened? What is, I think they know the reaction very well. What happened to this part that you know?
Yes.
This is what? This is what?
Those process we are
Yes,
learning.
dose process.
Those process based question, yes, and well done, well done.
Given the correct answer
Dose
during the dose process?
Yeah, and in dose process, when an electron withdrawing group adds, then the reactivity will be faster.
Yes.
So 1 NO2 is there, 3 NO2 when comes, it will be more faster.
More faster.
Only warming is required.
Yes, NO2, you know, withdrawing group.
Yeah, electron withdrawing group when comes, yes, correct. All are given
Correct, right.
answer. Well done, well done.
Okay, so let's go for the third question. Why dextro and levo rotatory isomers of butane 2-ol are difficult to separate by fractional distillation? They're all fractional distillation is a separation technique. There should be a large difference in their boiling point. So they can't able to separate by fractional distillation means what?
Yeah, they can tell that the boiling point will be
Almost similar.
So wherever they are asking fractional distillation cannot be separated, you have to keep in mind
Yes.
that orthonitrophenol and
Paranitrophenol.
same question will come.
Yes.
Why ortho and paranitrophenol cannot be separated?
Yes.
There it can be separated because distillation is applied.
There is a large difference in their boiling point.
There it is separated. Here it can't means you have to say that they have the almost same
Boiling point. So we can able to say that dextro and levo are the enantiomers and they're having what? Almost similar boiling point. So we can't able to separate by fractional distillation. Right. So up to that you should write.
Yeah.
Yes, they were the correct answer. Next question.
Yes.
Why is CH2 double bond CH2Cl more easily hydrolyzed?
Yeah.
So there are lot of questions like hydrolyzed, solvolysis, racemization. These all indicating which one? That is the SN1 mechanism, stability of carbocation. So SN1 mechanism mean you have to first remove. SN1 mechanism you have to first remove which one? The halogen and make the carbocation. Please check
Most
stable one.
carbocation. That is the basic mechanism.
Yes.
Stability of carbocation.
So can you tell me, dear student, whether the first compound or the second compound can give the carbocation faster and which carbocation is more stable? Hope you can able to, yes, or Ash already given the correct answer, that is allylic.
Allylic.
Yes, this is the allylic, you know.
Yeah, allylic comes. Allylic will be more stable than the primary. Here
Yes.
the second one comes primary carbocation and this is allylic. Allylic will be more
Stable.
than primary.
Allylic carbocation is more stable due to resonance. So allylic will undergo more easily. So hydrolyzed, solvolysis, racemic mixture, these all indicating what? They connected to SN1 mechanism.
That SN1 always
Right.
keep in mind the stability of carbocation.
Yes.
One question you can expect based on that.
Next, write the equation for the preparation of 1 iodobutane from 1 chlorobutane. So whenever we showing a question, dear student, I hope you all are ready with a book and pen. Please write and practice this one instead of immediately one answer. Okay. So yes, okay sir. So write the equation for the preparation of 1 iodobutane from where? 1 chlorobutane. So 1 chlorobutane, let's do very fast. This is the 1 chlorobutane. If you want to change by chlorine by iodine,
Then we can give the chance.
Yes.
We can tell the name reaction.
which, what is the name of the reaction? Already answer is there. You are already prepared thoroughly well, dear. So,
Answers are coming.
what is the reagent?
Single reaction.
Ah.
NaI and dry acid.
Dry acetone we can use it. This NaCl cut, you will get what? The butyl group with what? That iodine you will get it. Yes, this is our Finkelstein reaction. So this is the equation. So
All
directly.
the name reaction, if you know, means you will be able to answer the question because indirectly they will be asking.
Yes.
So even conversion also, nowadays they are giving the name reaction. So every name reaction you should learn.
Correct.
So, yeah.
Okay, next one. Out of 2 bromopentane, so out of 2 bromopentane, not drawing completely. During examination, don't write like this one. You have to write the complete valency of carbon and all. So 2 bromopentane and 2 bromo 2 methyl butane and 1 bromopentane. Question. Which compound is most reactive toward elimination reaction? What is the order of the elimination reaction? We know. That is also related to what? Tertiary, secondary, primary is the order of the elimination.
Wherever elimination happens, carbocation is the
Yes,
intermediate.
here
That
it
will
is
keep in mind.
secondary,
Yes.
here it is tertiary, here it is
is
what? Primary. So tertiary will
will be-
undergo. So that is 2 bromo,
Yes.
2 methyl butane
correct.
can undergo what?
Answer
The reaction
yeah.
faster,
So
right?
Every elimination, carbocation is the intermediate.
Yes.
Yeah. So every elimination, dehydration, beta elimination, everything is same.
We should be
beta
careful.
elimination, yeah, that all is same only. So dehydration.
Carbocation, see, the first step is what? The halogen should remove. Halogen should remove, then carbocation is to form. That is the
Intermediate will
first
be
step in
carbocation.
elimination.
Yes, Carbocation whenever comes, stability will be always 3-1. You
And
keep in mind.
yes, and what is the IUPAC name, sir? I think the IUPAC question we can expect from any one of the organic chapter.
Yeah.
You may
One
think that is it a question? Yes. NCRT, what all compounds are there? Even small question, hard question, average question, everything we can expect. So one question we can expect from any of the
one naming question they can expect.
from any of the organic chapter.
So if they are giving 2 compounds from coordination compound, then
Yes.
it won't be there.
Correct.
Otherwise, one question from organic naming you can expect.
Yes. So I think, dear students, be careful. Halogen is there, double bond is there. Double bond having more priority than which one? Halogen. So I think number we can
Number
start
will be
from here,
starting
right?
from left side.
1, 2, 3, 4, 5. So the name we can call it as what? Alphabetical order. Don't forget all of you. We can say, sorry, 4 bromo, 4 bromo,
methyl,
4 methyl, and the total
Pent
5
hyphen,
carbon, pent,
hyphen,
2
hyphen,
ene, right?
Yeah.
So 4 bromo, 4 methyl,
methyl,
pent,
pent,
2 ene is the answer.
Right answer. Yeah.
So still it's a
yeah.
long name and all. They are not forgetting to comment in the chat box. All of you appreciate your hard work. All of you. The same way, you know how harder to write in the chat box. So it is not harder like in writing the your paper, your answer paper. So that we need to elaborate maximum when if it is a board exam comes. Okay. So I think, sir, we can go for the next question, right?
Yes, we will go to the 4th question.
Identify the chiral molecule. Identify the chiral molecule in the following. I think they will give the answer.
Already we gave the idea, chirality, one question you can expect.
Yes.
Okay, chirality based one question you can
And
expect.
maybe
based
they
on, yeah.
connect with optical activity, which
Yes,
is
yes,
optically
yeah.
active. So
That is
check
also
whether there is a
based on
chiral
chirality,
carbon
yeah.
or not.
Whether it is optically active or not means they are asking asymmetric is there or not.
Which one, dear all? Which
yeah,
one?
yeah.
First
Give
one,
the
first
answer.
one,
Yes,
first one.
yes.
Yes, I think this carbon is CH and this is what? CH3.
CH3.
So this carbon is connected to hydrogen, OH,
CH3,
methyl and one isopropyl.
isopropyl.
So all are different group. Yes, this carbon is
4
what?
groups are different, attachedly different means, you know that one, it is the asymmetric. or
Chiral. Don't forget other name, my dear. That is what? Asymmetric carbon or chiral carbon. Okay, next question. Write the structure of the product when chlorobenzene. Write the product formed when chlorobenzene is treated with
the presence of-
methyl chloride, right?
Yeah, and here also, sir, they are asking the name reaction indirectly. Can you
Yes.
tell the name? Yes, yes.
What is the
Yeah.
name of this reaction,
What is
my dear
the
student?
name?
Come on fast.
What is the name reaction?
What
they are
is the
asking?
name? Chlorobenzene is a haloarene. Chloromethyl is a haloalkane.
Yes, they gave the answer. Yeah, well
What is
done,
that?
well done. Woods-Fittig
Woods
reaction.
Fittig.
Yes, well done. Well
2
done.
haloalkane mean Woods reaction,
yeah.
2 haloarene mean Fittig reaction, haloarene with haloalkane means what? Woods Fittig reaction. Yes, what we can place is the CH3 we can place on the benzene ring. What
Now
we
we'll
get?
be getting toluene.
Toluene
This one
plus-
they asked for conversion as well. How chlorobenzene is converted to toluene. That so all the question you will be able to answer it if you know all the name reaction.
Yes.
That you keep in mind. Yes. Sir,
All
we'll
right.
go
So
to the
next question. Write the structure of the alkene formed by dehydrohalogenation. That is our
Yeah.
beta elimination of
Keep in mind.
1 bromo. Okay, let me draw the structure.
Yes,
1
one
bromo. I think 1 cyclohexane, right? 1 bromo, 1 methyl cyclohexane with alcoholic KOH. All right.
Yeah.
So with alcoholic KOH, what can happen? The beta elimination can happen, right?
Yeah.
So beta elimination means what happen? Bromine, let me take from the alpha carbon, and one of the hydrogen we can take from the beta
that one
carbon.
Keep in mind, should not remove from the CH3. Yeah.
The Zaitsev rule we have to be
rule you have to
careful.
keep in mind. Yeah.
Maximum the double bond we have to take in the crowded part, the most substituted.
Keep in mind, should not remove hydrogen from CH3 if there is any proficiency for hydrogen.
Yes.
Yes.
So write the structure of the alkene. Only they are asking the
Yeah,
structure.
That only you need
Yes.
to write, then you will get 1 mark.
So I think the
Hope you
compound
understood.
is
Yes,
1 methyl cyclohexene. Yes, good.
Well done.
Okay, let's go for the next one, dear all. Draw the structure of the major mono-halo product for each of the following. I think when they're presenting the answer, you should rewrite the structures.
Yeah, that we need to give you the one. See, these type of question means should not write the answer alone, means
Yeah.
the product alone. Better way of presentation will be the whole reaction you write and write. That
Yes.
would be better.
Rewrite the complete
Yeah,
structure.
Complete, yeah. Rewrite this one and give the answer. Complete.
Yes, I think let's go for the explanation, right? So I think you will be given the correct answer. I know that you can't able to answer this question in the chat box
yeah.
because it's a structure. Anyway, you know the answer, right? That's enough.
Yes, yes.
So I think bromine with the heat means what? That is our substitution
Free
reaction.
radical substitution, you keep in mind, Br2 with heat or H nu or delta,
Yeah.
whatever they think they are giving, that only keep in mind. H nu, light,
Yes.
sunlight, delta,
Substitution.
it's all free radical substitution.
And but we can ask a question to the students, sir, from whether CH2 or CH3, will you take hydrogen? Can you say?
From where hydrogen will be substituted?
Ah, yes, Rida.
From
Rida given.
CH2, yes.
CH2 place, Br will go. Yes.
yes.
Because this place having a speciality, what is this place called? Benzylic position. This is benzylic free radical will give you.
For free radical and carbocation, stability order is same. Benzylic will be the most
Yes.
that you keep in mind. So here the benzylic will come.
So chlorine will be there.
will be
Here it will be CH, Br, and then CH3. Yes.
That is
Good.
the right answer.
Good, all of you.
Yes.
Next one is.
Yes, correct.
I think this is an alkene, H plus and Br minus. We can apply
Markovnikov addition.
Markovnikov rule. Negative part goes to carbon with less hydrogen.
Hydrogen
Positive
and
part goes to more hydrogen.
Yeah.
And there is
So
a
we can write product.
cyclohexane. And there is a
Here it will be
CH3
as well as
and then Br.
Yeah.
All right.
Hydrogen anyway we don't need to represent.
Yes.
This is the compound. So this type of question and all while doing, we be very careful. Should not make mistake.
Yeah.
Okay. While adding and all, should not change the place. Then you can easily score the mark. The same way you'll be losing.
Yes.
So be careful, very careful. Yes.
Okay.
Next
And
one.
even these all are NCRT question, dear student. NCRT question. So HCl is there. H plus is waiting. H plus is waiting to get an OH minus ion. My question: whether you remove this OH group or this OH group. Let me number 1, 2. Which OH group you prefer to remove? Can you say?
CH2. Yeah. Wait,
That's given that answer. That's
H plus will go to yes.
first
yes,
one.
Exactly. They gave the answer.
First one or the second one?
Yeah. Cl will go to CH2. They gave the answer.
Second one.
Yeah,
Second one. If you remove this OH, my dear, you will get the carbocation.
Yeah.
This is again benzyl carbocation.
Yeah.
To which you want to add the Cl.
And you can easily remember this concept wherever OH is directly attaching, that never
remove.
replaced or substituted.
Yes.
Because of resonance, partial double.
Double bond will
Whether
be
it is OH or Cl, that all will be very difficult to substitute. They're due to resonance. That you can keep in mind. That is the logic. Wherever
Yes.
OH is directly attached, that will not be replaced easily.
So stability, a haloalkane chapter, mostly the questions are related to the stability of the carbocations and all. Be careful.
Yeah, that order and all you have to keep in mind.
Yes, next question, how do you convert? So I think conversion questions.
Conversion question, yeah, I think they did so many.
So many
Yeah, I
100
think
questions are
they
there.
Happy to see such type of conversion question now.
Ah.
Yes.
So don't make
Yes,
any
partial
mistake, all of
double
you.
bond. Yes, Smriti, that is the right one.
Those who are in online, here all, please comment which step we
Yeah.
need to follow here.
Yeah,
that we
they are
can
giving
write it.
The fatigue, well done, well done.
Chlorobenzene to
see,
biphenyl.
This is
Very
what
good.
we told you, all name reaction, you keep in mind.
Yes, we can treat with the sodium and
Sodium
dry
and
ether,
dry ether.
and we will get which one? Biphenyl as a product, right? Biphenyl is getting through what? And if you know the name of the reaction, I think better to just mention that one to get an impression from the paper, the evaluator. So we can able to say that what this is what? Fatigue reaction. At the same time, we should be careful. Writing the reaction and writing the wrong name in that one means that will make a bad impact on you about this examination. So if you are confident about the name of the reaction, you can present it. That's it. So I think let's go for the next one, right?
Second one, sir.
Propene.
to 1 iodopropane. Yeah.
Propene to 1 iodopropane.
Yeah.
So someone is using HI in presence of peroxide directly.
That will be wrong.
Wrong.
Should not make mistake.
Ah.
Always with peroxide means HBr only is
Only
allowed to
possible,
add.
yes.
Yeah, only HBr. HBr in presence of peroxide only HBr is allowed. Otherwise not.
Yes, so let me add
So
first
we
of
will
all.
add HBr
First, let's bring bromine
Yeah,
first.
bromine first.
So we will
After that,
get-
we get again name reaction. I think they are, yeah. Yes.
Yes, we'll get
yes.
bromo. Then we can replace by what? Sodium iodide and dry acetone. That is our Finkelstein. We can use
so
it.
here we two concept, Markovnikov addition and Finkelstein.
Yes, that's
Together
it.
will come.
You are getting the answer right here all?
Yeah, they gave HBr peroxide and after that Finkelstein. Well
Okay,
done,
fine.
well done, well done.
So third question. I think 2-bromobutane.
to but-2-ene.
Yeah, 2-bromobutane. And also while you're drawing the structure and all the valency of carbon, please careful all of you. Because the teacher can easily able to understand where is the mistake in organic compound. So be careful about the valency of carbon while writing. So this is 2-bromobutane. How you can convert into but-2-ene? What is the reagent? Yes, sir, they already given the
Yeah,
answer.
they're giving the right
Alcoholic
yeah.
KOH.
So
yes.
beta elimination will take place
Its
very
place?
easily. Here also
we'll get
based on
what?
Seitz-Zaff rule, they are indirectly checking whether you know the concept of Seitz-Zaff rule or not.
Yes.
So Seitz-Zaff rule based one question definitely will be there.
And
so this is indirectly Seitz-Zaff rule.
Yeah.
Okay.
And whenever you're getting a two products mean, always try to write the major product. Please don't stop with the minor. Either write both of them, minor and major, or write only the major one. Okay. Okay, I think this is all right.
We'll go to the next one.
Yes. Give reason.
Yeah. Give reason.
I think CCl, if they seen means they immediately say yes sir,
Give
partial double bond.
partial double bond.
Right. CCl bond length in chlorobenzene.
Yes. Chlorobenzene they are talking about and
Shorter
bond in
CH3Cl. Dear all, you know that mostly you will write the partial double bond character.
Yeah, but one more point you have to keep in mind.
S character also we have to present it, all of you
Chlorine
please.
is attached to an sp2 hybridized carbon.
Yes.
That you keep in mind. That is why bond is very strong. So 2 points better you write while presenting. First one is due to resonance carbon chlorine bond is partially double. Moreover, Cl is attached to an sp2 hybridized carbon. Here in CH3Cl you have to say that Cl carbon bond is purely single.
Yes.
Because no chance of resonance. Second point is chlorine is attached to an sp3 hybridized carbon which is a weak bond.
Yes. So higher the S character, you know, higher the S character means that will hold that chlorine and all very tightly. Their electronegativity is more. So removal of chlorine is again harder. So and partial double bond and sp2 character. We should mention why CCl bond is shorter and stronger.
All the reasoning question try to write
Good,
at
good.
least 2 points, okay, that you keep in mind.
All right.
Yes.
And second
So,
question.
yeah.
That's okay, right?
Yeah.
Any
correct.
doubt?
Yeah. No.
Okay, fine.
Yeah. And now that 2 points you have to keep in mind: partial double bond character and attached to sp2 hybridized carbon in case of this.
Okay.
Yes.
Next one. The dipole moment of chlorobenzene is lower than what? Cyclohexyl chloride. Simple one, right?
Yeah.
NCRT, the reader back
Given
question.
one, yes.
So we have to relate with which one a dipole moment diagram,
Yeah,
plus
dipole.
R and minus I effect and all.
Yeah.
So you know
Here-
halogen on having two effects. Yes,
Yeah.
which all? That minus I effect is there, so it withdraw, and donating effect is there, that is plus R. So there is some cancellation can happen.
Yeah.
Whereas in the haloalkane, what can happen? Only one effect, which one? Minus I effect. So this is the one, only the dipole moment. So here there is some cancellation due to these two effects, but there is one. Here complete dipole moment is this direction. So this having high dipole moment than chlorobenzene.
Yeah, this way also you can remember this chlorine is attached to an sp2 hybridized carbon.
Yes.
So electronegativity difference will be almost same. Okay, here no dipole moment.
Carbon.
Here chlorine is attached to an
sp3
hybridized
carbon.
So
Yes.
sp3 hybridized carbon means less electronegative. Less electronegativity to more electronegative, dipole moment direction will be on upward.
Correct.
Here no dipole moment because both are having same electronegativity.
Right.
Okay, that you have to keep in mind. Yes.
Okay, so let's go for the next one. SN1 reaction are accompanied by racemization in optically active alkyl halide. So there are two steps in our SN1 mechanism. In first
Mechanism you
step,
have to keep in mind.
yes. First step that halogen get removed and you will get what? The carbocation. And in the carbocation, the nucleophile can attack through which one?
Yeah.
Through left side attack is possible, right side attack is possible.
Yeah. You have
So
to say, yes, sir. You have to say that the carbocation is planar, so nucleophile can attack from the front side and rear side. So front side will give one and the rear side will give the another one, equal mixture, that D and L form, that is racemization.
so 50-50 chance is there to get dextro and levo, that is called what? Racemization.
D and L equal equimolar mixture of D and L will come because of front and rear attack
Yes.
of nucleophile.
Right?
That's over.
Nucleophile can
Yes.
attack from both sides.
Yeah,
Yes.
left and right.
Just
Yeah.
express with a
Instead
small
of-
diagram and
instead
all.
of left and right, Ashmita, you should write front and rear.
Yes. Okay.
Front and rear. Then
Next
we'll-
one.
yeah.
What happens when the first one chlorobenzene is treated with? Chlorobenzene is treated with chlorine in presence of what? FeCl3.
Yeah.
This is our
electrophilic substitution.
electrophilic.
Every electrophilic substitutions are important. Yes.
And haloarenes, we know they are
Dihaloarenes
weak
will be getting-
ortho-para directing group.
Yes,
So
Cl
one
plus.
chlorine can go to ortho position and one
One will
chlorine
be
get to
coming in
para.
para position.
So orthodichlorobenzene and orthodichloro
Para-dichlorobenzene,
para will
right.
get in, and this will be the major and this will be the minor.
Yeah.
And second one is ethyl chloride. Ethyl chloride is what?
That is again
CH3
substitution reaction.
substitution reacting with the AgNO2. Our ambide and the nucleophiles, very careful.
Yeah, that KNO2 and AgNO2, AgCN and KCN,
ACN.
that all reaction you have to keep in mind.
So I think we can check it, sir, if there anyone make a mistake or not. So can you say AgNO2 give you NO2 or ONO? NO2 or ONO. Final stage, a day after tomorrow.
NO2,
Don't make this
Ansh is giving
NO2, right?
answer. So
Yes.
NO2, CH3,
CH2, NO2, right? Along with the AgCl
If
can
it is
form.
KNO2 means ONO will come.
Yeah.
But you keep in mind, AgCN will give
Isocyanide,
and
KCN will give you CN, cyanide. And I think, ready, right? Okay. 2-bromopentane is treated with alcoholic KOH. You know, 2-bromopentane. So 2-bromopentane when react with what? Alcoholic KOH. Again, they asking which reaction? Beta. This Br and this H, I think they will prefer.
Again, see, Sets-Up rule is applicable.
Yes.
Wherever Sets-Up rule is applicable, you have to keep in mind, should not remove hydrogen from CH3. That is the easy way to remember.
Yes, we will get the pent2ene from this
So right
compound.
answer is this one. So
Right.
equation you need to write very neatly for every question. Yeah.
Yes, dear all are ready, all of you. So half an hour we completed. I think question number 58. Two more questions are
we have
waiting.
from the chapter haloalkane.
Give
Now
reason. A. N-butyl bromide. So don't wait for some others. Let them write the exam. So we have a paper. We are writing our answer. N-butyl bromide.
has higher boiling
Point than tert-butyl. So don't forget to write the structure of the compound. Yes. And I think the answer they will give it very fast.
ONO will come in for KNO2 instead of this one. The previous one AgNO2 was using no. AgNO2 when we use, we will get NO2 as product, nitro. Okay. ONO will come. Okay. In case of KNO2.
Yes, my dears. So here there is no branches, therefore having high boiling point. Here there is branches. So what happens? Surface area decreases. So boiling point. So
When
mainly
branching increases,
surface area decreases,
then
boiling point decreases.
You can say intermolecular force of attraction decreases.
Yes.
Because larger surface area means more attraction.
Okay,
So,
I think this is clear, no? Second question. The presence of nitro group at ortho-para position increases the reactivity haloarene. Let me take one example, chlorobenzene. So if suppose there is a nitro group in ortho or para position, they are saying that will undergo nucleophilic substitution faster. I think they have the answer, right?
Yeah.
So nitro group is what group?
Electron withdrawing group.
Withdrawing group.
Okay. It prevents the benzene ring undergoing plus R effect.
Yes. So they will pull the electron from the chain, so that make the CCl bond what? Weaker. So it can replace this chlorine and we can bring the nucleophile easier.
Substitution reaction will take place.
Right.
Nucleophilic substitution will take place.
So be careful, all of you. Electron withdrawing group, if there on the benzene ring, electrophilic substitution happen.
Yes.
Sorry,
And sir,
nucleophilic substitution happen faster.
And sir, we can tell you one thing and clearly remember this one. This haloarenes prevents nucleophilic substitution, not electrophilic.
Yes.
There was a question for assertion reason.
Haloarenes prevent
electrophilic substitution, wrong.
It prevent only nucleophilic substitution.
It can easily undergo electrophilic substitution, no doubt.
Yeah.
Okay. Nucleophilic substitution, that you keep in mind.
I think the answers are clear, all of you. Are you there? Are you there? Are you there? And hope you all seen this question before and hope you can able to recollect these questions and all. Yes or no, my dear students? It's time 7 o'clock. I think 4 hours now we completed.
Yes.
Yes.
Being 4 hours. Yes. We are continuously interacting with you guys. Okay.
So this is the last
keep
chance.
Your energy for a few more hours. Okay. Be active. Yes.
Right.
Yes.
Let's go for the
Thank you.
last question from the chapter. Haloalkanes again. Haloalkane easily dissolve in organic solvents. We know that haloalkanes are insoluble or less soluble in water.
That question or this one you can expect. Yeah.
So why they are insoluble or less soluble in water means we can able to say that they can't form the hydrogen bond with water. But why they are soluble in organic solvent means what we studied, like dissolves like. So organic compounds what? If they organic solvent, if you put the haloalkane, the newly bond forms are what?
The new
this is
bond
stronger.
and the existing bonds are having same
Energy.
energy.
Strength.
Okay, or same strength. That is why.
That's why. And what is known as a racemic mixture that already we discussed? Equimolar mixture of what? Dextro and levo 50-50. And why their optical rotation we know. And optical rotation cancel each other. Say they're optically inactive. and give an example. So we can give an example, right? So we can say plus minus butane to all, or
the easy example, butane hyphen 2 hyphen all, plus
one-
minus, which means
one chiral carbon
one chiral carbon
should be
Any
there.
compound you can write,
Yes.
no issue. Plus
and
or minus.
yes, and again question of the two bromo derivative. Let me just to show the structure. C6H5, CHCH3, and then we have Br, and another one is what?
Yeah.
C6H5,
CH, and again phenyl group.
Phenyl group.
And we have Br.
Br.
Yeah. We have two compounds over here. You know that one, which is more reactive towards
SN1 substitution. SN1 means first cut. What? Halogen go and make the carbocation. Which carbocation stable?
Say that this is the benzylic one, and more phenyl group comes,
Yes.
more resonance and more stability.
I think here both are secondary, but here only one phenyl group. Here what? Two phenyl group. More resonance possible.
So this will be
more
the,
stabilized.
this will be the benzylic one, benzylic with the one benzene ring, and benzylic with the two. So 2 means more resonance.
Resonance.
More resonance means more stability.
Yes.
That you keep in mind.
So this will undergo this SN1 reaction faster. So I think the and sir, we can just conclude about the remaining part also. Haloalkane chapter. So we have to mostly expect SN1, SN2, beta elimination, name reaction, conversion, reasoning. So any point missing means we can just inform.
Polyhalogen compounds you have
Yes.
to keep in mind. Okay, should not forget to read that part. That polyhalogen compound DDT and CFC, chlorofluorocarbon, and that
Chloroform, phosgene formation. Yes.
That many part you have to keep in mind.
Yeah.
Okay, almost these are the most probable part. They will be giving the question that we discussed already.
These are the
Okay?
types of question you can expect from which one? This kind of organic chapters.
Yes.
So that is our simple chapter, haloalkanes and haloarene. I think we can go for the next organic chapter. You know,
Alcohols and phenols
alcohol,
we'll be discussing.
phenols
Yes.
and ethers. So these are the important topic or important name reaction. Just to recollect all of you, there are 3 important name reaction in this chapter.
Yeah, this chapter only the
Colts.
basic, but the most repeated name reaction we can say that
Colts and Riemer-Tiemann.
Every question paper, these Colts and Riemer-Tiemann reaction, 100% sure it will come.
Yes, and also the Williamson related, the twisted questions also we can expect.
Exactly.
And the distinguishing test, dear all, don't forget, Lucas test is there to distinguish primary, secondary, tertiary alcohol. Neutral ferric chloride test is given, which one? Phenol, the violet color. An iodoform test, the compound which contains CH3, CHOH functional group, and the acidity of alcohol.
Many times they give the question.
Yes, and the ether bond breaking part, dear all, don't forget. Yes, it's okay, I will send it,
That you can watch in the YouTube itself, okay? You can.
Because
later
not
on
to
you
get
can
to
revise,
just an
no issue.
answer.
Yeah,
So
yeah.
through that we have to discuss what all possible. So that's what we need here all. So let's go for the first question. Out of tert-butyl alcohol, that is, you know, this is the tert-butyl alcohol and
Which
what they
will
asking?
undergo acid catalyzed dehydration faster and
Ah,
better. See, already we
dehydration.
did- Yeah. Wherever dehydration comes, carbocation stability you keep in mind.
yeah, elimination when it comes what? That
Dehydration
first
is a type of elimination.
elimination.
Yes.
So this is what?
Primary carbocation and tertiary.
Tertiary. So which will
wherever
undergo
tertiary comes,
that will
tertiary
undergo
be
reaction
more reactive.
faster. And why? So I think they already given the answer.
Yes, tertiary butyl,
okay.
all are giving the answer. Yes, very good. Very
Okay,
good.
right.
Yes.
Next question B. Carry out the following conversions. Phenol to salicylic acid. That is our
reaction. Yeah.
that is our Coles reaction. So what is the reaction?
Phenol
Finally, phenol react with yes, sir.
NaOH, you will be
NaOH,
getting
ONA,
sodium phenoxide,
right.
then again carbon dioxide and H plus.
H plus. We will
You
get
will be getting OH and
OH and
COH.
COOH,
called
orthohydroxy benzoic acid or salicylic.
That's called salicylic
But
acid.
they're asking salicyl aldehyde, right? So
Yeah.
salicyl aldehyde means we
means
can go for what? Riemer-Tiemann reaction.
reaction.
So
Yeah.
first we can treat with
CHCl3.
yes, we
then
can
here
get the
will be
CHCl to the intermediate.
Yeah.
Then we can treat with
After that,
either we can write
NaOH
NaOH and last H plus.
Yeah.
We can get the
Then we'll
what?
be getting
OH and CHO, orthohydroxy benzylaldehyde or salicyl aldehyde.
Riemer-Tiemann reaction.
Yes, Riemer-Tiemann. This is Riemer-Tiemann. Yeah, not Scholes. Scholes mean what? Scholes mean phenol to salicylic acid. Riemer-Tiemann phenol to salicyl aldehyde. That's a correction.
Yeah,
Second
next
one.
Ethyl chloride to tertiary butyl ether. This
Ether.
one you have to keep in mind.
Yes.
That's what we told you. This one, see, keep in mind it's Williamson synthesis. There is a logic. Whenever Williamson synthesis reaction takes place, tertiary alkyl halide should not use. Because tertiary alkyl halide, wherever you use with an alkoxide, it's elimination. But keep in mind, Williamson synthesis is not an elimination reaction. Williamson synthesis is a substitution reaction.
Yes.
Nucleophilic substitution. So if they are asking for MCQ question and all, Williamson synthesis comes under what? It's a nucleophilic substitution
Reaction.
But wherever you use a tertiary alkyl halide, so here they are asking to prepare a tertiary ethyl ether, but should not take tertiary alkyl halide. Tertiary alkyl halide always favors elimination over substitution. That you keep in mind.
Yes.
So we can write now.
Yes, so ethyl chloride is
Yeah.
ready. We have to make into tert-butyl ethyl ether.
Yeah.
So this part already there with us.
Yes.
So we
Right.
need to get this one.
Yes,
So we know Williamson synthesis means what? Haloalkane
Alkane
reacting
with
with
the alkoxide.
sodium alkoxide.
Yeah,
So let us
here we'll
take
be using
sodium tert-butoxide. We can use it, right? Sodium
ONA.
tert-butoxide. This Na and the Cl cut will get this ether.
this compound.
Yes.
So, but should not use
If it-
ulta.
Ah.
That reverse should not take. It will be a big mistake. That
Yes.
you keep in mind. It's against the logic.
Yes.
Hope you understood. Yeah.
So that question, careful all of you. So if you just interchange this alkyl group, so tert-butyl will go there, ethyl will come. So sodium methoxide, these all are act as what? Strong base.
Yeah.
So instead of that,
Tertiary
instead of
alkyl
Williamson,
halide, yes.
beta
Tertiary-
elimination happen.
Yeah. So that should not do that one. That you have to keep in mind.
Yes.
Sir. We can go
I think
to
one
the
another
last
simple
one. Yes.
question. Propene.
Propanol.
Propene we have to convert into what? Propanol.
Here
I
you
think
can use the name reaction as well, sir.
Yes.
That will be easy. What
That-
is the
that,
name reaction? Can you tell, dear students?
that you
Can
studied
tell
in
the name
alcohol
reaction?
phenol chapter.
Yes. Can you tell the name reaction? What reaction convert propene directly to propanol?
Propanol.
Propene directly to propanol.
What
Yes,
is that?
Salman.
Two reactions are there. What two
It's
connection?
Close.
Hydroboration. One more is there. No, one more.
Yes.
What is that exact? What is the tail part? Hydroboration,
Oxidation.
oxidation reaction.
Hydroboration oxidation.
Ah.
Propene directly.
First we treat
P2H6.
with the diborane.
Yeah,
Then what?
H2O2
Hydrogen peroxide.
slash OH
OH minus we
You
get
will be
directly.
getting propanol. That will be easy.
Yes.
So because name reaction, if there means you can write directly, you will get the mark completely.
Right.
That would be better.
That's a conversion. Next question for you.
Yes,
That is
question number 62.
again conversion question.
Yeah.
First one.
Sodium phenoxide.
Sodium phenoxide is what?
Yeah,
ONA.
in between. Here also it's a name reaction only.
Yes, but
they did not start from phenol.
Beginning.
Yeah.
Ah,
They
that's
did not
a-
start from phenol. I think they are giving the answer. Yes.
This is our salicylic acid.
Yeah, correct. All they are giving.
Yes, salicylic acid from sodium. First
Sodium.
we treat actually phenol
Phenol
with aqueous
with aqueous
NaOH.
NaOH.
We get this. Then later on treated with the what? Carbon dioxide
Right,
and
and
acid.
H+.
We'll get
Yeah.
the salicylic
Salicylic
acid.
acid.
Second,
Acetone
acetone.
to propene.
Simple reaction, right?
Yes.
Acetone is propanone. If you want to convert into propene, first we have to do reduction.
Yes.
So let's do
So
Na.
secondary alcohol can take NaBH4. Ketone, the best reducing agent is NaBH4.
To convert a ketone to alcohol. So it's a secondary alcohol. Secondary
After
alcohol.
dehydration.
Dehydration. Either we can use
H2SO4 and delta. You can write.
concentrate H2SO4 and heat or
You can write.
H3PO4.
That also you can use.
We
Secondary
can-
alcohol means weak acid is also works.
Yes, so we can use this.
Yes.
Propene, we can get it in
Yeah.
two
So
steps.
for dehydration normally you can write H2SO4 delta. They will give you mark. No issue.
Coles reactions,
Yes,
Sally. No problem. Okay, fine.
Yes.
So third one is phenol to chlorobenzene
That is another
symbol.
one. Very simple one.
Phenol.
Yes.
First we can just remove the OH group, right? That's the
That will be-
oxygen we
yeah,
can
zinc
remove.
and heat.
Heat, zinc
will
dust
get
and
benzene.
heat
Yeah.
will get what? Benzene.
Benzene.
To which we can
Then
bring chlorine with what?
fluorination,
FeCl3 or AlCl3. We can use the chlorobenzene, and the opposite, you know, dose process.
Yeah,
Right.
opposite is dose process.
All right.
Okay.
So-
all this conversion you have to keep in mind. Yes.
Everyone, do you remember these conversion questions or not? Or do you afraid about these conversion questions?
I think organic they are very confident. Yes, guys.
Yes
Tell
or
yes
no? 33. Okay, don't forget all of you. Organic chemistry is a time-saving one. Immediately we can able to answer it. No need of a lot of calculation, and it should not waste your time.
Yeah,
Easily we can.
practice means you will be able to answer all the questions from organic that you keep in
Yes,
mind.
all
Yes.
right.
Yeah.
Next
organic,
one.
Yeah.
Account for the
Automatic.
following. This question many times they were revised.
I think this is the only we discussed just before. I told you
Ah.
orthonitrophenol and paranitrophenol.
Yes.
Yeah, they
Ortho-
can be steam, separated by steam.
Distillation.
Distillations
Yes.
be volatile.
So no, orthonitrophenol, the main point is what? Intramolecular hydrogen bond, whereas paranitrophenol having intermolecular hydrogen bond. Inter is more stronger than intra, so it can easily what? That orthonitrophenol is easy to volatile because of the weak bonding.
Yeah, in ortho the NO2 group is close enough to make intra, but in para it is far away, so it cannot make intra, only inter.
Yes.
Inter means high boiling point, intra means
Less boiling point.
Less boiling point means more volatile.
And this is the
Yes.
this is the question, sir. We said that was a special
Yeah,
case.
should not make mistake. Again, see tertiary butyl chloride on heating with the sodium methoxide.
Methoxide.
gives. This is what we discussed just before.
Okay.
They asked in different way in all the question paper. Here elimination whether you know or not.
Whether so let us ask. Finally, we can ask the questions like whether here beta elimination or any Williamson synthesis can happen. Can you judge it, all of you? Whether elimination or the Williamson synthesis, which one can happen in this case?
Yeah, this is the condition we gave you. Wherever tertiary alkyl halide when reacts with an alkoxide, always keep in mind elimination favors over substitution. So no substitution, elimination will come. That's
Yeah.
why they are giving. Yes, you have to say that it is elimination over substitution.
Yes.
So right answer is tertiary alkyl halide when reacts with an alkoxide,
Which is-
elimination favors over substitution.
Substitution.
Right.
So this is what methoxide, sodium methoxide, sodium ethoxide. If these kind of
All
things
those
come,
are
there
stronger
are
bases.
strong base here or like alcoholic KOH.
Yeah.
So it undergo beta elimination. So let me take one
Cl
chlorine,
and
one hydrogen.
This one. So
Yes.
CH3C. Here you will be getting CH3.
Double bond
yeah.
CH2. We'll
Yeah.
get 2-methyl propene as a product. Yes, we won't get
That is
this
they are
one.
telling tertiary butyl ether, methyl ether will not be forming.
Yes.
That you keep in mind.
So
now,
and
Riemann-Tiemann reaction
already we discussed,
no need
and
to write.
so definitely we can expect two
Riemann-Tiemann
named
or
reaction
Coles,
from in chapter.
Yeah, definitely will come.
Riemann-Tiemann,
That is, 100%
Coles.
sure we can say Riemann-Tiemann and Coles.
And what about Friedel-Crafts alkylation of phenol? You know, phenol is a ortho-para directing group.
Yeah.
So when we do a CH3Cl in presence of anhydrous.
And here, sir, we have to tell one point. Them should not skip the one product, because here they are asking the reaction means both the product you should write. Only in the
And
conversion you can skip the minor one.
Yes.
But here you should write both ortho and para derivative.
Product. And you should
Okay?
mention which is major and minor.
And you know the name of this one, right? Can you give the name? Hello, students. Can you give
That's
the-
having a common
that's
name,
a
dear.
Common name for this one. Can you-
Phenol with a methyl group, what we call?
What is
Phenol
the
with a
common
methyl
name?
group.
We need your answer. In
Yes, all of you.
Hello, dear students.
Come on, come on.
Yes.
Hope you get Horlicks
No,
boost and
no,
all.
No, Rida.
Right.
See the compound again. See the compound again.
What is that?
See the compound. Yeah. Now
Yeah.
correct. Hisham. Well done. Well done.
No,
Ashmita. Ashmita. No.
That catechol, see catechol, resorcinol and all are
That
there.
is both
That
OH.
two OH groups.
Yeah. This is CH3.
This is-
Ashmita.
Okay, this is okay. This is benzene 1,2-diol.
Yes.
Crasol.
It's
Yeah. Crasol is the compound.
Yeah, many question paper they gave that common name. That's why we gave a chance to give the name.
Yeah.
It's Crasol. Keep
Maybe
in
you
mind.
can expect MCQ question. What is the IUPAC name of orthocrasol
Yeah.
or catechol,
So this is-
resorcinol?
Yeah, this is orthocrasol. This is
Paracrasol.
Yeah.
And I think they will give the answer. Give simple chemical test to distinguish between ethanol and phenol.
Yeah, they are happy.
Ethanol.
Yeah.
Ethanol and phenol. Which test here? Which test you are going to do that? Which test? Neutral.
For practical also you did the same.
Yes.
Sabih, well done.
Very good.
Good.
Neutral ferric chloride
ferric
test.
chloride.
And
one
the,
more point. What is the color of the compound form?
what is the color
What is
of the
color
complex
compound
form?
Oh, game.
What is that? Forms violet complex. Yes, violet complex is given by only phenol,
Yeah.
not by ethanol.
Yes.
That we have
So
to
you
write there.
Write the thing.
Yes.
Okay,
So
yeah.
in this chapter, as I told you, we have three distinguishing tests. Lucas test is there, neutral ferric chloride is there, and the iodoform test is there.
CHOH.
Yeah.
Yeah.
Next one, give equation for of the following reaction. Phenol
treated
is.
with a concentrate nitric acid.
I think they will give the
just
answer
one.
fast.
Yeah. Give the common name. We
Come
have
on,
given
all.
the chance.
Phenol.
The product has a common name. Give that common name. Give the common name. For the
Phenol
question.
treated with the concentrated HNO3 you will get.
Size to the when when you are writing distinguished test, the mark for the equation as well. For every distinguished test, you should write the equation. First,
Yes.
you have to write which test.
For example, neutral perchlorate test should not leave like that. They may cut your mark.
That we have to
As
say
per-
what's happening there.
Yes, as per CBSE norms, you should write the test name below equation. Phenol plus FeCl3 gives, okay, C6H5O thrice Fe plus HCl. Then you have to write violet color. That is the way you should give the answer.
Yeah, so the given the answer is what?
Picric acid is
Picric
given.
acid.
Yes,
Color you
well
remember?
done.
Yellow color. Picric
Yeah,
acid.
that common name. Well done. Well
I
done.
think, sir, this question we already discussed as an equation in
Yeah,
conversion
already
question.
we did. See, propene.
Propene.
Hydroboration oxidation. I
Ah.
think we did already.
Diborane means nothing. That is what?
Wherever
Propene to what?
H2O to OH minus comes.
Yes.
Okay. That hydroboration oxidation is even a very important name reaction.
That's become
So, yeah.
propene to propanol. Yes, good all of
How will
you.
you distinguish? Another one.
Butane 1-ol,
and
butane 2-ol. How will you distinguish, dear all? Come on. What is the name of the test called?
Yes.
Butane 1-ol and butane 2-ol. How can you distinguish it?
Distinguished test. Tell the name of the distinguished test.
I think iodoform test is possible, no?
Use, but
Yes.
better or best one we can
We
use
can
as-
Lucas also
Lucas
possible.
also possible.
I think iodoform is given, no problem, dear
No
all.
problem. Iodoform also you can
Yes, butane 2-ol. This is our butane 2-ol compound. Yes, it having the group. It will give
CHOH group is there.
the
So no issue. That
yellow
one also
color.
will give. Yes.
yes.
Or
And
better you can
Lucas
write
also.
you can
What is observation? All of you Lucas test. The secondary alcohol will give turbidity after 5 minutes. Primary alcohol won't give turbidity, normal temperature. Right.
But yeah, keep it in mind. Yes.
Okay, one important question. Arrange the following.
In the increasing order of acidity. Yeah.
Acidity.
So this one, yes. So
Which all compounds are? Phenol is
we
there.
have, and
Ethanol we have.
and water we have.
Yes.
So here people may get confused with the water.
Water and alcohol.
Do you need a chance to give the answer? We will
Come
give the
on.
number. A,
Let
B,
me
C.
write A, B, C. Can you say? And one more thing, all of you. They ask you the increasing order.
Yeah.
Increasing order.
Yes, Smriti. Yes, yes. Well
Which
done,
one?
Well done, well done. So yeah.
Phenol,
Correct,
yes.
correct. Phenol is the most
Most acidic
no
because
doubt.
of phenoxide ion. Yes,
Phenol
A is the
acidic
most.
Because
Water and alcohol.
there should not make mistake. There should not make mistake.
So-
don't think in real common life and all. This will be that. No. Here you keep in mind.
The main point is what? It's an
Alkyl group
EDG.
has-
Alkyl group, if there mean acidity decreases.
Yes.
So this B
Plus
is
side
the
effect
least
is
one.
There then, but H2O doesn't have a plus side effect.
Yes. So phenol is most, then water, then ethanol is the correct
Ethanol
answer.
is less acidic than the water. That always you keep in mind because of plus effect.
Yes.
Even they asked in the question paper why ethanol is less acidic.
Right.
Okay.
Arrange
So,
the following
65.
in increasing order of their acidic character. So carboxylic acid part and phenol
Yes.
part, we can expect for acidity related question. So benzoic acid A, phenol is B, cresol is C.
Yeah,
I
here
think
cresol came. That
Yeah.
is what we
Huh.
gave this one before.
cresol
Yes.
means what? OH and CH3 on benzene ring. Come on, which is most or increasing order of acidity. Come on, all of you.
Whenever you
What about?
consider any alcohol and carboxylic acid, sir, we can say that carboxylic acid is the most.
Yeah,
you
Yumna, that Yumna will discuss in the amine chapter, okay? The basicity and all will discuss that.
Yeah.
So which is the most acid? Always carboxylic acids are what? More
Alcohol
acidic.
and carboxylic acid commonly when you consider
Acid.
alcoholic and carboxylic acid,
Yes.
always carboxylic acid that you keep in mind.
Then phenol
sir.
and cresol, something we have to careful. Phenol
Yeah,
and
phenol,
cresol,
cresol.
which cresol they didn't mention. For example, if it is paracresol, you know it's an electron
Any cresol,
donating
it is
group.
Whenever CS3 comes, wherever CS3 comes, electron donating decreases
Decreases the
acidity.
acidity. So we can able to
cresol
say
is less acidic than phenol.
phenol. So A, we can go with the B, and least one is what? C. So C, B, A.
I
Yes.
think all they gave the
Ash-
correct
who given the
Salman.
correct answer? Muhammad
Salman
Saba.
gave, Venkat gave,
See,
yes.
this is the one we want to notice that. See, the mistake happen is what? Your answer is correct. Answer in the sense order is correct, but not as per the question. They are asking increasing order mean symbol should be careful, all of you. Lesser to
Should
higher.
not use the greater than symbol, they will give you 0 mark.
Yeah, concept wise it's correct, but the answer to the question. Okay, increasing order. Next one, dear all, write the structure. Okay, let us do it very fast, sir.
Another repeated, complete the question, and
Yes.
this is the reader question. Many times, I think the same question came.
Repeated,
Yeah.
you know, the purpose of the reagent, try to understand, all of you. NaBH4 is what? A reducing agent. It convert ketone to secondary alcohol and aldehyde to primary alcohol. So do not touch this place. That's very very careful.
Yes, it is an ester.
Ester.
Never be reduced by
NaBH4.
Keep in mind. ester cannot be reduced by
NaBH4 only.
NaBH4 is mainly for aldehydes and ketones.
Yes.
Yeah,
So the
keep it.
ketone part only becomes what?
Secondary alcohol.
Alcohol. The other
remaining
thing.
part remains as the
Yes.
same.
As it is, you write there.
Yes.
Fine.
The right side part will remains as the same. I
Yes.
think all you got. Yes. Yes.
All
based
right.
on- yeah.
Okay, so H plus is there, OH minus is there. What is this reaction? An alkene is
Yes,
there,
yes.
acid catalyzed hydration. You know Marconi-Cos
Here,
rule we can apply.
Marconi-Cos rule you have to apply directly.
Yes, OH minus here, H plus here, we get benzene with the what? CHOH and then
Single
CH3,
bond
we get it.
CH3. Yes.
And this is the one of the
See,
expected
here,
question.
Yeah, again, attack of HI against an ether. We have 3 cases. I think all will come. Wait, this is for aromatic ether. See, aromatic ether. One thing you keep in mind: one product will be
Phenol.
That you keep in mind. One
Yes.
product will be phenol. Should not make mistake. Any aromatic ether, whether it is CH3. One product will be phenol. Then what remains is C2H5. Then you give
H,
OH,
the iodine.
That iodine with that one.
So aromatic either mean after the break you should get phenoxide
One
ion.
compound will be phenol. No
Yes.
doubt.
So
One
here
compound will
minus,
be-
here plus.
Yeah.
So to the minus, H will
plus
go.
there.
You'll get phenol there.
Aromatic
And
ether, whenever they are giving, one product should be this one.
Yes.
Phenol. Yes.
and the other one will be C2H5I. Yes?
Yes.
Given right? Yes, we'll
Yeah,
discuss
yeah,
Emina.
ethyl
We'll discuss.
added.
We'll
Correct,
discuss.
correct.
Okay, we'll
Phenol,
discuss.
Yes. Ethyl added. Yes.
Next one is.
Yes.
Next question is. I think all those questions we
this is
completed,
what
right?
we told.
Yeah.
This
This
is
over.
sir. Here, this is what we told. The
Yeah.
second case of addition of HI against an ether.
Yes.
See here, either whenever is added against a tertiary carbocation formation,
This is
then
tertiary.
it forms according to carried out according to SN1
one mechanism. So
Yeah.
tertiary, if there mean, please make the
Yeah, make-
tertiary part. So you'll get tertiary carbocation.
Because this is the most stable carbocation, tertiary
Yes.
carbocation, then I minus will join there.
Yes. So we can.
write CH3
Here
is
we can
CH3.
place the iodine.
Yes, iodine over
And
here.
Right
Yes,
side you will
plus
get
the
what?
CH3
CH3OH.
Methanol will come.
Right.
So this is the product. That 3 cases you have to keep in mind. Another one is also there. So next one.
And copper at
Right.
573 mean they
That is
definitely
the-
know what is the purpose of that. But it's a
distinguished test as well.
Yes.
That's why they are asking or primary,
Secondary, tertiary.
alcohol can be distinguished.
and here what is happen? You know it's a secondary alcohol here. It's on oxidation. You will get a ketone. So CH3, CH2, CO, CH3.
Yes.
Right? So secondary alcohol on oxidation, what we get? Ketone.
Corresponding ketone you will be getting.
Right.
That you keep in mind.
And this is a named reaction. See, they are giving the same concept in different way.
Yeah.
This is phenol treated with a chloroform aqueous NaOH followed by treated with the acid. What is this reaction called? That is our again Reamer,
reaction.
T-man.
So yeah, all the name reaction, even the conversion, complete the reaction and all, it's based on name reaction. So that you keep in mind.
Yes.
So we are getting Reamer T-man reaction product as
That's our-
yeah salicylaldehyde.
Right, salicyl aldehyde is going to form. Next
So,
one, 68th give reason.
One, question number 68.
Phenol is more acidic than.
Methanol. I think
Yes.
that is the easy one. They will give the answer. Yes, you can type here.
Phenol, can you say the exact name? What is needed in this question, all of you? What is the exact name? Phenol is more acidic
Yes,
than methanol.
yeah,
Why?
that because phenoxyrion, yeah, and so the it's first one CH3. Yeah, in the previous one that wherever a
Sorry,
tertiary
down.
carbocation formation chance is there, here it's the mechanism is SN1, dear students, SN1. Okay, SN1 always forms based on the carbocation stability. So if the bond breaks from the right hand side means you will get methyl carbocation, that is not stable. Left hand side, if it breaks, it will be a tertiary carbocation. So methyl carbocation and tertiary carbocation, which is more stable? Tertiary carbocation. That is why left side, not from right side.
Yes.
Right side, if it breaks, it's methyl. Yep.
All right. So
Yeah.
I think let us just clear that doubt, sir. Here, suppose the compound is given as CH3, CH3, OCH2, CH3.
Yeah.
In
either
this
when it
case,
comes- yeah. So you know that one here. It's
here tertiary is not there. This
Yeah.
is like a secondary group. This is a primary group. Such a cases, which is the less steric hindered place, like SN2.
You have to check the size of alkyl group.
Yeah. So this what?
Molar alkyl group. This follows SN2 mechanism.
Yes.
Keep in mind SN2 mechanism.
Only tertiary go with which one? SN1 mechanism.
SN1 mechanism.
Okay, let's come back to our question, sir. The phenol is there. Phenol and is more acidic than which one? Methanol. I think already our students given the answer. phenoxide.
Yes, exactly. So phenoxide ion stabilizes due to resonance.
Yes, phenoxide ion more stable than which one? Methoxide ion.
Methoxide ion are not stabilized due to resonance.
Resonance.
Or they are unstable.
Yeah, more stable means what? Yes, they are more ready to donate the H plus ion. It gets stability. I think that's with the structure you need to explain. Okay, not in words. Words with the more details in structure.
Yeah, you can write this one O minus if you are writing, that would be better.
Yes.
The
COH bond angle in alcohol.
is,
Let me
you know
take a
that one
simple
alcohol,
example.
CH3, yes,
OH, you know that oxygen
Lone
contain
pair
what?
of
Lone
yeah.
pair is
So that
slightly
is
less than
sp3 hybridized carbon is
Carbon.
there, so tetrahedral bond angle we are expecting
Yeah.
109, but it is slightly less
than this 109 degree. That you know that
one,
the lone pair repulsion is what? It's more, so bonds come close, so the bond
answer
angle
should be,
reduces.
yeah, it is due to the repulsion between the lone
Lone
pairs
pair
of
and
electron on oxygen atom of alcohol.
Alcohol.
Okay, fine.
Next one, I think, how do you convert the following? So dear all,
Yes,
please take your paper, do
Another
fast.
very repeated conversion, phenol to anisole.
Phenol to anisole. So let us see,
Phenol
sir,
will
what is the
react
first step they are going to do?
Yeah, I think lone. Yeah, that.
What is the
okay,
first
here,
step?
Give the step.
What
we have
is
to
the first step for this conversion? Phenol to anisole. You know, anisole is benzene with OCH3.
Yes.
So phenol, yes, good. First
do?
treated with the
Phenol
what?
is aqueous NaOH.
Aqueous NaOH. We get what? Sodium phenoxide.
Aqueous
Then
NaOH. Well done, well done.
second step, what they are
Yeah,
using?
sodium
Second
phenoxide.
step,
After that, Williamson synthesis you have to carry out.
Yes.
You know that one.
we can use CH3Cl or
It's a
CH3I.
Williamson synthesis.
We'll get OCH3. That is our
Phenol
anisole.
to anisole, sodium phenoxide and Williamson synthesis.
Yes.
That you will be getting.
Next
Second
one, I think, sir, propan 2-ol we need to convert into 2-methyl propan 2-ol.
Yeah.
That be
There-
careful, right?
yeah. Here-
So one carbon we need to increase extra. So
Yeah.
this place one carbon we need to get extra.
extra carbon.
But we have to do one step before that one.
Yeah.
So what is that first
secondary
step?
alcohol should be converted to ketone. But yeah, one point you have to keep in mind. This is a tertiary alcohol. That you have to weigh. That way you can make the logic.
Yes.
A tertiary alcohol. Yeah. This one you can. I think catalytic dehydrogenation is easy, right?
Yes.
Yeah.
Okay. So we can
That
use
will be-
either Grignard reagent or not. So we can use the Mg plus CH3 minus and you'll get the steps and all. So you'll CH3. Finally, after hydrolysis become OH.
Yes.
CH3.
One thing you
CH3.
keep in mind, secondary alcohol never turns to tertiary directly. That
Yeah.
you keep in mind. Secondary alcohol never turns to tertiary directly. If you want to prepare a tertiary alcohol, you have to add a Grignard reagent. But Grignard reagent can be added to either aldehyde or ketone.
Yes.
So wherever tertiary alcohol you need to prepare, tertiary alcohol can be prepared from a ketone. Okay, always you keep in mind ketone with a Grignard reagent.
Yeah.
So here we have a tertiary alcohol. That tertiary alcohol has how many carbon? We know that one. And here we know that one 3 carbon. So that Grignard reagent will be adding and will be converting. 1 carbon should be extra.
All
That
right.
only you have to keep in mind. Yes.
Yes.
Sir.
So aniline we have to convert into phenol. Mean first I think we can treat it with what?
Diazotization.
Yes.
Aniline starting will be almost diazotization.
Diazotization.
Aniline conversion will be almost all case it will be diazotization.
What is the reagent we are using? Yes, Karthik already given the answer. What? Warm
correct,
water.
correct, yeah.
Right, warm water. If you use OH group come to benzene, you will get what? Phenol as a
yeah.
product. So I think benzene, diazonium chloride, lot of reactions are there in
Reactions are
amine
there,
chapter,
yeah, amine
including coupling reaction and all. Yes, we'll discuss in amine chapter.
Benzene, diazonium chloride, warm
Yeah.
water we will be getting. Yeah,
Okay.
the very last question from the alcohol chapter, dear students.
Come on all.
We reached 70 questions. 70
Now
questions.
only 30 questions remaining.
Yeah,
Still.
one short revision. 70 question we reached.
Yes. So benzyl alcohol you have to convert into benzoic acid. It's
So, I
a
think
primary
so,
alcohol.
We can use directly.
Yes, we
Of
can
this
use.
logic you have to keep in mind. Every primary alcohol with a strong oxidizing agent directly converted to carboxylic acid.
Carboxylic acid, right?
So KMNO4/H plus you will be getting.
Yes,
carboxylic
KMNO4.
acid directly.
Acid, as alkaline or acidified, which one?
Yeah.
Best acidified, KMNO4 convert primary alcohol to acid.
one.
Dehydration of.
propan to all.
Yes. Propan to all on dehydration to propene. What is the
So,
reagent?
It's a very easy one. You know that one. Whenever a secondary alcohol converted to alkene, you know that one.
We studied the percentage and all, right? 85, how much?
85% phosphoric acid.
Phosphoric acid, H3PO4 can be used.
And heat you can
Heat.
use. Yes.
440 Kelvin we are using.
Temperature, yes.
And hope you remember for tertiary alcohol, what is the condition?
85% H3PO4. yes.
Tertiary
That will
alcohol,
be 20%.
20% H3PO4
Yeah,
and
so
358 Kelvin.
Kelvin.
Right.
Tertiary alcohol, if it comes 20% only, you need to write. Yes.
Okay.
Next is
So butane 2-on. Yes, butane 2-on to butane 2-ol. Yes, dear all. What is the reagent? We can use it.
Yes.
Come on, butane 2-on to butane 2-ol. Come on, dear all. What is the reagent? We can use it here.
A ketone to corresponding secondary alcohol. means
Reduction,
one process.
reduction,
Yeah, reduction. If you
reduction. Yes, Ash. Yes, yeah.
Yeah,
We can.
Yes, yeah, that also, that what I
Yes.
was about to tell. Here, if you are writing alcoholic H and heat, it's not wrong. That because beta elimination also will give the same product. Okay? Yes.
No,
That's
the
also correct.
so which is the best reagent? We discussed now. Which is the best reagent to convert a ketone to secondary alcohol?
is
Yes, NaBH4,
Beta
sodium.
aluminum hydride also, they won't cut
Yeah.
the mark, it's same. But
Reduction.
best for ketone is NaBH.
NaBH4 to make into
Yes.
secondary alcohol. Yes, there I think the 70 question from second organic
1
chapter.
to 70 we reach.
Yes.
Okay. Yeah.
Now 30 questions are remaining, but
Only-
the
yeah,
next
last-
chapter, you know, the importance is the most lengthy
Highest
chapter.
weightage
8
from
mark.
these- among the 10 chapter, highest weightage is for aldehydes. and
Aldehydes,
ketones.
ketones, and carboxylic acid. Highest weightage,
Okay.
dear all.
Yes.
You know which all are the named reaction from the aldehyde chapter. Lots of reactions are there. Let's see the fire, sir, once again.
Yes,
So, dear all,
again.
are you there? Are you there? Are you waiting, or are you waiting for lot of question what we can expect for the board examination? Are you there, right? So you are there with energetically, we think so. We can't able to see, dear all.
All the point we will be discussing. Don't worry. All the points we will be discussing. Yes.
Yes,
Yes, we will be discussing all the points. Don't
Sai
worry.
Sudhi, no problem. Just text me a message after the class. I will definitely will clear it.
Yeah,
Okay.
we will discuss
Don't
all
worry
the
for that
points.
one.
Yes.
Waiting, right? Waiting. Yes, all of you. Yes, fine. So, please, dear all, in between, try to take some water and all.
Yeah.
So, health also, we have to be very careful. Last moment should not be tired. Okay. Right. So, sir, we can go for the most
Always,
important
yeah.
chapter.
Important name. See, most of the name reaction comes from this chapter. Many name reactions are there.
Yes.
And almost all name reactions are very important.
Yes.
So let us go through the name reaction. Which all name
Okay.
reactions are there?
Yes, Rosenmund reductions are there. Acid chloride to aldehyde. Stephen reaction is there. Our cyanide into aldehyde. Itard reaction is there. Toluene to benzaldehyde. Getterman-Koch reaction. Benzene to benzaldehyde. Aldol and cross-aldol condensation with alpha hydrogen and alkali. And Cannizzaro reaction without alpha hydrogen and what? Concentrated alkali. Wolff-Kishner and Clemenson reduction what? Aldehyde ketone to hydrocarbon. And HVZ reaction, our acid reaction.
Yes, and distinguished test, all you have to keep in mind. The 2,4 DNP test, you have to keep in mind. Tollens test, you know that one. Aldehydes and ketone can be distinguished. Felling test, aliphatic can be distinguished from aromatic aldehyde.
Yes.
Iodoform test, that CH3CO, okay, containing ketone can be distinguished from the other one.
Right.
NHCO3 for carboxylic acid.
Yes. So these are the main
That all you
important.
have to keep in mind.
Yes. So here we just showcase what all, you know that it's not possible to explain everything. So these are the important name reaction. These are the distinguishing tests. In between, lot of reactions are there. Nucleophilic substitution, addition,
Conversion,
kind of
so many
reactions.
things are there, you keep in mind.
I
Yes,
think let
yeah,
us start,
we
sir.
Yes.
Write the products formed when CH3 thrice, CH3 thrice, right? CH3
Yes,
thrice, CHO. What they're reacting
When
first with,
reacts
sir?
with- Yeah.
CH3CO, okay, they are reacting with another ketone. So
Another ketone.
CH3CO, CH3, they are treating with the ketone in the presence of
dilute NaOH.
dilute NaOH, dear all.
See, tell what is the name reaction whenever dilute NaOH is
Come on, dear all. Which reaction we can use this reaction? Dilute alkali if they use. Which reaction?
Yes, dilute alkali means what is the reaction?
Cross aldol condensation. Very good, dear all.
Yeah, very good, very good.
Dilute NaOH mean aldol condensation, but the two species are different. So we are using which one? Cross aldol condensation.
Yes, aldol condensation. Well done, well done.
So let me write the product, all of you. You know the alpha hydrogen go to this one. You will get CH3, 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 and this become what? CHOH.
Yeah.
It's connected here to what? CH2,
C
CO,
double bond O, single bond
CH3.
Yeah.
I think
So,
they only.
that cross
That's
aldol, no need to write all this A and B and all. This one step reaction is enough.
enough.
Okay.
If they given
Because it's-
heat, also need to go
Yeah.
for the second condensation
Yes,
step.
condensation. And it's 1 mark, that is more than enough.
Yes. Next.
HCN addition against an aldehyde.
Yes. HCN addition. We know it is a.
How many nucleophilic addition reactions are there?
Nucleophilic.
HCN, NHSO3, alcohol addition. That all you have to keep in mind.
Yes.
HCN addition. will
CN,
take place.
no, nucleophile will attack, O become O minus, to which H will attack. You will get CH3, C, CH3,
Down
CH3.
it is CH3, yes,
Here, CH,
N,
to which
OH,
what? OH,
and
and it
CN.
become what? CN. It become
Yeah,
what? Cyanohydrin. Aldehyde or ketone when react with a hydrogen cyanide, what we get?
Yeah, they give
Cyanohydrin.
well done,
Yes, right.
cyanohydrin.
Good. And one more is their concentrated NaOH. They are asking many reactions in one single frame.
Yeah.
So CH3,
And
CCH3.
you can type the name reaction, what they're asking for concentrated NaOH.
I think definitely they will give the answer, sir.
They are giving, yes, Sabhi, well done.
Concentrated NaOH means which
Yes,
reaction?
aldol and
Cannizzaro. Who said
Yes,
Canni?
very good.
Okay.
Cross aldol and aldol means same molecule participate in aldol. If
Right.
two different type of molecule participate, that's called cross aldol. Yes.
So we know during Cannizzaro reaction what happened, one compound become its corresponding alcohol.
Yeah.
So we can write
CH3 over here,
terbutyl
there
with
will be
CH2OH
and
plus
sodium salt of a carboxylic
carboxylic
acid.
acid
This
will get
becomes
COONA.
Yeah. that
So
is-
be
yeah.
careful with
Sure.
the base, all of you, whether NaOH or KOH, be careful.
Yeah, based
So
on that one,
like
you can
that.
write the salt, sodium or potassium salt will come.
Yes. So
right
hope
to
you
hope
clear.
understood?
Right. So dear all, are you clear? Hope you already studied aldol condensation, cross aldol condensation products and all. Yes or no? Ready all? Ready.
Yeah.
It's aldol condensation.
Cannizzaro reaction or yes,
Yes, Cannizzaro.
Yes, well done.
All right. Let's go for the
Let's
next
go
one.
for the next one.
An organic compound. These type of paragraph question
Yeah.
identifying.
One question you can read the question very carefully.
Yes.
Okay. Yes. Then
Okay.
Try to give the answer.
Right.
Try to give the answer. Read the question very carefully.
An organic compound A having the formula C4H8O, red, it gives orange red precipitate with the 2,4-DNP. So it means it can be an aldehyde or what? It can be a ketone. It does not reduce tolerance reagent. So we confirm it is what? A ketone. So no, does not reage tolerance reagent means a ketone, but gives yellow precipitate with iodoform.
Yeah.
So that contain which group?
So in that statement, every hints are given.
Yes.
That hints you have to read very carefully because here 2,4-DNP reagent means they
I
gave the
think-
hint. Yeah.
So I think from
Yellow
this
precipitate.
itself answer I think is
You will
ready.
be getting,
For-
but you have to read. But sir, what they will do now, when they are getting these type of questions, they will think that it's very tough.
Tough.
That then
See-
they will approach the question with a negative mind.
For making
That you have to
simplicity.
change these type of question while reading itself, all the hints are giving. That
See-
you read carefully and try to answer the question.
For making the calculation easier, they are giving lot of ideas. So total 4 carbon and it contains CH3CO group and it's a ketone. What is the compound? That should be what? Butan 2-on, my dear students. So CH3CO, CH2, CH3 is the compound butan 2-on. Compound A on reduction with NaBH4. Okay, what happened? Butan 2-on on reduction, we will get butan 2-ol. We will get a alcohol, that is secondary alcohol.
Every ketone on reduction will give corresponding secondary alcohol. So
Yes.
we got B, sir, no?
So this
Yeah,
is our
this is
A,
compound
yeah,
B,
this is our
we
compound
got
B. There's B on what?
Compound on with
Concentrated acid, I think dehydration, right?
Yeah.
Okay, dehydration means what? Water, let us eliminate.
Elimination to form
You
double
will get
bond CH,
bu-
single bond CH3,
Yes,
butadiene
butadiene. This is C.
on ozonolysis, sir. So
Ozonolysis.
means, yeah, O3,
O3
slash H2O.
Zn bar H2O, you know this will
You will
break,
getting
you will get 2 molecules of
molecule
what?
of aldehyde.
CH3CHO. Here also one oxygen, here also one oxygen, CH3CHO.
CH3CHO.
That is ethanol.
Ethanol you will be getting. So
That
just
is
you
a-
have to write D as ethanol, then you will get the mark.
Yes.
Okay. So they are asking write their structures,
Right.
write the reaction. All the reaction we wrote. Okay. A, B, C, D. You have to identify.
And one more thing, sir, write the reaction of compound A with the NaOH and I2.
I2.
NaBH4 already we
Already
did.
we did.
NaOH and I2 means our
Iodoform
iodoform test. So
Yeah.
our compound is CH3CO,
double
CH2.
bond, single bond CH2.
We know iodoform test is NaOH and iodine and heat. What happened? The one carbon, the CO,
That will be
CH3
C, yeah.
become CHI3
CHI3 iodine
plus
form will be forming,
and
plus the remaining part will be CH3, CH2, CONA. If
right,
you want, you
sodium
can write,
iodide forms, water forms,
Yeah.
plus the byproduct is what? CH3 CH2 COONA.
will be forming.
Yes, CH3 CH2 COONA forms. And
This one, yeah. Give
reasoning
reason
also.
Question. Yeah, give reason questions are there.
Yeah.
Now listen.
Oxidation of propanol. You know what is dear all propanol? CH3, CH2, CHO. Oxidation of propanol is easier than propanon. We know the same question we can expect as
Can
aldehyde
be easily
oxidized than ketone. Reason is what?
Replaceable
Hydrogen.
In aldehyde, there is a replaceable hydrogen. That replaceable hydrogen, you can say that this is the function.
This is the one undergo oxidation.
Carbon is there. So, but here, you know that one.
In ketone, you know, this hydrogen won't be there. That's both side will be alkyl group. So there is a replaceable oxidizable hydrogen in aldehyde. So aldehyde undergo what? Oxidation faster than ketone. And there is one more question. Alpha hydrogen of aldehyde. You know, aldehyde is what? RCHO.
This one.
And okay, let's take an example. CH3. Then one ketone is CH3COCH3. Question. The alpha hydrogen of aldehyde. Which is the alpha hydrogen of aldehyde? These are the alpha hydrogen of aldehyde. These are the alpha hydrogen of ketone. Question. Why alpha hydrogen of aldehyde and ketone are more acidic in nature? So the main thing is what? The presence
Based on
of...
the bond you can sell, yes, the C double bond or single bond H is highly polar.
Yes.
You know that one.
We know they are what? Electron withdrawing groups. Aldehydes and ketones are what? Electron withdrawing groups. So what happened? It make the bond between carbon and hydrogen and all weaker.
Yes, weaker bond will be there.
We can easily remove it. So these questions are, yes, already given the right. Electron withdrawing groups are there of the carbonyl group. Good. Next question, write the structure of the following compound A and B.
73 question number, listen, next is, this one, you know that one, side chain oxidation, very repeated one. I think they will give the answer.
Yes.
We want the B. Type the name.
Yeah, I think those who are getting hungry and all, they will say the answer very fast now. What is that related to that, right? So what is that?
Give the name of the compound. What is? Yes, they gave sir. Subject,
Yes.
Well done. Yes, Smriti Ganesh. Well done. Correct,
Alkyl benzene when treated with alkaline KMNO4, first it become the salt that cook.
Potassium benzoate
Right.
will be getting.
On
After that,
acid hydrolysis, we get what? Benzoic acid. Then
Yeah, another one. This is another important one. CrO3 benzoic acid from cook. Yes, correct.
what is that?
Yeah.
What is here, dear all? This question,
yeah,
this is a
phenol,
secondary alcohol. Secondary
Any
alcohol.
secondary alcohol when undergo
Oxidation,
with the CrO3.
We get
corresponding
ketone, cyclohexanone. But this compound, you know very carefully,
Here should not make mistake.
when semi-carbazide, if it come, which NH2 group undergo that reaction?
Even that there is a reasoning question for the same.
Yes.
Why NH2 group nearby the CO
Group
will
not take part
participate
in-
chemical reaction.
Yes.
Only the NH2 away from the CO will participate.
This H2, the CO group where it is, the away NH2 always takes part. This O and H2 will go out. You will get the product as what?
Yes,
Cyclohexane with
correct. Yes.
double
So,
bond,
double bond N
NH,
CO
NH2, semi-carbazone.
Semi-carbazone will be
Right.
forming.
Yes. So if you know the product name like a semi-carbazone and here benzoic acid, please write below that one. Okay. So don't forget to write AB. Yes, 2 marks
Yes,
easy.
Question number 74.
Complete the
Valence
following
again.
reaction.
Yeah, complete the following reaction. And here you should take care while doing the question because you will be thinking that what is that NaC and HCl we did not learn.
Yes.
But NaCl and HCl.
When
you know that-
react,
Yeah, there are some reagents which are prepared as in situ. In situ means on the spot. Here we are going to prepare an on the spot a reagent called HCl.
HCN, H and CN combine HCN,
So
it
HCl
undergo.
will be forming. That HCN addition with an aldehyde, you know that one. Cyanohydrin will be forming.
Yes,
sir, we
it
can
will
write the
form
formula.
benzene with what? CH, OH and CN. We'll get cyanohydrin.
Yeah.
And
So
this is
cyanohydrin formation. This is here.
this is another reaction we studied when acid chloride treated with the dialkyl cadmium, we get ketone.
Yeah, here also if you want to add the more carbon in this one, that also you can use this equation. It's important. Number
Yes.
of carbon can be increased.
So this CD and Cl go as what? CdCl2,
Cl2,
cadmium
you will be
dichloride.
getting
Then you will get
C6H5
C6H5,
to
CH2.
again
This will
CH3,
combine with the what? The
CH3.
CO CH3.
Yeah, COCH3.
Right, we'll get a ketone.
Yeah.
So when acid chloride react with a dialkyl cadmium, we get a ketone.
That
Just
is
join the
the
alkyl groups.
preparation of ketone, it is dialkyl ketone, acid ketone.
And this is a very important name
This
reaction.
is
There
what
are
we told, all name reaction.
What is that?
Directly or indirectly. You can type the name of the reaction, dear students, right now.
yes, there is a 3-letter reaction in carboxylic acid part. What is that?
Yes, Sabhi,
Volhard Zelinsky reaction.
Not HVD, HV said anyway, Smriti, we understood what
Right.
you meant.
Yes.
Okay, yeah, correct.
So
Yes.
here what we have to do, don't forget all of you, only the alpha hydrogen we have to remove from the carboxylic acid.
Volhard, Zelinsky.
Yes, this is the alpha carbon from which you remove the alpha hydrogen and place the
one we
bromine.
will Place over there.
Yes, and also I think we can expect the questions regarding this HVZ reaction like this. By giving 4 carboxylic acid,
Which
they
one
ask
will
you
undergo?
which will give HVZ reaction. Check whether there is a alpha hydrogen or not. Okay, so methanoic acid can't give, benzoic acid can't give. So
That
only
one
alpha
will not-
hydrogen
yeah,
should be
alpha
there.
hydrogen containing compounds only will give.
Yes. Next,
is
write chemical equation.
for the
Following. First, what they are using?
Propanol treated with dilute barihydroxide.
So
See,
propanol reacting with one more propanol.
Propanol.
With which one? Dilute barium hydroxide means what? That's
dilute
our
and alkali.
that's
dilute
our
alkali.
aldol condensation. Let's perform, right?
Barium or NaOH, which means you keep in mind it's a dilute alkali.
Yes. So you will
be
get
getting CH3
3COH and
Here will be
CH2 COCH3.
Yeah.
So this on they are heating? No.
No heating. that
No
is not
heating.
us, So only till this one you need to
Only
write.
do the aldol condensation
That is
step.
enough.
And acetophenone.
Acetophenone treated with the
Right.
zinc amalgam and see tell the name.
Again.
Reaction zinc amalgam and concentrated HCl. So we give you chance to tell the name of the reaction. I think people are typing. Yes.
Acetophenone reacting with the zinc amalgam and
Zinc
concentrated
amalgam and
HCl mean
concentrated HCl, yes, Ashmita,
that is our
well done. Smriti,
Clemenson.
Yes, Rohan, Hanna. Yes, Ola there, well done.
That is our Clemenson reduction. Good, all of you.
Yes, Ashmita.
So
yes.
what happened in Clemenson reduction? The CO group becomes CH2
Every
hydrocarbon.
aldehyde and ketone converted to alkene. You keep in mind, or hydrocarbon. That is called Clemenson reduction.
Right.
And Wolff-Kishner reduction is same.
Yes.
Only reagent is different.
All right. So these questions
we will
are, I
go to
think,
the next one.
almost okay for you. Next one. Give reason.
I think one more is
Yes,
there.
one more is missing.
I think benzyl chloride is.
Yes, benzoyl chloride. What is benzoyl chloride?
Here also we can ask them what is the name reaction
Ah.
asking over here.
Benzoyl chloride to
Right,
what?
treated with-
Treated. Okay, I'm not writing the product. Benzoyl chloride reacting with what?
Treated with
Hydrogenated.
PDD/BSO4.
palladium and
That's
barium
the name reaction.
sulfate.
They are giving the name well done.
What is that?
Rohan. Yeah.
That is the first name reaction in our chapter.
Yeah.
Rosenmund reduction. Yes, benzoyl chloride become what?
Yes.
Benzaldehyde.
Rosenmund reduction. Yeah,
Yes.
that also. Rosenmund reduction. Another
That's a reaction.
conversion and name reaction. Definitely they will ask.
Correct.
Yes, sir, we can move to
Next
the
one, give
75.
reason. Question number 1, benzoic acid. No need to wait. Draw the structure fast and show it.
Yeah.
Benzoic
So,
acid.
Benzoic acid is a
Strong acid than acetic acid.
Yeah.
What we can say, acid mean they will remove H plus, it form anion. It remove H
So
plus
here it is
anion.
anion.
This is which ion? Benzoate anion.
anion
This is
and
what? Acetate anion. Which is more stable? The same like our phenoxide question.
Phenoxide one. You
Yes.
can keep in mind. Yeah, benzoic acid is stronger acid.
Right.
Than acetic acid.
You know, benzoate ion is more stable due to their more resonating structure. Here it is very less. So what happened? It will donate the H plus ion faster. We can explain
Yeah.
more like that.
Another question is there carboxylate and alcohol when they are asking that you have to keep in mind that this one phenoxide and carboxylate. That carboxylate will come more that you keep in mind.
Yes, carboxylate
Here both are
always greater.
carboxylate.
Yeah.
That you keep in mind.
And methanol. Methanol is what? HCHO. Methanol. I think this nucleophilic addition reaction, one of the expected question from this chapter all. Methanol is more reactive toward nucleophilic addition reaction than
Two
what?
criteria are there for nucleophilic addition.
Yes.
First one is plus I effect and next one is steric
Steric
effect.
factor.
So which steric factor when increases, reactivity decreases, it's inversely proportional. You have to keep in mind.
Yes.
Okay. Plus I, that you have to keep in mind. So here has less steric effect.
Yeah, I think they already given the answer. Can you say, dear all, ethanol and methanol when you consider, methanol
is
undergo
more
reaction faster because there's less steric hindrance
steric hindrance.
and there is no what? plus I effect and all. Here what plus I effect is there, so it reduces the positive charge, and bulky group is there, attack is harder, so methanol will undergo reaction faster. So I think
So two criteria you keep in mind: plus I effect and steric effect.
Steric factor.
Plus I effect will decrease
Good,
the
right.
polarity of the carbonyl functional group, and steric effect will hinder the approach of the nucleophile.
I think, sir, most of you are waiting to say that term in the chat box. Give a simple test to distinguish between propanol and propanone. I think you are
ketone.
means this
That
term
is
is already fixed in your mind. What is the test?
Between aldehyde and ketone, what is the test used?
What is the test? Okay,
Already
Ashmita is giving the
yes.
first answer.
Yes,
Ashmita, Ash, Hisham, G,
Yes,
okay,
all are there.
tolerance, right?
Yes.
Tolerance, Rida, yes.
Yes.
Ash, Sanjay,
Tolerance test,
Venkita.
yeah.
Tolerance test, right? Tolerance test is a test is given by what? All types of what? Aldehydes.
Muhammad Ibrahim, yes.
And
all are
don't
there.
forget
Yeah.
to write the reaction and
Between
the
aldehyde and
observation.
ketone. Yeah, whenever you write the distinguished test, name of the test below, you should write the equation
Reaction.
for the positive.
All
Negative,
right.
you should write no reaction.
You know, propanol react with the tolerance reagent will get the silver, right? The silver deposit also called silver mirror test.
Yes,
I think that question over.
Next is
Predict the
76.
main product of the following reaction. What is this again?
Yeah.
This is again what our tolerance reagent.
Yeah, reagent tolerance test. The
Ah.
reagent is AgNH3 twice plus ammoniacal silver nitrate
Yes,
solution.
that will attack only on aldehyde, you know.
Yes.
So the cyclohexanone part, you just keep it there. Ketone,
Yes,
please
correct,
don't touch
correct.
it.
Tolerance
So
test is always otherwise called silver mirror test.
yes,
Same. Yeah.
so the byproducts,
So
you
we'll
know
be
that
getting-
silver deposit, ammonia, and which
ammonia
one?
plus
Water
will be
formed.
The
And
silver will deposit on the walls. That is silver mirror test.
yes,
Okay.
next one
So
is
this one otherwise called silver mirror test.
yeah, and the NaBH4, you know, NaBH4 function is what? To convert ketone. This is again we discussed. This is ketone and this is an ester. The same question we discussed in alcohol chapter also. The ketone becomes what? Secondary alcohol. So you will get the compound CH3, CHOH, then CH2, COOCH3. Note over, in second step they are treating with an acid. So when this ester, dear all, this is an ester react with acid, what happen? It breaks to what? Acid and alcohol. So you just cut this area, you will get the acid part left side, that is CH3, CHOH, then CH2, COOH is the acid, and right side is alcohol, CH3OH, you know, this is called saponification. Ester when react with the acid, what do you get? Acid and alcohol called what? Saponification. And what about this reaction? I think again the aldol, cross aldol, and asking through the
Yeah.
reaction. So let us take a alpha hydrogen and give to this hydrogen. I think the aldol, cross aldol products and all, I think almost
Only,
okay.
yeah, you have to write the product. Only
Yes.
that one step product
CH on which OH will
be,
come,
and here it will be
CH2 and CHO will come.
Yeah, after that the no heat, then you have to write this one.
No need to do condensation. You can stop with the aldol.
Yeah. So
And-
here a simple chemical test to distinguish between. I think this will be very easy.
Here
for
also you are
Wherever
waiting.
COCH3 comes.
Whenever there is a CH3 CO C group, you can, you know,
know
what is
that
the name
one?
all of you know? This is acetophenone. This is
And
what?
benzophenone.
Benzophenone.
Yeah.
Acetophenone will give you what?
Yes, they
Which
give
one? Which
already-
one?
Yeah, what test? Yes, iodoform.
Iodoform test, right?
Well
Yes,
done.
it will give
Iodoform test will
iodoform.
be used.
And don't forget to write the
So,
reaction again.
Yes, I see every
Ah.
distinguished test you have
Yes.
to write the iodoform test.
Test
So,
it.
yeah.
And so the yellow colored precipitate is
Yes.
forming. Why is alpha hydrogen of carbonyl compound acidic in nature? That we discussed.
Yes, already we discussed the
But
same
the
one.
pattern you see,
Pattern, yeah.
previous we discussed the propanol and propanone they asked.
But
Here they
generally
carbonyl.
asking carbonyl.
So what we
That's it.
said, carbonyl groups are electron withdrawing group. It make the CH bond weaker, so it become acidic in nature.
That you keep in mind.
Right.
Okay, 77.
Account for the following first one.
Aromatic carboxylic acid.
Aromatic.
See here, yeah.
Yes, aromatic carboxylic acid like benzoic acid do not undergo what? Friedel-Crafts reaction.
Friedel-Crafts reaction means you know that one
Yes.
the compound catalyst used is anhydrous.
The same
AlCl3
question.
And yeah.
Yeah, the same question they are studying in
I
which
think-
one? Amine chapter also the same question, the
And it
salt
does not
formation.
undergo
Friedel-Crafts reaction. So benzoic acid like aromatic carboxylic acids and aniline do not undergo what? The Friedel-Crafts reaction because it form what? Salt, a complex with the catalyst what? AlCl3 because AlCl3 act as what? It's electron deficient one. So because of the salt formation, benzoic acid do not give Friedel-Crafts reaction.
It will produce H plus.
Yes.
That is the reason. Yes.
Now pKa value, you know, higher the pKa, what about acidity? All of you say, higher the pKa. Higher the pKa mean what about the acidity? Lesser or higher?
Yeah, it's inversely proportional, you know that one.
Right.
Inversely proportional, whenever pK value increases, Ka value will be decreasing.
So
value of 4-nitrobenzoic acid is.
Yes, 4-nitrobenzoic acid is what? Less than
that of
benzoic acid. No
Yes,
doubt
you
here.
know that one. Benzoic acid is a more stronger acid.
Acid.
Sorry, this one is a more stronger.
Stronger
Yeah.
because electron withdrawing group
group
is there. Electron withdrawing group present. What happened?
Yeah, they are asking which one has more pK value.
Yes.
pK value is more for this one.
Yes.
Because this is more acidic.
More acidic means less pKa, less acidic mean more pKa, and you know the electron withdrawing group that just a
Always
highlight.
Electron withdrawing group increases acidity.
Acidity.
Decreases basicity.
Right.
That
So
you have to keep in mind.
clear the answer, dear students? All right. Let's go for the
Electron
78th. Write the equations involved in the following reaction. Wolff-Kishner
This
reduction.
is what we told. Wolff-Kishner and Clemmensen reduction, same type.
Yeah.
You can expect.
So
Yes,
if they
it
ask
starts.
any name reaction mean either you can write the general equation or any example.
Yeah.
So you know
General is
Wolff-Kishner.
fine, C double bond O.
Just to mention which all are these aldehyde or
Aldehyde or
ketone
ketone
when
plus
react with hydrazine.
NH2,
We'll get-
ethylene glycol /
Yes,
KOH.
right. It will go double bond NH2. You will get hydrazone. And hydrazone on treated with what? Ethylene glycol.
Yeah.
Right. Ethylene glycol
Glycol.
and KOH. Then
You will be
heat.
getting-
The nitrogen gas
You will be
getting, and you will get what? Hydrocarbon.
Yeah.
Right. You will get.
You can go directly also, no issue. With this compound, if you are writing this one, NH2, ethylene glycol, if you are writing together,
1, 2,
write,
you can
yeah,
able to write it.
directly.
Yes.
So, this one Wolff-Kishner reduction.
And
then
I think
Itard's.
the Itard
Very
reaction.
important conversion
the
also
term-
they asked in so many question papers.
Come on, dear
Which
all.
one? Toluene will be starting.
Toluene.
And there is an intermediate.
Yes. Toluene reacting with what?
Yes.
Toluene reacting with what?
Yeah, what is the
Toluene.
reagent, can you tell?
Cr chromyl, yes,
CrO2,
CrO2Cl2,
slash
it form a
carbon disulfide.
complex,
Yeah.
right? You will get what? The CS2 is there,
Carbon
you will get
disulfide,
CH,
then you will be getting
OCrOHCl2, or you can write twice. The intermediate, that's on
Then you will be
acid
getting on
hydrolysis,
acidification, you will be
you will get the benzaldehyde. This is the Itard.
Okay,
So
yeah.
whenever you writing a name reaction, please write the reaction and give a description about that one.
Exactly,
What's
yeah.
happening
But-
there?
But important is name reaction means define, whether they are asking define, that equation is important.
Yes.
Equation is perfect means you will get 1 mark.
Correct.
You have written all the explanation in words, but no reaction means you will get 0 mark.
Right,
That
that's
you
it.
have to keep in mind.
All right.
So Itard's reaction is very important. So we have 2 more questions from this chapter. Students.
Conversion.
So, yeah, conversion.
I think-
benzoic acid to benzaldehyde.
Benzoic acid to benzaldehyde. Let
Yeah.
them give the steps, sir.
Yeah, I think here also you can apply
First,
name reaction.
First we
Yeah.
can apply a conversion like what
Here
we
it
can
is
treat it with
PCl5.
what? PCl5 or
Then you will get
SOCl2 and all.
benzoyl chloride.
Yes,
Benzyl chloride to
COCl.
benzaldehyde we have.
That we
Yes.
know. Hydrogen,
Yeah,
palladium.
Atul, for previous reaction, intermediate is important. If you are not able to remember, then skip that one, write all the things together and write.
Right.
Okay, but mark is going close to 70 means they may cut, doesn't matter. Means if you want 70 mark, you should remember intermediate.
Yes.
Otherwise, you are not able to remember the intermediate means you can write the reactant together and write.
Okay, I think we do the acid to acid chloride first. Then
Yes,
what?
that is
Rosenmund reduction.
After that, ethyl benzene, sir, to
Yes.
benzoic acid.
Already
Here
we
also with
discussed.
the direct one, irrespective of the number of carbon atom on benzene ring, it will convert it to benzoic acid. That is called side chain oxidation.
Yes.
Side chain oxidation means KMnO4/KOH. We will be getting that potassium benzoate,
Right.
then benzoic acid.
Yes. And the propanone to propene, I think we discussed before.
Yes.
Propanone,
Already
first
we did
we have
this
to
one. Yes.
reduce by NaBH4.
Then
The
we will be
ketone
getting
becomes
secondary
what?
alcohol, corresponds
Secondary
to
alcohol.
Then
Secondary
we will be
alcohol on
getting
dehydration by using
concentrated SO4
yes, or 85% H3PO4 phosphoric acid and heat for 40 Kelvin.
Yes,
You will
be
get
getting-
propene. Right.
That
This
is
also possible.
Yeah.
So I hope you this reactions all are clear. So this reaction we see in one another format, identifying A, B or conversion. Same.
Yes, correct. Ashmita, correct one.
Correct here all? Yes.
Dehydration, if you are using H2SO4 and heat, you will get the mark.
Now
issue.
sir, we are
Same.
going to complete 5 hour.
Yeah,
5
80
hour.
questions are
80 questions.
80 questions. Okay?
Yes, one of the expected type of question here all. They will just
See.
change the compound. That's it.
The last question from the aldehyde chapter, arrange the following compounds in the increasing order of their property indicated. See,
Yes. First one is.
reactivity towards nucleophilic addition.
Yes, there is a given.
Here, the very simple thing you have to keep in mind, bulkier alkyl group means less reactive.
Yes.
That is the easy thing. Okay. Bulky alkyl group is there means it will be less reactive, inversely proportional.
Yes.
So which one has the smaller alkyl group? CH3CHO. Next is CH3CO, CH3. Least one will be C6H5 because phenyl group is bulkier than any other alkyl group.
Right.
That you keep in mind.
So here only we have methyl group, here methyl and phenyl group, here both are methyl group.
Yes.
Here is the only one bulky group is there. So reactivity toward increasing or decreasing, careful all of you.
Yeah.
Increasing
So,
mean
increasing order,
C is the
most
most,
will be C, then
then
will be
B,
A,
then A,
then
least
will
one
be
is C.
C.
Sorry, the B.
B will come.
C is the most one. C is the most one.
After
Then we
that,
can
A
say
will
the
come,
A
will come.
and
After
B,
that,
one
B.
with the
So,
phenyl group.
BAC. I think they give.
Right.
Yeah,
Given the
well
answer
done.
or not?
Yes.
Yes. Okay.
However, still, yes, yeah.
Next
That
one.
is, yes, energy level you have to maintain.
Ah.
Even we are trying our level best
Yes.
to maintain the same energy level. You guys should be there with us till the end. Okay?
Think about that one. We are not the one going to write the examination. You are the responsible for that one. So you should be active more than us. So we have the another equation. Write
Yes.
them in the increasing order of
Yeah,
acidity.
this one also you have to keep in mind.
A,
Here,
B, C.
Fluorine, fluorine, and the without this one they are giving.
Yes.
Keep in mind, among halogen, fluorine is the most electron
Right.
negative.
Electron
Most
withdrawing
electron
group is
negative.
there. Acidity increases.
Yeah.
So among A, B, C, I think fluorine is there,
the
chlorine
most.
is there. We know
Yes,
fluorine is the most electron withdrawing group. So B is the most one. Then A and here only alkyl group, donating group means they will decrease acidity.
Yes.
So C is the one. So C, A, B is the correct answer.
yeah, sir.
Increasing. Yeah.
So here we can add a higher order question, sir. In
Yeah.
some of the question paper they ask
Yes.
with the CF3
Yes.
and fluorine and NO2.
Yes.
Okay, so if they are asking with the CF3, NO2 and fluorine and all, you have to keep in mind CF3 is the most, then next will coming as NO2, then will be fluorine, then will be chlorine.
This is
Okay?
the
Many
more-
question paper this one they ask. Yeah, CF3.
CF3
Means if this carboxylic
with
acid,
3 fluorine.
If they are giving CF3, that you have to keep in mind, then NO2F.
That's with the most
It can
electron
be a
withdrawing
higher
group.
order question based
Yeah.
on this one. Yes.
All right.
Shall we move to the next one?
Yes, next one is give simple
Yes.
chemical test to distinguish between the following pair of compound.
Yeah, my,
Benzoic
it's
acid.
continuously we are talking, so sound will be less.
Yeah. Benzoic acid and phenol. We will increase the sound, no problem. Benzoic acid and phenol. What is the distinguishing test? Either we can use neutral ferric chloride or we can use what? Sodium bicarbonate test. Yes, I think even the answer right.
Between,
Yes.
Yeah, between carboxylic acid and alcohol, you know that one. If any one of the compound is carboxylic acid, you use NaHCO3 test. That will be easy.
Yes.
And FeCl3.
So-
every NaCO3 you will be getting carbon dioxide and risk of percent.
Yes.
So only if you are writing NaCO3, they may cut you a mark. You should write the equation.
Write the reaction, form the sodium salt.
Distinguished test reaction is important or compulsory. We can tell.
Right. And we have a simple equation again we discussed. Propanol and propanone means what? We can use the tolerance test, even Felling's test, any one. So if there is one test, suppose maybe for two distinguishing, more than two conversion, it may be distinguishing test possible mean, no need to write everything, just write any one distinguishing test and write that reaction. Please don't waste your time by writing two or more
It's
reactions.
easy and you can easily present that one that you choose.
Yes.
Okay. And mark will be anyway same.
Right.
Yeah.
So,
Propanol and propanone. Anyway, we wrote the same. So tolerance test. Here also you should write the reaction. Fine. I think we
So I
finished
think,
all questions from
aldehydes,
ketone.
ketones and carboxylic acid, most of the important area we covered.
Now we have only 20 more questions.
Yes. What
Yes.
is one more
Yes.
chapter? One more organic chapter
One
is
more organic
waiting.
chapter.
Yes,
Yes,
you
sir.
can join
Yes, yes,
with the
yes.
last organic chapter that you know. Which one?
Amines.
Amines chapter. Yes. So let us start, right?
I will
Right.
start.
Yeah,
Okay.
yes.
Fine.
Continue, sir, continue.
So students
That
are
energy
actually,
level we have to
yes,
maintain.
we are
Yes,
going to
so
maintain the
I-
same energy level. I think students are here now.
Yes.
Okay, okay.
So I am handing my weapon. Okay, so our weapon is.
You are here, you
handovering.
be here.
Okay, yes, yes,
Yeah, yeah, okay,
start.
fine, okay.
Let's go.
Okay, let's see.
For a few minutes, sir. Don't worry.
yes.
Yes, here,
Yeah.
dear children, here the main important things are, you have to remember about the, we already noted that named reactions actually. Hoffman bromamide degradation reaction, then Gabriel thalamide synthesis, then coupling reaction, then we have to remember about the basicity of amines in aqueous solution as well as in gaseous state also you have to remember. Okay, na sir?
Yes, both
Yes,
the phase.
both the
you
phase.
have to
Both
remember.
the phase you have to
Increase the
remember, okay.
order and wait
Then
for that.
how to distinguish the primary, secondary, tertiary and aliphatic and aromatic. The tests are mainly Hinsberg reagent test, that means benzene, sulfonyl, chloride test. Then carbylamine test or isocyanate test as well as nitrous acid test. Along with that you have to remember one more point, that's actually I am writing here, that is coupling reaction.
Yeah.
Coupling reaction also you just remember, okay. I here already there, okay. Coupling reaction is there, so that's the idea you have to remember, okay. So then electrophilic substitution also there, that's it, okay. These are the ideas you have to remember from the chapter amines. If it's so, then we can move to the questions now.
Yes. We
Let's
can
go.
Start, sir.
Okay,
Yes.
let's go.
Yeah.
This
Yeah, among the organic, I think amines is the easiest chapter.
easiest one and
So,
easily
we
you
are
can get the
expecting-
mark.
Definitely.
From all the chapters, some questions are coming here also. I mean, connection questions will be
Yes,
there,
yeah,
okay.
clubbed question you
Clubbed
can
question
expect.
you can expect from amines, okay. So here, while you are looking here, CH3COOH is there.
Yeah, I think
CH3COOH is there.
yeah,
Okay.
meantime you can
While
write-
we are treating this one with what? NH3 and delta.
Any carboxylic
What will happen?
acid heat means
That will be
it will
happen.
happen
Instead of that OH, NH2 will come amide.
You will be getting
CH3CO, NH2 will form. Then again one we are treating with the
And this one you
NaOBr.
find, students, this is nothing but NaOBr means NaOH plus Br2.
NaOH plus Br2, that only NaOH plus Br2,
It's combinedly
that
giving
only NaOBr.
Yeah,
NaOBr. Yeah.
NaOBr.
Yeah, that's it. So while you are treating this, actually nothing, Hoffman bromamide degradation. What is Hoffman bromamide degradation? That time you have to remove that CO, then NH2 you have to directly connect it. That's it. CH3, NH2 will be coming. Okay. So methanamine will be the answer. I hope you already got the answer.
Then the parent compound will be getting, so that you have to.
Yes, yes, yeah, yeah.
Correct
I think someone is asking, Venkata Subbareddy Mutakala is asking, what about biomolecule? Biomolecule is there, okay. From
Last
here,
chapter, right?
last chapter is
Order only we
biomolecule,
are
okay.
teaching, order only we are
Yeah,
teaching.
that order last, it will be coming, okay, don't worry. So this is methanamine you are getting. What about the second one? Listen to me very carefully. C6H5NO2, that is nitrobenzene. That is nitrobenzene, okay, sir?
Yes.
Nitrobenzene.
Any
Once I am
nitro-
treating that one with Fe bar HCl. Fe bar HCl means that will produce hydrogen.
Yes. One more.
That will produce a
either
reduction.
Fe/HCl or Sn/HCl they are giving.
They'll give you.
You have to write
But
the
this is the easy method and cheapest method. That's why they are using scrap iron we can use now. So anyhow they will give you what?
You will
NH2.
get the aniline.
NH2. Aniline they will give.
HCl.
Then that aniline, if you are treating with NaNO2 plus HCl 0 degrees Celsius to 5 degrees Celsius, that area is called a diazotization. That is called a diazotization. Don't forget the idea, diazotization. So that NaNO2 plus HCl, okay, while it is treating 0 degrees Celsius to 5 degrees, the temperature is very, very important, correct now? Okay, so we will get what? Benzene, diazonium chloride, N2 plus Cl minus we will get. Benzene, diazonium chloride we will get. Okay, ready?
And we will
Then,
give them a chance, sir.
Oh.
Okay. This compound benzene.
no, this benzene, diazonium chloride only you are treating with the CuCl. What will happen? What will happen? We are waiting. We are waiting for your answer. Come on.
Yes. You can give the name. No need to give the structure. Give the name. Give
Name of the compound. That's it. That's it. Here, what is A? What is B?
Yeah, we need your active interaction, dear students. Should not sleep over there. We have only 18
Yes, yes.
questions.
Mohabatra is telling the answer. Zabi is telling the answer. Yes, Zabi. Great. Hanna MS is telling Sandmeyer. Yeah, Sandmeyer type only. That only. What's the answer? What will be the compound? Compound name you have to
Yeah,
tell.
all are giving Hisham.
Yes,
Well,
Ansdar J. Gujumon. Great to see. Okay.
Yes.
Yes, Tanvi, Jay Aditya, Saad Nawaz. Everyone are telling the answer. Great to see that.
Yes, cyanobenzene.
Yeah, cyanobenzene. Okay, so can we write the answer, sir? Right directly? Can I write now? So here, once this diazonium salt means, can I write here now?
Yes, here we
So
can
that
write
will
now
give you what?
that when CuCl
That will give you
HCl
CN. Cyanobenzene is coming.
Any
Then
cyanide
cyanide
on
on hydrolysis. In presence of acid, it will give you carboxylic acid. So benzoic acid is the answer. Benzoic acid. So A is cyanobenzene and B is what? Benzoic acid.
Every cyanide on complete hydrolysis give carboxylic acid, that you keep.
That's the idea. In presence of acid, acidic hydrolysis.
Yes, yes.
Okay, now ready.
Salman,
When you hydrolyze cyanobenzene, yeah, when we are hydrolyzing cyanobenzene, we will get what? Satvik is answering. Okay, so that's the answer. Okay.
Go to the next one.
Yeah, next question. Okay. So this is the next one, sir. How will you distinguish between the following pairs of compounds?
Okay.
You are
Can
having
we-
aniline
yeah, can we give them
as
chance?
well as ethanamine. Yeah. Okay. Let them tell.
Aniline and ethanamine, keep in mind both are primary amine.
Primary amine. How
So
you
both
will
are primary
how
amine.
you will get?
So tell the reaction. See, they are giving. Yeah, well done. It's both can be applied, sir. Actually,
Yeah.
they gave both.
So here
answer.
the thing is that aniline and ethanamine we can apply the nitrous acid test.
acid
That is
test.
easy test. Okay.
Yeah.
Nitrous acid test. Not only that carboylamine test we cannot apply
Carboylamine
because
cannot
both are
apply
primary
both.
amine.
Yeah, both are
They are
primary.
telling carboylamine, that is wrong. Okay, carboylamine will give both are primary amine.
That is why I gave the hint. Both
Yes.
Both are
This
primary.
NH2, if I am treating with a NaNO2 plus HCl.
Yeah.
Plus HCl at 0 degrees Celsius to 5 degrees Celsius, they will give you benzene diazonium chloride. It is stable. It is stable one. But while I am taking ethanamine, ethanamine means CH3, CH2, NH2. Okay, CH3, CH2, NH2. If I am treating with the NaNO2 plus HCl, NaNO2 plus HCl 0 degree to 5 degrees Celsius, it will give you primary alcohol. CH3, CH2OH plus nitrogen.
Yeah, N2 gas.
Plus nitrogen. That nitrogen gas will evolve like a bubbles.
With
So
nitrogen gas you can identify.
Identify.
And sir,
Easily you can identify.
we use Hinsberg reagent? No.
Hinsberg
Because
reagent
both
also
are primary.
both are primary.
Hinsberg
This is
reagent
primary.
yes.
This is also primary.
Yes.
So we cannot use.
Yeah, this one will give alcohol and nitrogen gas. Alcohol is not the identifying compound. Here nitrogen.
Nitrogen will come as bubbles. It is a gas, bubbles.
Alcohols are colorless.
Yeah, colorless.
The test means there should be physically distinguished.
Yes.
Physically distinguished means here nitrogen gas can be physically distinguished.
Easily you can distinguish. Whenever a gas is coming means they can easily. So you did the test of carbonate for carbon dioxide, right? So carbon brisk effervescence. Likewise it will come. Okay. Not brisk effervescence, bubbles will come. Okay, that's
can
it.
go for second
So
one.
second one, aniline and N-methyl aniline.
Yeah.
Aniline and N-methyl aniline. Okay,
Here also
let's
you
see.
can give the answer.
Let's see what they are telling. Let's see.
That I think they are giving the right answer.
Yeah.
As you said,
This
you
is
can use
aniline. I will write the compounds here, sir. This is aniline. This is aniline and N-methyl aniline. Now they can apply.
Yeah. So
N-methyl aniline.
CH3.
N-methyl aniline. This is N-methyl aniline. Okay.
So
This is
here you
N-methyl.
can use-
This one is primary.
And
This one is secondary. Now you can apply either Hinsberg reagent test
Or
you can apply or carboylamine test you can apply.
here you can use
So you
carboylamine.
can apply carboylamine test here. I hope
Yes,
that will be easy now.
that is easy.
So chloroform while we are treating with alcoholic AOH.
KOH,
Alcoholic AOH, it will give you what?
Isocyanate.
Isocyanate.
Isocyanate. NC.
Sorry, NC and that's it.
Yeah, that is enough.
That's enough. That's
Foul
enough.
Smell is there.
Foul smell. This is a
That
bad
don't-
smell.
yeah,
Foul smell.
Foul
Here
smell
no
is-
reaction.
Here we have tried no reaction.
No reaction is coming. No reaction.
Okay,
So that's it.
The carboylamine reaction that with the foul smell we can physically
Physically we can easily determine.
Okay. So
Or else, sir, can you give easy method for aldol? That we will give. Okay, easy method for aldol. Last we will discuss
Yeah,
about
that-
aldol.
that-
Okay.
yeah, that
So
easy
now we are
method for
discussing
aldol.
about aniline. After the last, finally, after the biomolecule, we will explain. Obviously, we will explain about how to answer the aldol. Okay, no problem at all. Okay.
we will explain.
We will explain. Oh, don't worry, don't worry.
can go for
So
the next
this is the idea. If you can use Hinsberg test also while you are using Hinsberg test and NaOH, that precipitate will dissolve in that NaOH finally. But here that precipitate won't dissolve in NaOH. That's the idea. Okay.
Next
So
one.
next question. No. One more is there. One more is there, na? One more is there. One more is there. We can come back. Okay. Arrange the following compounds in decreasing order of their boiling points. Okay, boiling points. So the thing is that you have to remember. Alkanes have very less boiling point than that of what? Ethers.
Alkane least, then after
Ether,
that ethers,
then
after that we can write
aldehyde as well as ketone. We can write ketone,
first, after
then
that
approximately
aldehyde
aldehyde, Then
After that, alcohol comes.
what? Alcohols comes.
Then amines comes.
Then amines after that.
come, then
Amines
alcohols
after
come.
that alcohols. Amines
then
after that
alcohol
alcohols.
come, then
After
carboxylic
that
acid.
carboxylic acid will come.
Yes. So
Okay,
maximum is
carboxylic acid will come.
Then alcohol,
So,
amines,
in-
aldehyde, ketone, ethers and alcohol.
That's right. They should have the same number of carbon atoms. Then only this one. Okay. So the thing is that while you are looking about the boiling point, this is the simple idea. Okay. Boiling point is directly proportional to number of carbon atom. Okay. Then boiling point is directly proportional to molar mass. Same only.
Yeah.
Same only.
Branching
Molar
point
mass
is
only.
boiling point
Then
will
boiling
come
point is directly proportional to intermolecular hydrogen bonding.
Yeah.
That they know. They know. Anyhow, I am simply writing hydrogen bonding. Then boiling point inversely proportional to branching. That's the idea. If they know this idea means they can easily answer everything. Okay. So in the case of alkane, there is no hydrogen bonding and all. So directly we can tell. Here, what about the
have
question?
to keep
In
in
our
mind,
question,
yes,
butanol,
alcohol,
butanamine,
amine, and
butane. All are butane. That means 4 carbons are there in every cases. And here it is an alkane. This is alcohol. This is amine. So which one will come?
Maximum will be for alcohol.
Maximum will be for alcohol will coming. So butanol I am writing here. Butanol. Then before that, before that butanamine will come.
Amines will come.
Butanamine will come.
And hydrocarbon
Before
will
that,
come as
butane will come. So they may be think like that in butanamine as well as butanol, both cases hydrogen bonding is there. Even though why butanol is having more boiling point, the thing is that here here actually the hydrogen bonding is formed by oxygen.
Yeah,
Here-
aldehydes and ketones, boiling point will be almost the same.
Almost same, almost same.
Less will be for ketone.
Ketone.
Because aldehyde is more polar.
More polar. That's the reason.
Okay, so very closely if you are checking the value, aldehyde
Aldehyde is little bit more. High.
More. For if you want, you can put less than simple, no issue.
No problem.
Aldehyde will have
No
higher
problem.
boiling point than
Comparatively, they are. That's why only we are taking about them together
ketone. We
only.
are writing approximately equal because this one we will take together as carbonyl.
Carbonyl. That's why only we are writing together.
Otherwise, you can say aldehyde will have higher. No doubt.
No problem. That's the
get
problem.
confused.
So here butanamine is having actually nitrogen hydrogen bond only. So here the hydrogen bond is with the nitrogen. Here the hydrogen bond is with oxygen. That's why it is more. In the case of carboxylic acid, more number of intermolecular hydrogen bonding, more
Dimer
oxygens.
formation.
That they know.
Because of dimer. Yes,
Yeah.
we can go
So I think we can go to the next question. I think they are ready now.
Yeah.
So you have to put some fires as well as hearts in the comment box, please.
Yes.
Please. This is the last moments.
Satvik, the diagram and all is not important for tricycle and all. The reaction, cathode, anode, and that is over. No?
Till now they are with electrochemistry.
Anyway, they are.
Yeah, now we are in aniline. Now we are in amines. Yes, Anna MS. Okay, come on, everybody. Yes.
Yeah. All are there.
Yes, Snowflake is coming. So we have to show your energy. Okay. Yes. We are in the last moments, last lap only. Only very few questions only remaining. Okay.
Yes.
Ready, sir.
Yeah.
See that.
Yes. See, this is
Yeah,
our energy
now
actually.
comment box is firing like anything.
Yes.
Yes, hearts of you guys. Okay.
Yes. So,
Yes, okay, shall we go to the next one?
Yes, next was
Yes, we got the fuel, okay.
Yes.
Account the following. Aniline is a weaker base compared to ethanamine. It's a simple one. Why amines are showing act as a base? Because of the lone pair. Because of the lone pair. Okay, here in ethanamine also CH3, CH2,
has lone
NH2. Nitrogen has lone pair, but the problem is that in aniline, this lone pair is not available to donate. Because of the resonance, this electron will come here like this. You remember the resonance? Because of the resonance, plus R effect, because of plus R effect, that lone pair is not at all be available for the donation. That's why their basic character is less. That's it, no sir?
Yes.
That's enough.
That
Okay.
is more than enough because otherwise you can compare with the plus I and minus I.
Yeah, no problem. Yeah, fine. So that's the thing. Here it is. Here the thing is that here CH3 SH2 group is plus I effect group. So they will donate electron to nitrogen. So in nitrogen, electron density, electron is a wave. That electron density will increases. So they can easily donate to anyone. So they
Here
are.
phenyl group is electron withdrawing, so that will take the electron. That's why. So anyway, that is fine. It's enough. Here electron is lone pair is available for protonation. Here lone pair is not available.
Not available. That's it. Okay. Next to be aniline does not undergo Friedel-Crafts
I think that is the
reaction.
easiest
That's the
one.
easiest one and
Everyone
important
knows.
one.
Everyone knows.
Important one also. Important one also.
Very repeated.
You know. This is the idea. I will write here. Anyhow, I will write here. This is the thing. This is aniline. Okay. Aniline. Once I am treating with the alkylation, I will take off Friedel-Crafts alkylation. Okay. CH3Cl plus anhydrous AlCl3.
Yes.
Anhydrous AlCl3. What will happen? What will happen, sir? This lone pair. Actually, we are expecting a splitting here, but this AlCl3 directly come and attach with the NH3.
Electron deficient
Yeah,
species.
electron deficient species.
So,
So
every electron deficient
that
species
will be
acts as
become
an acid.
NH2 plus AlCl3 minus. They will form a complex.
Yeah.
They will form a complex salt. We can write like that, okay?
Yeah.
So complex, they will form a salt. That's it. So this CH3Cl have no role. So electrophilic substitution won't occur, okay?
The reaction
So
will not take place in the desired direction.
desired direction.
Yeah.
So that's it,
we'll
okay.
Go to the next one.
Next
Sir.
one again, sir. Tell me about
Only
only
primary amines can be prepared by Gabriel Thalimide synthesis.
Okay, sir. Tell me, sir. What about Gabriel Thalimide synthesis? What about okay? You read, sir.
See, Gabriel Thalimide synthesis means you that one. There is a second step. Gabriel Thalimide synthesis. You know that one. Benzene ring having CO. Here it is CO. Here it will be NH.
This is
After
thalamide.
That one here, yeah. Here
Thalamide is there. You have to treat it with
that
a
one, it will be treating with the KOH.
chaos.
Then
You have to
will be
make
getting
this one into covalent into ionic.
So you will be getting a potassium
Thalamide.
So here it is CO and here it will be NK.
NK.
Okay. This is the step we are talking about. Here it's a nucleophilic substitution. We are taking RX.
RX.
Students. RX means what? Alkyl halide, sir.
Alkyl.
Alkyl halide only can participate if you are using.
It can break it easily, but aryl halide cannot break it.
You cannot use aryl halide. That is the issue. If you are using aryl halide, you will get aniline.
Yeah, aniline.
Okay. But that will not.
But that carbon halogen bond is not at all be breakable. That they are already learned in haloalkane. Yeah.
Do not participate in
Nucleophilic substitution reaction. That's it. Very simple.
So, how will you present the answer? In Gabriel Thalimide synthesis, second step is a nucleophilic substitution in which only
Haloalkane only undergo participate.
Haloarenes will not. That is why never
At a normal condition, it won't occur.
aniline never forms.
Aniline never
Only,
forms.
aliphatic primary amine can be formed.
Okay, ready?
No need to write the reaction. Only this statement.
Yes, they are telling the answers, sir. But with high heat, can we show how it is wrong? No, not like that. But some other different condition, it is possible. That is ipso reaction and all. That is not there for your board exam point of view. Don't worry. Okay, only this much is there.
Yeah. So here, room temperature, when normal reaction takes place, they are asking.
That is not going to be possible. That is not
we are not giving any extra temperature.
any extra temperature. Normal.
temperature.
Gabriel, how he did like that only. That is.
Temperature, reaction is normal temperature. That time they are asking whether it takes place. No, heating means we know that one high temperature and pressure. Definitely
That is possible. That is different. Okay, that cases are different. That is not there for you.
That is not there.
This is asking about Gabriel. Specifically, they are asking. Okay.
Yes, sir.
So shall we go to the next one, sir?
Yes.
Yes. So this is the 85th question. Okay. Although NH2 group is ortho-para directing electrophilic substitution reaction, yet aniline or nitrating give good yield of meta-nitroaniline. It's a very important question. I am putting 5-star here. Very important. Okay. So here I will take this one. I will take the next slide. I hope that will be better. So here the thing is that aniline. Okay, I will write the reaction. That will be better. Aniline. Once I am undergoing concentrated HNO3 nitration. Okay, concentrated H2SO4. It will give you what? It will give you aniline is here. Here NO2 group is coming at a para position as well as NO2 group is coming at a, we are expecting ortho and para. But unfortunately, where also this NO2 is coming.
Yeah.
Meta also coming. This actually around 51%. This only 2%.
And
This is 47%. Why it's so? That's the question. Because the thing is that this is strongly acidic medium.
It is not supposed
Strongly
to form.
acidic medium. So
It's not supposed to form actually.
actually,
but forming.
but the thing is that this aniline in strongly acidic medium means H plus is more. That's the idea. So what will happen? This H plus will take that electron and it will be forming what? Anilinium ion. NH3 plus. This anilinium ion.
And that is a deactivating.
Anilinium ion is meta-directive.
Meta-directive
or deactivating group. They are meta-directive or deactivating group. That's why hereafter if you conduct that reaction, automatically it will go to what? Meta-nitroaniline only will get. Okay, ready?
They gave the answer, sir.
Yeah, they are telling the answer. Okay. Shall we go to the next one?
Yes, sir.
Yes, sir. Okay. So here the thing is that second one, CH3 twice NH. That means
more basic.
dimethylamine is more basic than trimethylamine. Okay, in aqueous solution. Why it's so? So the thing is that again Again, while you are looking this one, you can see this one CH3 is there, then C is there. Here CH3, CH3 twice only, right? Okay, so N is there. We can write N is there. Here CH3 is there. Here also CH3 is there. This is a tertiary amine, tertiary methyl. Okay, so this is a tertiary amine. Similarly, CH3 is there, and CH3 and H, and here lone pair. So the thing is that while we are looking about the plus I effect is more here. Here plus I effect is less because here 3 alkyl groups are there. So here 2 alkyl groups only. So according to plus I effect, tertiary should be having more basic than secondary. But the problem is that while we are putting this one in aqueous solution, they will undergo solvation. That means with the water they can form hydrogen bond. So more hydrogen bond can be formed by this one only. This one cannot form the hydrogen. I mean they can only less only they will form.
Yeah, because here hydration enthalpy will be high.
High.
Because easily soluble.
Easily soluble.
Hydration enthalpy
So
high
here
because less steric effect.
less steric effect as
Here
well.
more steric
effect.
So will not soluble in water. So less hydration enthalpy. High hydration enthalpy means it will be coming ulta.
No,
Okay,
just reverse it will come.
Reverse it.
So the thing is that according to hydration enthalpy, this one is more soluble. Secondary is more soluble than tertiary. By comparing these two, the thing is that by comparing these two, we can tell that secondary is having more basic than which one?
That
Tertiary.
is why, sir, they have order no in aqueous solution order is
Secondary, then primary greater than tertiary in the case of methyl. In the case of ethyl, secondary, then tertiary, then primary will come. Okay, that's the idea that they learned already. So I think we can go to the next one. That's it now. That's it. I hope. There is some question. Okay. Ammonolysis of alkyl halide is not a good method to prepare pure primary amine. Okay. So while you are taking RX haloalkane with ammonolysis means you are taking ammonia excess.
Yes,
okay. So while you are treating this one means what will happen? This will be RX will treated with that will be producing RNH2. Again it is treating with the NH3. It will produce R2NH.
Yeah, here it will be
okay.
Alkyl halide.
Okay, alkyl halide. Okay, I'm sorry.
It's okay.
Okay, so this one excess. Okay. So this one R2NH will be there. Again, if you are treating RX means what will happen? R3NH will come. So R3N will come. Again RX means it will form R4N plus X minus. So you will get a mixture of primary, secondary, tertiary and quaternary ammonium salt. Okay. That you will get. You won't get the primary.
So correct.
So that's the idea.
During ammonolysis, mixture of primary, secondary and tertiary amines are formed and it is very difficult to separate from one another.
That's
that
why.
Is the right answer. Mixture of primary, secondary and tertiary enough metals are formed and quaternary if you are not telling also.
Yeah, if they want to get more primary means they have to take more ammonia. Then so it will be easy. That's not needed. That's enough. That's enough.
Yeah, primary mixture of primary, tertiary and secondary are forming and it is very difficult to separate from one another because of their close boiling point.
That's it. Next again, distinguish between the following CH3, CH2 and NH2. That is ethanamine as well as diethyl amine. Diethyl amine. This one already this is primary amine. This one what? Secondary amine. They have the answer. What about the primary amine, secondary amine? How we can distinguish? Tell me the answers, please.
Yeah, they are giving the
carbyl amine test. Okay, carbyl amine test is enough. Carbyl amine test is enough or Hinsberg test.
Yeah.
Diazotization. Okay, diazotization means this will give a yellow oily liquid only. Secondary amine will give. That also they are learning, no, sir? Okay.
Methylamine in water reacts with the ferric chloride to precipitate hydrated ferric oxide. Yes, that's a question. We will explain if you want. It's same methylamine. That type of many questions are there. We selected only few questions. Okay, means important one. That is there. If you want, we will write.
Sir, one thing we can do. We can after this 10 question, we use just note that question, sir. Okay, no problem.
Yeah, you can type this question again. No issue. That methylamine is very easy. That OH will be replaced by Cl.
That's it. Nothing more. Okay. So whether I have to no need to write now. Whether I have to write this one.
No.
The carbylamine. Carbylamine already we discussed now. Already we did.
It's carbylamine.
Same.
But you should write the reaction. Okay, should not forget. Yes.
Same but different. Okay. Yes. So here the next one aniline and methylamine. Okay, aniline and methylamine. Sir, this one also we told. Aniline and ethanamine we told. In the case of aniline and methylamine we can use what? nitrous acid test. Nitrous acid test means this will give you what? Benzene diazonium chloride, stable one at 0 to 5 degrees Celsius. But this one will give you nitrogen gas. Okay.
Alcohol with the nitrogen
That idea we already discussed it. Okay, shall we go to the next one?
yes, sir.
Okay, we can go to the next one, guys.
Number,
This is the next one, 86th question.
Yes.
An aromatic compound. Listen to me very carefully. This kind of conversion question is going to come. Okay, this kind of question will be there. Any of the chapter, at least one question will be there. Okay. So an aromatic compound A on heating with bromine and KOH to form a compound B of molecular formula C6H7N. So here itself they can understand. Bromine plus KOH. Listen to me very carefully. Bromine plus KOH. This is actually Hoffman bromamide. That only you are learning.
Bromide will take only amide.
Only amides, amides
and
only.
we can participate.
So here this one C6H7N means obviously it is aniline.
Yeah, it definitely.
This is aniline, no
Aniline
other
can
option.
be formed from
C6
benzamide.
means aniline, no other option because here it is not a aliphatic one. C6H6 like that nearby only it is coming. So aniline. So obviously this one should be benzamide. C double bond O NH2. Benzamide, which on treatment with the bromine and KOH it is giving aniline. Then again what they are telling, which on reacting with chloroform and alcoholic KOH, that is isocyanide test. Alcoholic KOH will give you what? Phenyl isocyanide, NC. I'm sorry, NC. Phenyl isocyanide. Okay. Phenyl isocyanide. It is having foul smell. Foul smell. It's having foul smell. Okay. So that's the idea. So then they are asking about what is A, B, and C. Reaction already there. Okay.
They already got, yes, Hoffman's bromide.
Yes. This one. If you want to write the names also, this is benzamide. Okay, benzamide, and this one aniline,
Phenyl isocyanide.
and this one phenyl isocyanide. I hope you guys got it. Ready? Yes. They are telling. Okay, we can go fastly, na sir.
Yes, sir.
Yes. Now the time is 8:31. We started from 3 o'clock, guys. Even though you are there, that's the power. That's the spirit. Okay. Yes, DK. Yes. We can go to the next one. This is the question number A. We are taking aniline. We are taking aniline with what? This is another one. Can I put 5-star here?
Yes.
5-star. Very important. Okay. So I am treating with the concentrated sulfuric acid. Concentrated sulfuric acid will give you H plus and HSO4 minus. Automatically here lone pair is there. So that we already told. Strong acidic medium. So here it will be become NH3 plus HSO4 minus. That one we are heating.
Again on heat.
Heating
And here
rearrangement.
you can remember the name and those who
Yes.
have idea, you can send the name.
I think, sir, something. Your sound is not at all be okay. My sound, I have enough sound. You keep this one mic, okay? You keep this sound mic with you, no problem at all, okay?
It's
So
okay.
here, NH3 HSO4 minus DK sound is going, okay, students, okay?
Yes.
No problem. Even though DK is with that much energy, okay? So here, NH3
See this
HSO4
compound
minus-
on heating. Yes, dear students, this compound heating a very important compound. There is a common name for that one. Yeah, yes, very good.
Yes,
It's
they're
given-
telling.
yeah,
Zitter ion, they're
sulfur-
telling,
yeah.
okay, correct? Here, this will
That's
form what?
sulfanic acid,
Here,
NH2 will be there, sir.
NH2 will be there.
And HSO3.
Then HSO3 will
Yeah,
be there, okay?
HSO3 will be
Here
there.
HSO3 will be there, okay? HSO3H.
Or SO3H you can write.
SO3H
Same.
will be there. Then
This
they
is
will
the
undergo-
sulfanic acid.
They will
Sulfanic
undergo
acid.
just
Yes.
rearrangement and form zitter ion.
Yes.
That's it.
Yes.
Yes,
Yeah,
great,
that
great,
is the
great,
sulfanic
okay.
acid.
So that's the answer.
Okay.
Can I go to the next one,
Yes,
guys?
we will go to 88,
Okay,
sir.
okay.
Yes.
Let's go to the next one.
Yeah,
Here
one more is there. One more.
Okay, I will write that one here.
Yeah.
So here, benzamide is there.
When reacts with the Br2 slash.
is there, CONH2 is there.
When
That
reacts with the
reacting
Br2 slash KOH.
Bar NaOH, Br2 bar NaOH.
Yes.
Hoffman
Hoffman's
bromamide
bromamide
degradation.
reaction.
You have to simply remove CO
Yes.
and we can
Then we'll
write
be
what?
getting the aniline.
NH2. Aniline
Yeah.
we will get. Then we are treating that one with what? CH3
Yes.
COCl, I hope.
Yes, yeah, acetylation, sir. Acetylation.
Okay,
Yeah,
acetylation.
CH3COCl
That is
in
acetylation.
presence.
That will give you what?
COCH3.
NHCOCH3.
Yes.
Okay. NHCOCH3 will get.
Acetylation.
Acetanilide will get. Okay.
Yeah.
So that's
So-
the idea.
Yes.
So acylation only. This
Aniline,
idea
yeah,
is
correct.
acylation only.
Acylation.
So acetanilide you are getting. Okay. So that's
Either
it.
you can use CH3COCl or CH3CO twice
Twice
O
O.
in
That-
pyridine.
that's- the thing
And
is that
one, yeah,
CH3CO group we should have to get.
that is it. And the
Acylation.
role of pyridine is to prevent the reverse reaction. The pyridine
Because
will
then HCl will-
neutralizes the HCl.
HCl,
Okay.
that will
We can go
neutralize.
to the
Okay.
next one, sir.
Next one,
88.
next one. Okay, this is the 88th question, guys. 88th question. Aromatic diazonium salts are more stable than aliphatic diazonium salts.
I think
Idea
they
is
have the answer
simple.
right now, yeah.
Okay, you tell me the answer, guys. I will.
Why
just note this
aromatic
one.
diazonium salt are more stable? Yes. Yes, yeah, due to, yeah, correct, that is easy. It's due to resonance.
Resonance is there.
Yeah, whereas aliphatic diazonium
So this one,
chloride,
what resonance stability is there?
Resonance stabilization.
Stability is there.
where aliphatic
But-
diazonium salt cannot be stabilized due to resonance.
So I will take if I am R2 N2 plus Cl minus means there is no resonance.
Yeah.
No resonance.
And carboxylamine reaction we wrote in almost all conversion. We are not going to write it again.
Again.
Carboxylamine reaction.
That they know. That they know.
Yeah,
you know now? Yes or no? Yes.
Yes,
they
due
know,
to
they
high
know.
resonance. Yes,
Okay.
correct. Yes, easy,
correct,
easy.
correct.
Yeah,
Okay,
I
we can
think
go to the
amines-
next one, guys. This is the 89th
Second last
question.
one,
This one
yeah.
again. Acylation.
Already we did.
This acylation.
Acetylation.
Here,
Yeah.
this one
NHCO, CH3.
CH3 will come.
Yes.
Okay, then
And
again
here
this
it
one.
is
This one is
associate.
actually Hinsberg
Yeah,
test.
Hinsberg test.
This is secondary amine.
H
So what
will be
happen?
replaced by HNCl
Here
will
we
be
can
replaced.
write S double bond O.
Oh, yeah.
Double bond O. Here instead of this Cl, N will be there.
Yeah.
CH3 will be there.
And
CH3
here
will be
this
there.
is-
Then
yeah.
H and Cl will be removing. Okay. So that's
Or you
all.
can write this SO2 together also, no issue.
No problem,
SO2
no problem.
and
Okay, no problem.
yeah,
no
and
issue, no issue at all.
See, yeah, that
Then
is
this one, benzene diazonium chloride. Once you are treating with the CH3, CH2OH or H3PO3,
yeah,
you will get
you'll
what?
get benzene.
Benzene.
That two
Oxidizing
reagents you have to.
agents.
Yeah, that many times they
Benzene,
ask
benzene.
either ethanol or H3PO2/water. That will come same. Will the
Benzene,
product
benzene
will
will
be
get.
same benzene.
Benzene.
Yes, we can
Okay.
go for the test, sir.
So give a simple chemical test to distinguish
To
between
aniline
aniline
and
and NN dimethyl aniline.
It's a tertiary amine and primary.
amine and tertiary amine. Which
I
test
think
you can use?
Hinsberg
test.
reagent.
Hinsberg
Yeah,
reagent is
Hinsberg
enough, okay.
reagent. Yes,
Hinsberg
Atul
reagent is
Matthew,
enough,
that
I
is
hope.
correct. Yeah,
Yes.
Hinsberg reagent. That already we wrote. So
Already
this
wrote.
is also Hinsberg reagent test. So this test you can write.
No problem now.
Yeah, it's
okay, shall we
we
go to
can-
the next one, guys?
Yes, sir,
yes,
sure.
they are ready. They are ready.
Yeah, arrange the following in the increasing order of their PKB
values.
Yeah,
so we
that-
know when PKB value
Increases,
increases, means
KB value
basic
decreases.
strength decreases.
Yeah,
You
KB
can write,
value.
KB value.
Yeah,
So that
decrease.
means
Or basic
strength
property,
decreases.
yeah, basic
So I
character.
am taking this one A, this one B, as well as this one
one
C.
C, yeah.
So here the which one will having more basic strength? Whenever benzene ring is there, basic strength decreases. Because they will take the electron pairs towards.
Yeah, here
towards
we
the
can do
resonance.
one thing. We can categorize as this one is aliphatic and this one is aromatic.
Aromatic.
So,
So-
aliphatics are always more basic.
More basic. So
Yeah.
their PKB value is less. So
Yes.
I can write that one first.
Yeah, first.
PKB only we are
And
writing.
among these two
Among
aromatic,
these-
this will be more because
More,
of CH3.
Because CH3 is there.
Yeah, so next C
one,
will
A.
come.
Next C will come. Okay, I'm sorry. Next C will come. Next C will come. Then after which one will come? Next after that which one will come? A will
Yeah.
come. So that's
So
the
that is the
least
way-
basic one. So that's why more PKB value will be there.
PKB value we are taking as the most. That you keep in mind.
Not
Yes.
BCA only. They are
Yeah,
telling.
BC
BAC they are telling. No, BCA only will come. Okay.
See here it will be
Yes,
the
yes,
PKB
yes.
value. Correct.
Yes, correct only, correct only.
Okay.
So if it's so, then we can move to the next one. We can move to the next one. This is the last question, guys.
Yeah.
This question already
90th
we did,
question,
already
dear
we did.
students.
CH3, COOH and NH3.
Yes.
That will give you CH3.
Amide always form.
NH2 will form.
Yes,
Okay.
amide.
That's the A. One
When
thing is
reacts
treating
with
the
the
bromine
Br2.
and KOH.
It's repeating already.
Again,
It's
CH3, NH2. In the
Both
question
mans-
paper also
yeah.
it is repeating. That's why
Yeah.
only we are putting.
And last
Then
one is
again,
carboxylamine
CH3,
reaction.
CHCl3
plus alcoholic KOH.
alcoholic KOH means what? That is
carboxylamine
that is
reaction,
carboxylamine
CH3NC will come, sir.
CH3NC will
CH3NC.
come.
Isocyanate will
Okay,
come.
isocyanate test. What about this one,
And
guys?
this one, yeah.
This one C6.
See, here they are giving the intermediate.
Can I take
Yeah.
here, na, sir?
Yeah,
So here they
C6H5.
start from the intermediate
Yes,
actually.
yeah.
N2
N2 plus BF4 minus.
BF4 minus. This is the one
On-
and only one
Yes.
stable at room temperature. Okay.
Yes,
So anyhow,
heating
we are treating this one
NaNO2
with
slash
NaNO2 plus NaNO2 bar Cu and heating we will get nitrobenzene.
Nitrobenzene.
We will get
Nitrobenzene with
nitrobenzene.
FeCl,
Then
Fe
remaining
slash
they know.
HCl. Or
Then remaining they know. Then
You will get
here
aniline.
means you will get what?
Aniline.
Aniline.
Yeah.
NH2 you will get
And
aniline.
acetylation
that will give
again.
you acylation.
Yeah.
C double bond O. Sorry.
Acetal-
NH.
yeah.
NH.
C double bond O.
CH3 they will get. Acylation, simply acylation that we already discussed, guys.
Yes.
So that's all about the case of
I think,
that's the case of amines.
We finished all the organic chapter.
all the organic chapters.
Yeah, we have one more chapter,
One
the
more,
last and
before
final
that,
one.
Before that, we have to tell one more thing. Here you have to remember one more, that coupling reaction you have to remember.
Yeah.
Sir, we already promised
I
them that.
think, sir, we have one more question. We will finish this one. I think, yeah, 91.
91.
It's the additional one.
Additional
Okay?
one.
Yeah.
So
It's
no
the
problem, no
bonus
problem.
question
This is
we
a
will
bonus
do.
question we are doing.
Yes.
This one again,
it's a
C6H5
very-
NO2 SNCl. What you will get?
NH2 will
so
get,
that is
aniline will
NH2.
get,
Aniline
yeah.
will come.
Aniline
will come.
acetylation.
Then again acylation. B acylation.
Yes.
Acylation means
CH3.
NHCO CH3 will come.
Yeah.
Okay.
And
again
that
we
one-
are treating with HNO3 and H2SO4.
That
So only this group is para-directive. That
Yeah.
means deactive. The somewhat
Ortho and para will come and
but
para will
ortho
be
they are
major.
because
Yeah.
it is a steric entrance. Because
Yeah,
of the
still-
ortho,
oh.
para only major
Major
product
will be para. So you can write
selectively para-directive, that one.
Yeah,
NH C double bond O CH3
and para
to
position has
NO2 will come.
NO2. Then
NO2
hydrolysis will
Then
give back
hydrolysis
the
means
NH2.
this will go back. So D will be benzene is here.
NH2,
Here
aniline
NH2
will
is
come,
there. Here
and
NO2
NO2
is there. So para nitro aniline will come.
And
That's
here
it.
E is there,
And
sir.
if you are taking E means that we
That
already
is
discussed.
sulfanic acid. We
That
can
we
write
already
directly.
discussed. Okay,
We can write directly.
Directly we are writing
Concentrated
NH2,
sulfuric acid and
NH2
heat.
and SO3.
SO3. Sulfanic acid will be
that heat
coming.
also sulfanic acid we are getting. Okay,
Yes.
that's it. Yeah, they are telling.
Yes.
Sir,
Yes. C
he's
paranitro.
behind.
Acetylation. Yes, correct.
Yes,
only,
yes, correct,
Yeah.
correct. Okay.
Yeah.
So that's the idea, dears. That's the idea, dears. This is the idea. So they are asking about Deepak sir. Where is
Yeah.
Deepak sir? He is the one. He is behind the camera and giving the answers to you. Deepak sir, come on.
Yes,
come on.
yes.
Yes.
Now the
that's
last,
that's
very
the
last
idea
chapter.
about what? I mean, and the
Yeah.
last
Our-
topics. Last topic. That is actually the biomolecule. This is the final lab, sir.
Yes.
You want to
Yes.
tell anything to them?
Out of 70, 63 mark area we already covered.
Already
Yes,
covered.
covered.
Now around 7 mark is left. That is our
Only seven.
biomolecule
Biomolecule chapter is
I
going
think,
to finish.
That chapters are very easy. From
Yes.
the single frame, let me tell you, let us discuss about what all are the important area from the chapter. Biomolecule, then we can wind up.
One more.
After
And,
that,
and
we'll-
up to the last moment of their exam also, we are there along with them.
Yes.
So you have to utilize it. You have to remember all the things and you have to write it, guys.
Right.
And you have to rock it, guys. Okay.
Everything.
Yes,
what
it
all
is.
we
Yeah,
discussed
almost.
in this basics
It's
here.
going to almost 6 hours. Almost
Yes.
6
So,
hours.
yay,
Right.
6 hours. Yes.
Yes.
Okay. So I think the last
Yes,
chapter.
now we can
Yes.
go for the
sir.
last
Last
Are you ready?
session. Yes, ready.
Yes. Okay. Come on. Come
Let's
on.
go
You
for
can
the-
stand here.
So dear all, this is our last chapter, biomolecule, 7 marks at any cost, should not leave it. This only we have to write something here, nothing like more reactions and all not there. Only few reactions, you know that. So
Yes.
these are the
We have-
most important topic from the biomolecule chapter, you know. First one is type of monosaccharide, you know. Which all are the types of monosaccharide, sir? We can able to say that monosaccharide, we studied that monosaccharide, disaccharide,
Polysaccharides and all.
oligosaccharide,
Yeah.
and examples, everything. And types of, especially carbohydrates, okay, carbohydrates, which all mono,
Everything.
different types are there. And reducing and non-reducing sugar, we know the reducing sugar, non-reducing sugar, what it
Yes.
is,
What
and
it
what
is
are
and
the
why it is
examples.
called, yeah.
Right. And a reaction, we can definitely expect a 1 or 2 reactions. How they determine the
conversion.
structure of which one?
Reaction of glucose with any of the reagent. I can
Glucose
ask.
contains
one.
6 carbon. Why
Yeah.
so? How many oils like that? Okay.
And what are anomers? Alpha D glucose, beta D glucose. What
Good
is
idea.
invert
Sugar.
sugar? And glycosidic linkage, where
Peptide
it
linkage.
is.
Yeah.
Peptide linkage, where it is. Phosphodiester
Phosphodiester
linkage,
linkage.
where it is. And fibrous and
Fibrous
globular
globular
protein,
protein.
study what it is with example.
Amino acid, essential,
classification.
non-essential.
Essential, non-essential, acidic,
Acidic,
basic,
basic.
neutral amino acids. Structure and denaturation of protein. I think we
Boiling
can
of
expect
egg.
a question
Yeah,
for
yeah.
boiling
Of
denaturation.
egg.
Yes.
Denaturation.
Curdling of milk.
Yeah, milk. Yeah.
Vitamin deficiency, one of the expected question either in MCQ or 1 mark area.
Yeah, that case study question, you can expect all these
Yes.
things. Yeah, that
And
will
So,
nucleoside.
they should have vitamin A. Now
Yeah.
they have to watch these videos.
Ah,
and all.
this-
Yeah.
something related
Now the
to
time
eye.
is night
Yes.
only. Okay.
I hope
Yeah.
you not have like night
yes.
blindness and all. Hope you have richer in vitamin A, right?
Yes.
Yes.
Nucleoside and nucleotide, what is the difference? And DNA, RNA, what is the difference?
This is the
Let's
last.
go for the question.
Yes,
here
so
have a
we are
paragraph
also in the
question.
last lab. Let's see.
Yeah.
Come on.
Yes, come on.
They are
Okay.
telling, one thing I have to tell, they are
Yes.
telling the deadly trio. Yes, yes, we are okay. Yes,
Always will be one.
Yes.
Okay, right. So let's go for
See.
the question number 92, right?
Yes.
Yes, yes,
So
Yes,
a
sir.
paragraph is given, a case study type of question. What are amino acid? That is the first question. What are amino acid here?
Okay.
They are the building blocks of what? Proteins.
Proteins.
What is the general formula? You know, RCH,
NH2 and
COOH. That's
Yeah.
it.
Carboxylic acid is there,
Right?
NH2 is there.
NH2 is there. Both
Yes.
amino and acid.
Acid.
And why are amino acids amphoteric in nature?
OATC. Yeah.
Amines.
Yes.
Amines are
You can say that.
Right.
COOs are acidic.
There is a basic group as well as acidic group.
Acidic group.
Yes.
So it will form what? NH3 plus and what? COO minus.
Minus.
It form a cation anion part. Both
That is
charges are there.
again
That's called what?
Sitter ion. That even same
and
side.
COOs can donate H plus. This NH2 can gain
Sa-
H plus.
same-
I think just now we discussed that in amine
Sulfanic
chapter,
acid.
sulfanic acid
Sulfanic
also
acid.
there is a sweeter ionic form.
Same like sulfanic acid. Here citrion formation.
All right.
Yes.
So give one point of difference between acidic basic amino acid.
The one with
Acidic amino acid contain what?
More number of COOs.
More number of COH group, and basic amino acid
Yeah.
contain more number of NH group.
If they know the basic idea, they can answer.
They can
it.
answer.
Simply they can
COH
answer.
number
Logic.
is more than NH2, then it is acidic.
Right.
NH2 number of NH2
Correct.
groups are more than COH, it is basic.
Yes.
That you
And
can get.
Study at least one example for each all of you. Acidic amino
Yes.
acid, aspartic acid is there, basic amino acid, lysine is there,
Yeah.
neutral amino acid,
I think, yeah.
One thing they are asking.
Question, yeah.
Is it required to read the entire question like that? They are
No,
asking.
I think these type of, see dear all, even if you read the paragraph, what is the question? What are amino acid? So even if you read the paragraph and all, you know, I think chemistry point of view, even if you not read the paragraph, the questions are almost direct.
And anyway, you can read.
but
Okay,
conversion
don't
time they
go
have to
to
read it.
Any confusion in question, then only you have to go for the
Conversion
paragraph.
time they have to read entire thing.
Yes, ABC, in
Yeah.
organic chemistry, ABC find the
that
question
all-
without reading the paragraph, don't attend the
You
question.
cannot
Okay.
handle it. Okay,
Right.
that's the thing. Okay, fine.
Next
fine,
one, what are essential amino acid? Essential amino acids are what?
Amino acids which are required.
Right,
Okay.
which is not
which cannot be
synthesized.
synthesized in our body,
Body.
and which should be supplied through our diet.
Diet. And name the linkage formed when carboxyl end of one amino acid
Condenses with
condense with the amino end of the other amino acid.
Amide
So-
linkage will be formed.
Amide
That amide
linkage-
linkage has a name. What
Yes.
is the name of the
What-
amide linkage formed between amino acids?
What is the name of the
Yeah,
bond
they
between
give-
two
yeah.
amino acid
Linkage.
is known
Yes.
as?
Peptide linkage, they're
Peptide
telling
linkage.
already.
The
they're telling,
amide
yes,
linkage
yes, yes.
formed. Yes.
That don't forget that glycosidic linkage is a type of ether linkage,
Yeah.
and amide linkage is peptide linkage,
linkage, peptide
and the
linkage.
phosphodiester is an ester linkage.
Yeah,
Don't forget the
glycosidic
types.
linkage is between sugars or carbohydrate.
Right.
That you keep in mind.
Okay, let's go for the next question. How can you explain the absence of aldehyde group in the pentaacetate of
D-glucose.
D-glucose?
So we can write CHO.
Right. So
Yeah.
pentaacetate of D-glucose, we know CH3CO,
CH3.
CH3, and then we have CHO, CO, CH3, and 4 time along with the word CHO.
CHO.
We
Yeah.
know that this aldehyde group,
Is not free.
Is not
right?
Here.
It's
Yeah.
not free. It involved in what that cyclic formation.
formation.
So
Yeah,
what happened?
whenever-
Aldehyde group
yeah.
won't be there.
Yeah, pentaacetate is formed. That is CH3 group. CHO will be the part of
Right.
cycle.
Yes.
So it will not be a free group.
Yes.
So C free
If it is
CHO
free
group.
means that will be available.
Yes.
That's the question. How can you explain the absence of that? So when you treat
treat
this
with
compound with the hydroxylamine,
NH2H.
yeah, normally we know aldehyde react with the
Aldehyde react with
hydroxylamine
hydroxylamine.
will give the
Yeah,
product.
but it will
Oximes
not-
they will give.
Yeah,
Like
the
oximes.
same question you can expect, like even though there is a free aldehyde group,
It will
why
not-
it's not giving NH2H test because
That
it's not,
CHO group is not available.
not available.
Yeah, that way also
Right.
they ask the question that you have to keep in mind.
And name the bases present in RNA. I think they will give the answer. I think
RNA. Yes, tell me.
RNA.
Come on, come on.
Answer bio students will be so happy,
so happy
now this
about
time.
biomolecules.
Yeah.
Bio students, if
So
test,
they have
only
so much.
math students having
No.
confusion. What a chapter is
They
biomolecule.
are
base
struggling.
present in RNA.
Yes.
Reducing sugars are the
Uracil,
sugar
uracil.
which can reduce
Base
tolerance reagent and Fehling's reagent.
reagent. That's why reducing. That's why only they are going to reduce.
Yes. Yes, Viral,
Uracil.
which one?
Yes.
Name
Uracil,
the bases present in
thymine.
RNA. Which one of these not present in DNA? Which one? Which one?
that
Yes. Uracil.
Uracil.
What are
Uracil.
the bases present in RNA? AUGC.
AUGC.
Adenine,
Whereas in
guanine,
DNA, that is
uracil. Yeah.
ATGC.
ATGC.
Right.
Thiamine only absent.
All
Time,
right.
yeah.
Next question. Write the reaction showing the presence of the following in the open structure of glucose and aldehyde group. Yes, we treated with the glucose. CH2OH is there, CHOH 4 time is there, CHO is there. This is our glucose.
Yes. When reacts with bromine water,
Bromine water we can
Yeah.
React with which one? Bromine water. It will give you what? This CHO become
Yes.
COOH.
and bromine water is a
CHOH.
mild oxidizing agent
Oxidizing agent.
that will convert only aldehyde group.
I think the answer is already there. What is the
Already
answer
there.
of this complex,
Yes.
all of you?
Yes.
This complex, what we call it as?
Br2,
Glucose
Ashmita.
One
acid,
question they are asking,
right?
will they ask the diagram for maltose and all? So the chance is less only.
No, structure they won't ask, but the linkage they will
Linkage
ask.
they will ask.
Yeah,
Which
C1
kind
and
of linkage,
C4.
what kind of linkage, like that
Yeah.
they can
Yes,
ask.
that
and
way.
also the NCERT same diagram they will give you and what kind, what it is,
Yeah,
whether it is
that type.
sucrose, whether it is maltose, whether it is
Like that they
starch,
can
cellulose.
ask. Yeah.
So what's the structure given? They won't ask you to draw, right?
Less chance to draw the structure
Yes.
because that maltose and all very less
Yeah,
chance.
glucose and
Glucose they
fructose
can ask.
structure.
Glucose
not
they
yes,
can
should
ask.
know.
Glucose that
Haworth
Haworth structure,
representation.
Haworth representation they can ask.
Yes, so aldehyde group presence is determined by what?
Gluconic acid
Bromine
we got.
water,
Gluconic acid. Yes, great.
And a primary alcohol, whether there is a primary alcohol
This one.
or
Yeah,
not.
that
the
is
same
this
they treated with
primary.
what? Strong oxidation.
Oxidizing agent,
Then
concentrated
by what?
HNO3.
Concentrated HNO3.
What they are getting?
We'll get
Saccaric acid.
Saccaric acid. Saccaric acid we'll get.
This CHO becomes COH.
And
even the
COH.
CH2OH
Both become COH. Saccaric acid. we'll get.
Saccaric
Yes,
acid
right,
will be
sir.
forming. Yes, sir.
Haworth structure chance is less. That's,
Yes.
In the previous year questions when we saying
Yeah.
yes we can able to say that not a question but can be expected only for glucose and fructose.
Yes.
Next one is what are the hydrolysis product of
Product of
DNA?
DNA.
Yeah.
DNA and
DNA will-
RNA contain what three things are there?
Generally,
It's
you
all-
have to keep in mind they are nucleic acid.
Yes.
Nucleic acid has three components. First
Pentose
one
sugar.
is a pentose sugar,
Pentose sugar.
then heterocyclic nitrogen bases and phosphate group. So pentose
Phosphate
sugar,
group is there,
heterocyclic
pentose
nitrogen
sugar is
bases
there, nitrogen base is there.
and phosphate group. So
and you
these
know the name of the pentose sugar in RNA is what? Beta D ribose, whereas
And
in glucose is what? Beta
deoxy-
D2 deoxyribose.
deoxyribose. Yeah.
Yes, and phosphate group is common.
Yes.
What happens when D-glucose is treated with the
with the
bromine
Already
water?
we discussed.
Just we discuss, we'll
yeah.
get what? Gluconic
Gluconic
acid.
acid.
What is the effect of denaturation is one of the expected
Yeah.
questions. You know there is a native protein. When this native protein subjected to what?
Undergo high temperature
High
heating,
temperature.
high
On
temperature
heating.
on heating or
Temperature
change in
or
pH,
any chemical change,
like change in pH.
pH. It become denatured. And what are the changes happening? It's a question.
Structure
Yeah,
will be
it retains the primary structure.
And secondary and tertiary structure
Yeah.
completely destroy
Primary
and it's
impact.
lost its biological activity.
Yes.
Globular protein become what? Fibrous protein
Fibrous
and all.
proteins.
These all changes happen. Denaturation of protein.
That when
example.
egg boils and all this happen,
Yes.
that denaturation of protein happens.
Secondary and tertiary will be undergo destroyed.
Change. Yes.
And next question. Write the reaction involved when D-glucose. Already we discussed
Already
some
told,
reaction.
already
Yeah.
told.
Then
Anyway.
NH2H hydroxyl amine.
Yes. What is the name? So sir, just let us just discuss.
Yeah,
about
they will
what-
be
Tell me
getting.
the answers,
What
please.
is the answer when glucose react with the hydroxylamine?
And not only with the glucose, this is important for aldehyde chapter as well.
Aldehyde chapter.
Whenever
Sir,
they are
sir,
asking
in
hydroxylamine,
between that, one is asking, sir, can you write the mock exam in Brilliant tomorrow?
That-
Instead of that, one thing they can do, we will send all the question PDF in the group.
we can give them the sample
the
paper, sir.
sample
No,
paper, no
those who
problem, no
want
problem.
can write, no
You-
issue.
you-
We
you-
have
you-
enough
you-
sample
you can
papers.
come and
Any
write,
sample paper you can attend. That's
No
not
problem,
an
no
issue.
It's the
Just-
last moment, right? So no
Yeah.
need to waste for time for that one. Spend that
Three
time
instead
for
of that,
what
you have to
practicing
sit
questions.
Yeah,
That
it's
will be
our
better.
suggestion. Better to sit for 3 hours and learn things.
So what
Okay.
is the answers are they
Yeah.
giving?
So here it will be NH2OH now, so there
It will be CHOH.
NHOH. So that
This
will be
one,
oxide.
double bond and single bond,
Glucose,
oxide.
Oxide,
form.
oxide.
And this indicate that glucose contain a carbonyl group.
Carbonyl
group.
And
Yeah.
what about this one? This is our
C3CO
acetic
twice.
anhydride.
So-
you know, acetic.
That is pentacetate will be
So the
forming.
Yes.
acetate will be
Yeah.
forming.
Pendacetate. This is our
So CH3
CH3CO
acetic
twice,
anhydride.
That
Yeah.
already we
CH2OH.
discussed.
Yeah.
OCOCH3
okay.
and
Then here it will be
CHOCOCH3. That's a
4
4 times.
times. Then
and we
here
have
it will be
CHO.
CH.
This is called
CHO.
glucose
Pendacetate.
pendacetate, which indicate that glucose contain 5 OH
5
groups.
OH.
Yeah, that is the conclusion of that reaction.
Correct. Write the structural difference between
starch and
starch and cellulose. What is the structural difference between starch and
They are learning
cellulose?
directly. They are learning.
Yeah, starch
Starch
has
is made up of
alpha D glucose
Alpha D glucose.
And this is
and
what?
this is beta D glucose.
Beta D glucose.
And starch has
having
two components, amylose, amylose and amylopectin.
Amylopectin, right? Amylopectin. Whereas cellulose only that one component beta D glucose,
Yeah.
and it's a linear one, it's branched
one.
and the bonding also we can say,
C1,
right?
C4.
Yeah,
And
it's a alpha 1,4 dash glycosidic linkage is there,
Here it is.
whereas here
Here it is
beta 1,4 dash glycosidic
glycosidic
linkage.
C1,
Here one
C4.
more is there, right?
Yeah, C1, 1, 6.
1,6 dash also
1,6
we can
dash
say.
glycose.
Which one? This is in amylose.
Amylose.
This is in
Yes.
amylopectin.
Yeah, C1 and C6 for the branching.
Yes.
Branch.
Yeah.
And there's a simple question: what type of linkage is present in nucleic acid?
It's
It's
called
a
Yeah.
phosphodiester linkage. Right?
Nucleotides.
Asking whether we have to draw the phosphodiester ring.
No.
No need to draw.
That all bio type, that type of question and all don't
That's
expect
it,
over
that's
here. Just the mention the.
Give one example each for fibrous
Fibrous and
protein and
globular
globular
protein.
protein. Fibrous protein, you know, when two protein chain running parallel, they held it together by hydrogen bond, become
It's
fiber-like,
called-
called fiber-like
yeah, fibrous,
protein.
yeah.
Globular protein mean a long polypeptide chain undergo
Folded
coiling,
and twisted to form like a
becoming
coil.
global, right?
Yeah, it's
Fibrous
yeah.
proteins are example. I think we discussed too, right? Which
Yes.
all
Keratin
and which one? Myosin.
myosin in muscles.
Whereas
Yeah.
globular proteins, which all?
Now that one, insulin.
and albumin, right? The egg
yeah.
protein.
Egg albumin. Yeah,
Yes,
insulin.
given right?
Yes.
Myosin, right?
Yeah.
Good, sir. Yeah.
Give
Yes.
one example, okay, that we did. Next question. 98, we
98,
are approaching
98,
to
yeah.
our
The
last
last
question.
Second last question we have.
What is
Essentially
essentially the
difference between alpha D glucose and beta D glucose.
alpha D glucose and beta D glucose?
See,
what we
here
call?
we can say that anomers.
Anomers.
They are
Anomers.
asking indirectly. Yes.
Anomers are the isomers of carbohydrate where only one carbon configurations are different.
Different.
You know, alpha
Orientation of OH group will be different.
Different.
Yeah.
You know, alpha glucose and beta glucose in which the first carbon, C1
Yes.
carbon, the
OH
configurations
OH
are different.
Arrangement of OH is different.
If with OH on right side, it's
Yes.
alpha.
Alpha.
If OH on left side,
It
it's
is
called
called
beta.
beta. Haworth means while down it will coming and one will be up.
Yes.
It's same only. Yeah.
And what is mean by pyrano structure of glucose? We
Glucose
know
will be
pyran
compared with the
heterocyclic
pyran. Yeah.
compound we are
Cyclic structure.
using.
It's cyclic structure.
Right, pyran ring we are using to make what the Haworth
Similar by
representation.
Right. They know.
Haworth
Glucose
representation.
and this one has the similar structure.
Yeah. And the glucose we are using
It's called-
pyrano structure, whereas fructose we are using furano
Furanose
structure.
structure.
Don't
Yeah.
forget here.
Furanose.
I think 99 second last question.
Yes,
Yes.
last question.
Yeah.
Write the
99.
main structure difference
Difference
between
between
DNA,
DNA and
RNA.
RNA.
Structure difference DNA, RNA.
DNA is there,
what?
RNA is there.
DNA is the double-stranded one, whereas RNA is
And
the
it's a single-stranded
single-stranded
one.
DNA has nitrogen bases adenine. You can write
thymine, whereas
guanine
with the
triple bond cytosine.
And here the
And
bases
here
are A, T, G, C.
C. And
Whereas
here
A,
A,
U, G, C.
C. Yeah.
And
Uracil.
DNA, the pendo sugar, you know, different. RNA, pendo sugar,
Yeah,
different.
that all you can
Yes,
write.
yes.
Yes.
That's it.
Yeah.
And what is the other question?
Name those
of
which
the
are
four?
common to both DNA and RNA.
Yes.
Which all are common? A, G,
G,
C.
C.
A,
And here
G, C.
C.
These three are common in
Common.
both
That's
DNA
right.
and RNA. Yes, sir.
Yes, sir.
Let's go to the final
last
one.
one.
Last
one we will
Right.
be doing it. Yes.
So 100th
Are you guys ready?
Exactly, I think around
Yes.
9.
Yes.
9
6
o'clock.
hours is going
6
to come.
hours.
Exactly.
Yes.
Yes, great,
So
great.
describe what you understand by primary structure and secondary structure of protein. You know,
Yeah, that structure of protein, one question you can expect.
Yes.
It is important.
you know, it is the specific and sequential arrangement of various amino acid in a
Acids.
protein chain
Protein chain,
called
yes,
the
called
primary
Primary
structure.
structure.
And the secondary structure are of two types, which all?
Alpha helix and
Alpha helix.
helix
and beta pleated.
Beta pleated structure. You know, alpha helix means what? That long chain, peptide chain undergo what? Hydrogen bonding and coiling.
Yeah.
Whereas beta pleated means they stretched
Stretched
it to
out
its
to a maximum
laid side
extension.
by side, connected
Yeah.
through hydrogen bond. And sir, we
Both
can
are-
definitely yes.
Yeah, both are stabilized through hydrogen bonding that they asked in so many question
that's
paper.
the important one.
That is
the
important.
bond
You have to-
stabilizing the alpha helical structure of protein. That's what hydrogen bonding.
Hydrogen bonding. Yeah.
Sir, I think vitamin part we can just describe it now
Just to-
because
yeah.
we can expect
Yeah,
that one.
Just we can tell the deficiencies we can tell.
Let
Yeah,
them
which all
tell.
vitamin. Yeah. So we will tell the vitamin. You should tell the
them
deficiency.
That's the last
Okay,
competition
that's the last-
between
yeah.
us.
Okay.
So tell me vitamin A we are not asking that
Yeah,
you know
that is
night
the easiest
blindness
one.
and
Okay.
serophthalmia.
Serophthalmia.
Yes,
Vitamin B1, what is the deficiency?
Yeah.
Can you say?
Tell me, come on,
Vitamin
everybody.
What
B1.
is the B1? What is
Vitamin
the
B,
B1
vitamin B.
deficiency causes?
I think bio people
Vitamin
are there,
B.
so they will be so excited now. B1, tell the answer.
Vitamin B1, yes,
Very,
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 very.
Yes.
Very.
Yeah.
Very.
B1.
That is
Okay.
B1.
Yeah.
Yes,
Vitamin
great.
B2. What is
B2.
vitamin B2?
B2. Yes.
Vitamin
B2 give the
B2
answer.
causes
B2 causes, come on.
Yeah.
Very over. That is only for vitamin B1. What
Yes.
about B2?
B2
Kelosis.
yes. Yes.
coming
Kelosis.
kelosis.
Well done.
B2
Yes. Kelosis.
kelosis. Good all
B6,
of you.
yeah.
Next
Good,
stop.
great.
What is next one? B6.
B6 we will go.
So they are telling
B6,
don't
sir.
underestimate computer science students.
Ah,
Okay, they are not
no,
understanding.
not at all.
That's the thing. That's the spirit, guys.
You
okay?
can score 60
Nice.
marks. No
Really
issue.
nice,
Yeah.
nice. Okay.
Yes. Kelosis.
Kelosis.
Yeah.
Yes. Vitamin
They are
B6 what?
B6 is
Conversion.
convulsions.
Everything they are
Conversion.
telling.
Yes.
Vitamin B12, you know,
Now
cobalt.
12.
What is that?
Cobalt.
Vitamin B12.
Vitamin
B12.
B12.
Something
B12.
with anemia. What
Yeah.
is that? Something
Pernicious.
with anemia.
Pernicious
Pernicious anemia.
Yes,
Very
very
good.
great to see.
Pernicious
And last
anemia.
left, I think vitamin D is there.
Vitamin D.
Vitamin D.
Vitamin D.
Something
D.
related to bond.
Yeah.
Vitamin D.
Something related
Vitamin
to
D.
bond.
Vitamin
B.
C we did not ask.
Ramanujan
Right?
again
Vitamin C
came.
we did not ask.
Ramanujan
Yeah.
came.
Ramanujan
Yeah.
came back.
Yeah.
Yes.
Came.
Scurvy,
So what is that?
scurvy.
Then what is
Vitamin
that?
D, rickets.
Yes, scurvy.
C
That
for
is C,
scurvy.
that is
D
C.
for rickets.
Yes.
D for rickets.
Actually we
D for
forgot.
rickets.
Yeah, C we
for
missed.
scurvy.
Yes, very good. Vitamin C, scurvy. Vitamin D, rickets.
rickets.
Vitamin
Vitamin
E.
E.
What about vitamin
Vitamin
E?
E.
Muscle,
That's a major
yeah.
problem.
I think we need that one more now. Right. It causes vitamin E
Yeah.
causes vitamin
Causes
E
E.
deficiency causes E.
Yeah, muscle.
Muscular
Weakness,
Muscular.
yes.
And last one, which
Yes.
one? Vitamin K.
Yeah.
Vitamin K
Vitamin
related
K.
to what?
Muscle weakness. Yes. Vitamin K.
Vitamin K related
Yes,
to
blood-
something related
Yes,
to
RBC
yes,
fragility.
RBC fragility.
Or
Yes,
blood
yes,
clotting, you can say blood
And
clotting.
sir,
Right.
Before that, one more thing we have done. We already promised them. We will tell
Write
a shortcut to write the aldol condensation.
Yes, yes.
Okay. So
I
one
think,
I will
DK
write.
will do it,
Aldol. Yeah, aldol condensation I will write.
C3 CHO you do it, sir.
Yeah, one question. I think we finished 100 questions,
Yeah,
right?
100 questions.
Guys, thank you so much. And an additional thing we are going to do. Few students asked about the
Only then after we have to wind up.
Just
Don't
one
go,
thing,
don't go.
okay.
We have to
Yeah.
wind
Please
up. We have to
wait
tell
on
something
something.
more.
Want to
Okay.
say something.
We have to tell something more only. Aldol condensation
See,
also you
yes,
know,
sir.
sir.
any compound, if they are asking aldol condensation means, you can write like this one, okay? Aldol condensation. See, aldol condensation, any compound if they are giving, this is the easy way, I think, CH3, CHO if they are giving, okay, 2 molecules will participate. So better idea is you write the plus sign and one more molecule will take. When you take any one, whether it is aldehyde or ketone, from the second molecule you take out the alpha hydrogen. What is alpha hydrogen? This is the functional group and this is the alpha carbon. Take out one alpha hydrogen and you write the CHO.
Yes.
And you write dilute
Dilute
NaOH.
NaOH.
Okay. And what you need to do is, you can write like this one, this H
That
will
one
go
I have
to
to take
oxygen.
this, yes.
After that, these two parts will join. Okay, any compound. So you will be getting the idea like this one, CH3, CHOH, then it
And
will go
CH2,
directly
CHO.
to CH2, CHO.
Then
You know
beta
that one, this is
hydroxy
called
aldol.
3-hydroxybutanol. And
Beta
after that,
hydroxy.
yeah, beta hydroxy. This is alpha and this is beta. Beta hydroxy will come. When it is
Elimination
heating,
alpha, hydrogen is
that I
removed.
think you have idea. This is the OH. And
that will
according to Setsaf rule, should not remove hydrogen from this one. Here we will take hydrogen. Then you will get the compound
double
CH3,
bond,
CH, double bond CH, single bond CH.
That's it.
So instead of this one, if any other compound, if they are giving, for example, CH3, CH2, CHO, okay, then what you have to do is, this is the alpha hydrogen, then you have to do like this one, CH3, CHH. You understood the idea? This is the alpha hydrogen. Then this will be CHO. Then this will join over here. Okay, same way. Then you know how to proceed. Hope you understood.
Right.
Okay.
And aldol, the second name also, don't forget, maybe a MCQ can be expected what? This is alpha,
Beta
this is
hydroxy
beta.
aldehyde.
Yeah,
Beta
beta.
hydroxy
So,
aldehyde.
That
That's the
conversion
thing.
also they asked in so many cases, beta hydroxy and all. Okay. It's
So,
very important.
6 hours journey is going to finish.
I think,
guys.
sir, it's
Right.
exact 6 hours.
Exact 6 hours. So
Yeah.
the thing is that don't forget to subscribe our
Yeah.
channel. You have to suggest the channel to your friends also.
Yes,
Physics
tell
team
everyone.
also ready.
I think, sir,
Physics team also
yeah,
ready.
Yeah,
Yeah,
see,
yeah.
these 6 hours are challenge maybe break. Okay, coming days for the
They'll-
other
they'll
subject
break.
also people are ready.
So we hope-
subscribe the channel.
And
Okay.
suggest it to your friends also. We hope this much is the session was that much beneficiary for you. We hope so. Okay, sir.
And
anything to tell?
finally, we want to see their love,
Affection.
what they have within the 6 hour, whether it is benefit.
That
whether
you have to
it
show
is
it in the comment
useful or
box.
not.
Come on, come on, come on.
Yes.
Please tell me, all of you,
Yes,
that
yeah.
through your comment, can you please
Yeah.
give in the chat box your
Yes.
what all things you
What all
feel
emotions
about
you are
this class.
feeling?
You
If
can
you want to
comment in
type
the chat
also, you
box.
can type it in the comment box. We are
Right?
waiting.
So
We are waiting. Come on, come
And
on.
I
yeah,
think
don't
we
worry,
don't
sir.
waste their
Yeah,
time.
don't worry,
Yeah.
students. We will be with you.
Yes.
Okay, before the last moment of
All
your
right.
exam, we will be with you.
Yay.
Yes.
So the
Thank you so
guys,
much. This is for you guys.
Right.
this for you. All the very best. Do
And,
your best.
Yeah.
So write
So
the maximum
come up with
content.
flying colors, and we will be expecting a very good result. And thank you so much. Thank you so much.
Yes.
Love you all.
Right.
Bye bye.
So good night, all of you. Thank you once again from behalf
Yeah.
of Brilliant Group of Institutions. So we all are happy
Yeah.
to say that I think around 90 students are keep
on
Yeah.
staying the
Okay.
online around 6 hours. So love you all and wish you all the very best from our bottom of heart. We will
Thank
pray
you so
for
much.
you.
Yes.
That's
Bye-bye.
our rest of our duty.
Bye bye bye. Study well.
Thank you.
Thank you
Bye.
all.
All
and
the best.
keep
all
the
best.
keep practicing. Thank you all.
Hi everyone. Welcome to
Amazing channel of Brilliant Katha.
When you're rubbing one body with another body, electrons are transferred from one object to what? Another object. Okay, this process, this type of electricity is been given a name.
Halogen connected carbon sp3, then it's connected to benzene. See all of you, halogen connected. What is this carbon hybridization? Full single bond sp3, see then a benzene ring.
Denominator poles shouldn't be included in the denominator poles. That means the denominator, these -1 and -5 should never be included in the solution.
Homocircle caudal fin. It's giving two equal lobes. But in case of cartless fishes, look at here, one big lobe is there, one small lobe is there. You cannot cut into two equal half this fin.